Thank you for choosing American Pest CEUs. Hi, I'm Sean Reeves. I'm an Associate Certified Entomologist with American Pest CEUs. I've been in the pest management industry since 1999, and I'll be your instructor for today's course. Today's course was compiled by Jack Launius, who has served in the pest management industry since 1990. We only have one planet. In today's course, we're going to talk about pesticides in the environment. After studying this chapter, you should be able to describe how pesticide applications can affect the environment, explain how to prevent pesticide drift, runoff, and movement to non-target areas, identify sensitive areas that could be harmed by pesticides, discuss how to prevent pesticide residue accumulation associated with mixing, loading, and equipment washing, state when to adjust or delay an application to minimize environmental impact and maximize effectiveness. Applicators and the public share concerns about how pesticides may harm the environment. Initially, hazards to humans were the primary reason. The U.S. Environmental Protection Agency, EPA, decided to classify a pesticide as a restricted use product. Now, more and more pesticide labels list environmental effects, such as contamination of groundwater or toxicity to birds or aquatic organisms, as reasons for restriction. To register new pesticides, EPA requires manufacturers to submit extensive environmental tests. The agency also reviews environmental effects when reevaluating existing pesticide registrations. The environment. The environment comprises everything that is around us. It includes not only the natural elements that the word environment usually brings to mind, but also people, the manufactured parts of our world, and the indoor areas in which we live and work. The environment is air, soil, water, plants, animals, houses, restaurants, office buildings, factories, and all that they contain. Anyone who uses a pesticide, indoors or outdoors, in a city or on a farm, must consider how that pesticide affects the environment. So there's some really good points here. Obviously, we have to understand the environment is everything around us, and not only is it everything around us, but it's our responsibility as pesticide applicators to protect that environment. So each time you're planning or thinking about doing an application, you need to really think about the environment around you, and you need to keep in mind what's around and what issues you need to be concerned about in that surrounding environment. As we go through this course, we're going to detail a lot of things about the pesticide use in the environment and how we can all do better to protect it as pesticide applicators. The environment. Applicators must ask 3 questions. Where will the pesticide go after it leaves its container or application equipment? What effects could this pesticide have on those non-target sites it may reach? What can I do to minimize harmful effects? Pesticide characteristics. To understand how pesticides move in the environment, you must first understand certain physical and chemical characteristics of pesticides and how they determine a pesticide's interaction with the environment. These characteristics are solubility, absorption, persistence, and volatility. And you're going to really need to understand all 4 of these terms. Any of you taking core exams in any states are definitely going to hear terms like solubility, adsorption, persistence, and volatility. So just keep in mind those 4 terms are going to be very important as we go through this course. Let's start off by talking about solubility. Solubility is a measure of the ability of a pesticide to dissolve in a solvent, usually water. Pesticides that are highly soluble in water dissolve easily. These products are more likely than less soluble pesticides to move with water and surface runoff or through the soil. So there's some really good points here. Solubility is going to be that measure of the ability of a pesticide to dissolve in a solvent, usually water. So what that says is, just right up front, if you're putting a product out that's water soluble and you know there's rain in the forecast, what are you really doing? You're putting out there the potential for that pesticide to get carried off target. So it really doesn't make sense for us to put a water-soluble product out when there's going to be rain or something like that. Now you'll notice on a lot of pesticide labels, it says do not put product out when rain is imminent in the area. And this is the exact reason why. Now obviously products that are more soluble are going to move quicker with water than ones that are less soluble. So these again are going to be based on formulations and mixtures. So as you're studying pesticides, make sure you understand how mixtures and formulations relate to solubility with the product. Another important term in today's course is going to be adsorption. Adsorption is the process whereby a pesticide binds to soil particles. Absorption occurs because of an attraction between the chemical and soil particles. Typically, oil-soluble pesticides are more attracted than water-soluble pesticides to clay particles and organic matter in soil. Although pesticide molecules with a positive charge are tightly absorbed to negatively charged soil particles, a pesticide that absorbs to soil particles is less likely than one that does not absorb tightly to soil to move from the spray site. With absorption, we have to think about this. We have to understand what types of mixtures are going to be more likely to attach to that soil or bind to it. So we already talked about that those oil-soluble pesticides are more attracted than the water-soluble pesticides to clay particles and organic matter in soil. So we already know something that's oil-based is going to absorb to that soil better than a water-based product. And just note, a pesticide that absorbs to soil particles is less likely than one does not absorb tightly to soil to move from the spray site. Many things we're looking at when it comes to pesticides has to do from runoff. Will the product run off to a non-target area? And as we think about it, absorption is one of the biggest factors in this. So once again, you have to watch your formulations. You have to understand the absorption rates of the products and understand what's in your surrounding area. If you're by a body of water or you're by a storm drainage sewer, you need to understand that if you don't have good absorption, when it rains, that product could very easily be carried off-site and end up in a lot of places you don't want it to. So just continue to study this absorption and how pesticides work with it. Another term that's very important in our core studies on pesticides is going to be the word persistence. Persistence is the ability of a pesticide to remain present and active in its original form for an extended period before breaking down. A chemical's persistence is described in terms of its half-life, a comparative measure of time needed for the chemical to break down or degrade. The longer the half-life, the more persistent the pesticide. The pesticide that remains in the environment after an application or spill is called residue. And again, this is a very important term, this term persistence. Any of you taking core exams in any of the states, as I always say, there's going to be certain things on there, and the term persistence is usually on there. And just understand that persistence is that ability of a pesticide to remain present and active in its original form for an extended period before breaking down. So you'll hear people talk about how persistent is a pesticide or how long does it last. So there's another word you're going to hear about as you go through these studies called residual. Is it a residual product? Well, the persistence of the pesticide in the environment is going to tell you a lot about how long the residual is. Just keep understanding that persistence is how long it lasts out in the environment, and also understand that persistence is very important because the persistence of the pesticide has a lot to do with pollution, runoff, and things like that related to the pesticide being active for a long time. As you can imagine, the longer a pesticide is persistent in the environment, the more the chances are it could do harm to that environment. Sometimes residue is desirable because it provides long-term pest control and reduces the need for repeated applications. However, some persistent pesticides can harm sensitive plants or animals, including humans. Therefore, it is especially important to prevent persistent pesticides from moving off-site through improper handling, application, drift, leaching, or runoff. I like this term residue here because the reality is it does provide more long-term pest control. So that persistence and that residue left behind is providing us with longer-term pest control. And we need that because we don't need to make repeated applications all the time. So you hear a lot of people say when they're doing a pest control or weed control service, we come out monthly, we come out every other month, or we come out quarterly. The reasons why that is because the product's going to last for a specified period of time, at least in theory. We know other environmental conditions like rain and other things can break them down. But the point is, we need this residue and we need this residual effect. You can't do a quarterly pest control service if the product only lasts 2 weeks. So there are some good things with these residues. We just have to understand they can also harm sensitive plants or animals, including humans. So we have to make sure that they don't move off site. We've already kind of talked about that. But you definitely don't want these pesticides moving off site through things like improper handling, application, drift, leaching, or runoff. And these are things you can learn about by reading the label and just understanding your formulations and different types of products. Obviously, through handling, you don't want to have a chemical spill or anything like that. But when you think about drift, I mean, that's a whole nother issue. If the wind's blowing 30 miles an hour, do we really want to use a ULV product that's just going to be picked up by the wind? Absolutely not. And of course, the leaching down through the soil, which we talked about a little bit earlier, is that product going to leach right through the soil? Is it a sandy soil where it's just going to leach right down to the water table? Or is it more of a clay and more highly organic soil where it's going to bind more through that absorption? So just keep in mind, you're going to continue to hear these different terms and you have to continue to study them in your pesticide career. Besides presenting a hazard to persons and non-target animals entering a treated area, the application of persistent pesticides may produce illegal residues on rotational food or feed crops. To protect consumers, there are legal limits on how much residue may remain on products sold for food or feed. Check the label statements about the persistence of the pesticide and for replanting restrictions. The rate of pesticide breakdown relates to the persistence of the pesticide. So keep in mind, those of you dealing with food or feed crops, you have a whole nother responsibility here. You're trying to protect consumers, so there's going to be legal limits on how much residue may remain on products sold for food or feed. So you have to understand what those are. If you're out applicating with pesticides, herbicides, things like that, if you're putting too much on there and that gets tested and the level's too high, that's something you're not going to be able to sell. So there's a really big responsibility, obviously protecting human health with that, but also for your crop itself. If you put out too much and that crop is no good, at that point you're not going to make any money on it. And those of you that are in agriculture, I know it's very hard to turn a profit at times anyways. You definitely don't want to deal with something like this. The other thing you do need to check is the persistence of the pesticide and for replanting restrictions. So when you use a pesticide in an area, if it says you can't replant there for 6 months, don't replant in that area. That means that product will probably get picked up by the new plants. It'll be systemic. And then once again, if that product gets picked up, then all of a sudden you're dealing with a higher level because you're going to go and you're going to do your pesticides again. The problem is it's already in the soil, so now you're doing another pesticide application, and in that agricultural product or plants picking that up. So now you've got more pesticides in that plant than there should be. So just keep in mind that that's something you have to be aware of, especially in agriculture. The other thing that's important here is the rate of pesticide breakdown relates to the persistence of the pesticide. So you have to understand how quickly it breaks down relates to the persistence. So something that breaks down quickly is not really a persistent pesticide, whereas something that could stay in the environment for weeks, months, even years, then we're definitely dealing with a persistent pesticide, and we need to be very careful and understand the impacts of that product. Pesticide breakdown. Several processes break down pesticide compounds into simpler and often less toxic chemicals. Some pesticides break down very rapidly, in a matter of days or even hours. Others linger in the environment for a year or more. Pesticides are broken down or degraded by the following processes. Chemical degradation. The breakdown of chemicals that do not involve living organisms, usually by a chemical reaction with water. Microbial action. The breakdown of chemicals by soil microorganisms, such as fungi or bacteria. Photodegradation. The breakdown of chemicals in reaction to sunlight. Water and temperature both affect the breakdown of pesticides. Warm, wet conditions can increase the speed of pesticide breakdown. Cool, dry conditions slow down the degradation process. We should look for places to use pesticides in areas where they are less likely to be affected by rain or sunlight. This is a good first step when slowing down chemical and photodegradation. And just to give you a quick idea here, you might want to put pesticides in areas around a house on the exterior, like in the eaves or in the soffit areas. I understand you have to think about drift and wind and things like that, but if we can get the pesticides in areas where the rain and the sunlight is not going to hit them as quickly, they're going to last a lot longer. So just keep in mind where we put the products has a lot to do with this chemical and photodegradation. Another idea is when you're performing an interior service, treating somewhere like a wall void can be a great way to make sure our products are not subjected to unnecessary water from house cleaning. Also, this would help with photodegradation. So again, we don't have to worry about chemical degradation, we don't have to worry about photodegradation, because we're putting the product in an area where it's not going to come into contact with anything. The other good part about it is as well, is that product is going in an area where humans or non-target animals aren't going to touch it either. So any way you look at it, when you do put these products in the right areas where the rain, sun, and non-target animals and species won't contact them, you're always going to win. They're going to be more effective for a longer period of time, and they're definitely going to be more safe as well. Next, we need to look at volatility. Volatility is the tendency of a pesticide to turn into a gas or vapor. Some pesticides are more volatile than others. The chance of volatilization increases as temperatures and wind increase. Volatility is also more likely under conditions of low relative humidity because evaporation increases in drier conditions. What we're saying here is with volatility, and you definitely want to understand this for core exam questions, some pesticides are always going to be more volatile than others. What we're saying here is, and you're definitely going to want to understand this about volatility when it comes to core pesticide exam questions, volatility is definitely that tendency of a pesticide to turn into a gas or vapor. So basically what the pesticide's doing is it's just vaporizing up into the air. Now the chance of this is going to increase as temperatures and wind increase. So we have to understand that volatility is going to be higher as the temperature and the wind increases. I see that on a lot of core pesticide exams. Also, it's very important to note that volatility is going to be more likely under conditions of lower humidity. So that drier air is going to cause evaporation, kind of like a lake or something in the desert, right? You know, when it gets really hot and it's dry, that water just continues to evaporate, and that's why we don't have a lot of lakes and things like that in deserts, because of the fact that that evaporation just pulls that water up into the air. And it's no different with the pesticide. Those mixtures are the same way. As that heat increases, as the humidity gets lower, it's just going to volatilize or vaporize up into the air a little easier. In our next section, we're going to look at how pesticides move in the environment. Pesticides may move from targeted application site in several ways: in air, in water, attached to soil particles, and on or in objects. Let's talk about movement in air. Pesticide movement away from the application site by wind or air currents is called drift. People who mix, load, and apply pesticides outdoors are usually aware of how easily pesticides may drift off-site. Those who handle pesticides indoors may not realize how readily some pesticides move off-site in the air currents created by ventilation systems and by forced air heating and cooling systems. Pesticides may travel off-site as spray droplets, vapors, dust or solid particles, and even on blowing soil particles. So we have some simple concepts here. Obviously, wind or air currents can pull pesticides into the air. This is called drift. So that drift is one of the easiest ways for pesticides to be carried off-site into non-target areas. Some key points here are the fact that people who mix, load, and apply pesticides outdoors are usually aware of how easily pesticides may drift. I'm just going to use an example. If you have a dust product and you try to mix it outside and you pour that dust into like a puff duster bottle or something like that, you're going to see that dust kind of disperse up into the air. And just think, if the wind's blowing hard, that's really going to get carried off quickly. Now, these dusts can be highly toxic for things like honeybees, so we really have to think about when we're doing a product mixture outside or we're using a product, what that wind is like and how it can affect those non-target areas. An interesting thing here that I think most people don't think about is the fact that ventilation systems and forced air heating and cooling systems can also move pesticides off-site. So these types of systems are basically taking air from inside your home and exchanging it with outside air. So there is the risk of the fact that those air systems could pull pesticides into the air from inside your house by removing and exchanging that air. And just remember, pesticides can travel as spray droplets, vapors, dust, or solid particles. Understand that there's many different ways. We talked about the vapors, but the dust or solid particles, obviously, we talked about the dust. And solid particles could even be something like soil that has pesticides on it being blown by the wind. Those of you that live in the central part of the U.S. are used to those heavy winds. You have these different wind storms, dust storms maybe some people call them. But at the end of the day, think of it like this. If that dust is getting picked up and it's had a pesticide application, what are we having? We're actually having that dust get carried away up into the air with the pesticides on it, which of course is going to take it to non-target areas. Next, let's talk about movement in water. Most pesticide movement in water is either by surface movement off the treated site, runoff, or by downward movement through the soil, leaching. Runoff and leaching may occur when too much pesticide is applied or spilled onto a surface, too much rainwater or irrigation water moves pesticide through the soil, off-site, or into groundwater. Highly water-soluble or persistent pesticides are used. On this slide, we've introduced another term that we mentioned briefly earlier. The term is leaching. This is going to be the downward movement of the pesticide through the soil. You're definitely going to want to understand what leaching means because, again, this will be on a lot of your core exams. Now, when we talk about runoff and leaching, as we have here, just understand, if you use too much pesticide on a surface, this is going to be a problem. Obviously, if you spill it, it's going to be a problem as well, because then it would be concentrate, and we could have another big mess on our hands. Too much rainwater irrigation is another way that the water moves the pesticide through the soil, and it can go off-site and even into groundwater. Highly water-soluble or persistent pesticides being used, so just keep in mind, if you're using highly water-soluble or persistent pesticides, the chances of them moving in water are going to be a lot more. Runoff water in an outdoor environment may move into drainage systems, streams, ponds, or other surface water where the pesticides can travel great distances. Pesticides that leach downward through the soil may reach groundwater. In an indoor environment, water containing pesticides can flow into floor drains and contaminate water systems. A careless act, such as dumping a pesticide or rinsate down a sink or toilet, may contaminate an entire sewage or water treatment facility. Some pesticides can leach indoors. In a greenhouse, for example, pesticides may leach through the soil or other planting medium and contaminate other greenhouse surfaces. Look for special instructions on the label that warn of pesticide hazards caused by the movement of pesticides in water. Sometimes labels require buffers or setbacks from water and wells. One quick thing on this slide you do want to know, make sure you understand on your pesticide labels and your state laws what the setbacks are going to be from water and wells. A lot of your pesticide labels will mention water and wells, and if you don't look at those labels and understand what the setbacks are, you're going to misapply those products, and then you're in risk of contaminating water and wells, which is definitely something you don't want to have to worry about. Take a few moments to review this diagram. This diagram shows various ways chemicals break down or move or translocate to other areas. So how else can pesticides move? Movement on or in objects, plants, or animals. Pesticides can move away from the application site when they are on or in objects or organisms that move or are moved off-site. When pesticide handlers bring or wear home contaminated personal protective equipment, work clothing, or other items, pesticide residues may rub off on carpeting, furniture, and laundry items, and onto pets and people. One thing that I would note from this slide is the fact that your work clothing is a major issue. When you've been out doing pesticide applications, make sure you take that clothing off right away and make sure you launder it away from other clothing. Don't go sit down on your couch and other areas in your home and get those pesticides spread on your furniture. That's definitely something you do not want to subject you or your family to. Preventing pesticide drift. Studies have shown that a sizable percentage of pesticides may never reach the intended target site because of drift. Significant drift can damage or contaminate sensitive crops, poison bees, pose health risks to humans and animals, and contaminate soil and water in adjacent areas. It is impossible to eliminate drift, but it is possible to reduce it to a tolerable level. Let's talk about spray drift. Spray drift refers to the off-target movement of a pesticide during a liquid application. This is the result of small spray droplets traveling off-site on air currents. Spray drift occurs more frequently than vapor drift or particle dust drift. You can avoid most spray drift problems by paying close attention to spray droplet size, wind direction, and wind speed. Large spray droplets are less likely to drift than smaller ones. Selecting the proper nozzle and pressure is important to reduce drift. High pressure and nozzles with smaller orifices or openings produce small droplets likely to drift. Conversely, large nozzle orifices and low pressures produce larger droplets. So when we talk about spray droplet sizes, just remember your nozzle is a big part of it. If you've got a smaller nozzle with higher pressure, you're going to get smaller spray droplets that are more likely to drift. Now conversely, as we talked about here, you get a larger nozzle with a bigger opening and even lower pressures, you're definitely going to have larger droplets. And as you can imagine, those larger droplets are going to be heavier. So with the wind, there's less chances it's going to drift. Now, you got to understand what the wind is before you do an application anyway. So if it's a really high windy day, you can have a problem with either one of these. But the point we're making here is just remember, smaller nozzles, higher pressure is going to be smaller droplets that are going to drift easier. Larger nozzles with lower pressures are going to be bigger droplets that aren't going to drift as easily. Classification of droplet size. Nozzles produce a range of droplet sizes, known as the droplet size spectrum. Regardless of the type of nozzle used, a percentage of droplets created by a nozzle will be small enough to drift. Modern nozzle designs are excellent options because they reduce the amount of droplets prone to drifting during an application. A droplet size classification system can help describe the droplet sizes produced by a nozzle. This standard, S572.1, Spray Nozzle Classification by Droplet Size, established by the American Society of Agricultural and Biological Engineers, classifies nozzles into 8 categories. Using these categories, you can select a nozzle, orifice size, and operating pressure that produce a label recommended droplet size spectrum. Consult the label for the droplet size specifications that may be in place for a particular application. This chart gives you the information to select the proper nozzle for an application. Brass spray tips typically have the size stamped on the end, while plastic tips are color-coded. Please take a few moments to review this chart. Thus reducing the chance of off-target movement. Fine spray droplets may begin to evaporate before reaching their target. These droplets become very small and light and may move off-site. Modern drift control additives will decrease drift potential without dramatically shifting the droplets to a larger size. Remember, however, to always follow the label directions about using a spray adjuvant intended to minimize drift. Some drift control additives may actually increase the drift potential of an applied tank mix. Also, be aware that large spray droplets may reduce coverage, resulting in less pest control. Other factors. Wind speed and direction are the most important environmental factors influencing spray drift. Labels may indicate maximum and minimum wind speeds for application. Except in the case of temperature inversions, see below, the early morning and evening are often the best time to apply pesticides. This is because windy conditions are more likely to occur around midday when the temperature near the ground increases. This causes hot air to rise quickly and mix rapidly with the cooler air above it, favoring drift. The best time to spray is when spray droplets move slowly upward in the absence of windy or inversion conditions. Quick thing you want to note on here is early morning and evening hours are definitely the best times to apply pesticides. I understand a lot of you can't do that. You got a lot of customers to take care of. You're busy out in the field. So if you can plan pesticide applications around those times, at least as much as possible, it's better. Especially in the summertime when it's really hot in the midday. It's better if you keep your schedule a little busier earlier in the morning and even a little more towards the evening. It's better for things like heat stress as well, because if you're out there working and the heat index is up in the hundreds, you also can have problems with heat illness. But I understand it's tough when you run a business out there. Just try to do applications around those times of day as much as possible. Low relative humidity and/or high temperatures can also increase the potential for spray drift. Under these conditions, the evaporation rate of water increases, resulting in smaller spray droplets that drift more easily. Avoid spraying during these times. The height at which the pesticide is released above the ground or target may also affect drift. Applications that use large droplets close to the ground often produce little drift. Aerial spraying and tall tree spraying, on the other hand, are more likely to produce spray drift because they intersect large distances of air far from the ground. Drift from boom sprayers can be reduced by lowering the boom height to within 20 to 24 inches of the target crop. We talked about this earlier. Lower RH, or relative humidity, and high temperatures are going to increase that potential for spray drift. Not to mention the fact that volatilization is going to be even heavier during these times, as we talked about earlier. You would easily understand as well, if you're doing an aerial application from a plane, obviously, because that product's being released from that high in the air, the chances of drift are going to be pretty heavy. So that kind of goes without saying. But let's say you're treating trees or something like that. You're treating way up in the air. Maybe you're applying 15, 20, 30 feet from the ground. Obviously, again, it's a lot easier for you to have drift issues when you're treating that high up in the air. So as much as we've talked about this, we need to talk about how to decrease the outdoor drift. We can decrease outdoor drift by spraying when the wind speed is between 3 and 10 miles per hour, spraying downward from sensitive areas such as residential properties, schools, crops, waterways, or beehives, using proper nozzles and pressures, using drift control additives if appropriate, lowering boom height, leaving an untreated border or buffer area in the downwind target areas. We can also decrease outdoor drift by thinking about indoor applications. To reduce drift indoors, pest control operators must consider the air circulation patterns inside buildings. Turn fans and air conditioners off and close vents where necessary to prevent pesticides from drifting to other parts of the building. Use low volatile and non-volatile pesticides and low pressure treatments to reduce indoor pesticide drift. A temperature inversion is an atmospheric condition where the temperature increases with height. This could be described as a layer of cooler air near the ground trapped by a warmer layer of air above it. A temperature inversion exists when the air at ground level is cooler than the air above it. Under these conditions, the air is considered stable because there is little or no vertical air movement. Almost all air movement during an inversion is sideways or lateral. This causes a high concentration of small spray droplets to be suspended in this layer of cool air near the ground. These droplets can then be carried long distances, especially if wind speeds increase. When the spray droplets settle out, they may still be concentrated enough to cause damage or harm. Inversions may occur at any time of the day and at any height above the ground. However, they most often develop during the early evening hours as the ground temperature begins to cool and the warm air has already risen. And take a moment to look at the two images on this slide to see what that looks like. Inversion conditions intensify during the night and may persist until mid-morning when the ground is warm enough to start the vertical mixing of air, i.e. the wind starts to blow. This causes a dilution and separation of suspended spray droplets. Consequently, applications made during early evening, night, or morning hours under seemingly ideal conditions may result in highly damaging drift that can move long distances. This is especially true if the humidity is high. Such movement could occur up to 1 to 3 hours after the application. You can recognize these stable air conditions inversions by observing the movement of dust or smoke. If dust or smoke rises little from its source and tends to hang in the air, an inversion may be present or developing. Another way to detect inversions is to place one thermometer at ground level and a second thermometer high above the ground. Then compare the difference in temperature. If the temperature at ground level is below that found at the elevated thermometer, a temperature inversion exists. Do not apply pesticides under such conditions. When we look at vapor drift, this refers to the movement of pesticides as gaseous vapors from the target area. Some pesticides are volatile. They change readily from a solid or liquid form into a gas under the right conditions. This usually occurs in hot weather. Pesticides that have volatilized into a vapor or gas may drift farther and for a longer time than they would have as spray droplets. Only those pesticides that are able to volatilize are susceptible to vapor drift. As air temperatures increase, the likelihood that these pesticides will volatilize and drift also increases. Whenever possible, choose a pesticide formulated as a low volatility product. Do not apply volatile pesticides on hot days. Some products may even volatilize several hours after application, so be aware if high temperatures are predicted for later in the day. Many product labels advise against applying these products when temperatures are at or above 85 degrees Fahrenheit. Remember to check the label precautions for product-specific concerns about vapor drift. Particle drift, also known as dust drift. Particle drift refers to the movement of solid particles from the target area in the air during or just after an application. These solid particles may include pesticides formulated as dust or soil particles to which pesticides are attached. Some pesticides can remain active on soil particles long after they are applied. If particles are blown off the target site, sensitive areas may be contaminated or damaged. To prevent particle drift from outdoor pesticide applications from entering nearby buildings, Be sure to close all windows and vents. Turn off all circulating fans, forced air heating systems, and air conditioning units. For indoor pesticide applications, reduce particle drift by turning off fans, forced air heating systems, and other air circulating equipment. Check pesticide labels for statements related to these concerns. Couple of quick things to note here. If we're doing an outdoor pesticide application, we definitely don't want it to enter nearby buildings, so you need to look at things like windows and vents and just make sure they're closed. It'd be really easy for a product to drift into those areas. Also, we talk about here turning off circulating fans, forced air heating systems, and air conditioning units, because once again they're pulling air in from outside, they're exchanging the inside and outside air, so this is an issue that could bring the pesticides in. Now obviously for indoor pesticide applications, reducing that particle drift by turning off fans, forced air heating systems, and other air circulating equipment is helpful. Also think of it like this. If you were doing a service and you were putting a dust in an attic, like an insecticide dust, you would want these things turned off anyway. You don't want a forced air heating system or an air conditioning system running when you're putting a dust in that area, because obviously it could carry it throughout the house. We would definitely be remiss if we didn't talk about applicator responsibility. As an applicator, you are legally responsible for any damages resulting from the off-target movement of pesticides. Assess the vulnerability of neighboring properties and those areas downwind of the application site. Evaluate weather conditions for temperature inversions, wind direction, and wind speed before making the all-important decision about whether to spray. You may have to adjust your application equipment to reduce spray drift. Consider using low volatile formulations or adding a drift control agent or thickener to help minimize drift. If you apply pesticides indoors, you are also responsible for preventing drift. Ensure that pesticides do not move beyond the target site. All people and animals are kept out of the treatment area according to label instructions. Let's talk about sources of water contamination. Surface water or groundwater contamination results from either point source or non-point source pollution. Non-point source pollution from pesticide applications is usually blamed for pesticide contamination of the outdoor environment. However, studies show that water contamination may also result from point source pollution. So let's talk about what the differences are between point source and non-point source pollution. This is going to be very important for you as an applicator, as well as if you're taking any core exams. These questions come up regularly. Point source pollution comes from a specific identifiable location, such as a pesticide spill entering a storm sewer, back siphoning of pesticides into water supplies, contaminated surface water entering sinkholes, repeated spilling of pesticides at mixing and loading sites, careless spilling of wash water at equipment cleanup sites, improper handling of spills and leaks at storage sites, improper disposal of containers, rinsate from containers, and excess pesticides. Non-point source pollution comes from a widespread area. An example is the movement of pesticides into streams or groundwater after broadcast applications to large agricultural fields, rights-of-way, or turf areas. Pesticide contamination of surface water. Surface water is often a source of drinking water. Therefore, pesticide contamination of surface water, such as ditches, streams, rivers, ponds, and lakes, is a health concern. Pesticides that move in runoff water or with eroded sediment may contaminate plants and animals located downslope and reach sources of surface water. Now, every one of you understands why we need to protect surface water. Obviously, a lot of times it's even a source of drinking water. I do want you to understand that a lot of your states are going to have specific laws when it comes to surface water. So as you're getting ready to take exams or even need to just know the laws to do applications, make sure you understand your state laws as it relates to surface waters. They can be a really big deal. I can tell you, I took exams in New Hampshire and seemed like about a third of the exam was about surface water. But keep in mind, it's your job to understand those state laws, but also just make sure you're protecting surface waters. As you can imagine, once we pollute our surface waters, we're really in trouble in this country. Factors affecting runoff and erosion rates include slope, vegetative cover, soil characteristics, volume and rate of water moving downslope, temperature, and rainfall amount and intensity. These factors influence how much water runs off and how much moves into the soil in filtration. In urban areas, runoff may occur on hard surfaces where granules are left on sidewalks and streets. Runoff is a potential problem for most outdoor application sites. In areas treated with any type of pesticide, it is critical that runoff does not carry the pesticide into water sources or other vulnerable areas. Generally, runoff risk is greatest when heavy rains immediately follow pesticide applications or when the ground is saturated or frozen. Although surface waters are most likely to be contaminated by runoff, groundwater may also be affected when surface streams connect with shallow groundwater. We talked earlier about the fact that you don't want to do a pesticide application when rain is imminent in the area, and especially not while it's raining. The other thing that we introduced here is if the ground is already saturated from previous rains or frozen, you can imagine that product's going to run off a lot easier. As a matter of fact, I looked at a termiticide years ago. We were trying to do a termite treatment, and I looked on the label, and because the ground was frozen, I realized we couldn't use it. We were out there with picks and shovels and trying to beat through the ground, but the reality was the label itself said if the ground is frozen, you couldn't put out the termiticide. If I hadn't read that label, I wouldn't have known this, so just keep in mind when the ground's frozen, saturated, or any of these things we're talking about, you don't need to do a pesticide treatment. Let's talk about pesticide contamination of groundwater. Groundwater provides 70% of the water used for public and private water supplies, irrigation, and industry. Like surface water, groundwater must be protected from contamination. Once groundwater is contaminated, correcting the problem is difficult or even impossible. Groundwater is found underground in cracks, in the bedrock, and in spaces between soil particles, gravel, and rocks. It is the source of water for wells and springs. The layer of soil and gravel or fractured bedrock in which all available spaces are filled with water is the saturated zone. The boundary between the saturated zone and the underlying unsaturated rock and soil is known as the water table. The overall geologic formation from which groundwater can be drawn is called an aquifer. And this is the point where leaching comes in. Some pesticides reach groundwater by moving through the soil in a process called leaching. A pesticide that leaches into groundwater must move down through the soil and water and resist binding to soil particles and breaking down into non-toxic compounds. Pesticides that have high solubility, low absorption, and are persistent are more likely to leach. They typically have a label statement describing these concerns. A pesticide that absorbs or binds itself strongly to soil particles will not leach as easily. Besides the characteristics of the pesticide, soil properties and environmental conditions also affect whether and to what extent a pesticide will leach. Leaching, very, very important. Make sure you understand leaching. Make sure you understand when we talk about the pesticides binding to soils. We talked a little bit earlier about the different soil types. Some of them they're going to bind a little better to, like clay and heavy organic soils. But at the end of the day, you definitely need to understand leaching and the different types of soils you're going to be working with. The biggest thing about leaching is we don't want those pesticides to make their way down to the water table in the aquifer, because once again, a lot of times this is where our drinking water is coming from. So as much as you're doing this to protect yourself and your job, you're really doing this to protect the environment around you. Let's take a look at the properties of soil. Soil properties. 4 soil properties that affect a pesticide's potential for leaching are texture and structure, organic matter, depth of groundwater, and geology. Texture and structure. Soil texture is the relative proportions of sand, silt, and clay-sized particles. Percolating water moves faster in sandy soils. Sand also has fewer binding sites available for the absorption of dissolved chemicals than do clay or silt soils. Though sandy soils are more prone to pesticide movement, leaching may also occur in clay or silt soils. What we're saying here is sandy soils are going to allow that pesticide to move quicker through the soil so it doesn't absorb to the soil as much. So you have to understand when you're working in the sandy soil, that pesticide is going to go down really, really quickly. Whereas when we're working with clay and silt soils, especially if they have higher organic matter, that pesticide's not going to leach down into that soil as quickly. You always have to understand the type of soils you're working with and what the potential for leaching is. Soil structure is the shape or arrangement of soil particles. It plays a big role in determining the size and shape of the pores through which water moves. Small amounts of pesticides may also move through soil cracks, wormholes, and root channels. These features are called macropores. Let's talk about organic matter. Organic matter consists of decaying plant material. The higher the soil organic matter content, the greater the ability of the soil to hold both water and absorb pesticides. Pesticides held in the root zone are less likely to leach into groundwater and may be taken up by plants. Remember this. This is on almost all core exams in almost any state I've taken them in. The higher the soil organic matter, the greater the ability of the soil to hold both water and absorb pesticides. So when you hear about leaching and you hear about absorbed pesticides, just remember that higher organic content in the soil is going to make the pesticide stay there longer and not leach down to the water table. Depth to groundwater. Areas with a shallow water table have a greater chance for groundwater contamination because less soil is available to act as a filter. There are fewer opportunities for pesticide degradation or adsorption. When using pesticides in areas where the groundwater is close to the surface, choose a product with a low leaching potential. Take extra precautions during mixing, application, and cleanup. Geology. The permeability of the geologic layers lying between the surface of the soil and the groundwater is also an important factor. Highly permeable materials, such as gravel deposits, allow water and dissolved pesticides to move freely downward to groundwater. Layers of clay, which are much less permeable, can inhibit and slow the downward movement of water. Preventing surface water and groundwater contamination. To help prevent surface water and groundwater contamination, EPA requires all pesticide products labeled for outdoor uses to include the following environmental hazard statement on the label. Do not apply it directly to water or to areas where surface water is present or to intertidal areas below the mean high water mark. Do not contaminate water supplies when cleaning equipment or disposing of equipment wash waters. Pesticides that could contaminate groundwater must bear groundwater warning statements on their labels. When such statements appear on product labels, choose pesticides appropriate for use in sandy soils or where extra precautions are needed to reduce the risk of water contamination. You can minimize the risk of point or non-point source contamination by following best management practices, BMPs. BMPs are effective, common sense procedures that emphasize proper mixing, loading, application, and disposal of pesticides. Following BMPs reduces the chance that pesticides will harm the environment. Use integrated pest management principles. Apply pesticides only when and where necessary, and only in amounts adequate to control pests. Use non-chemical control methods whenever possible. When using pesticides, determine the type of pest, the density of the pest problem, and the proper control method. If a pesticide is necessary, choose the least toxic product that will do the job. Calibrate pesticide application equipment regularly. Use spot treatments or band applications if possible to reduce pesticide use. Identify vulnerable areas. The presence of sandy soil, sinkholes, Wells, streams, ponds, and shallow groundwater increases the chance of groundwater contamination. Never dispose of empty pesticide containers in sinkholes, or dump or rinse sprayers into or near sinkholes. Also take care to avoid contaminating drainage ditches and other potential sources of runoff to streams and waterways. Never clean tanks or intentionally discharge water from a tank of any vehicle into a street, along a road, or into a storm drain. Do not mix and load near water. Mix and load as far as possible, at least 50 feet, from wells, lakes, streams, rivers, and storm drains. When possible, do so at the application site. Consider using a sealed permanent or portable mixing and loading pad to prevent seepage into the soil. Keep pesticides away from wells. Do not store or mix pesticides around wells. Poorly constructed or improperly capped or abandoned wells may allow surface water containing pesticides and other contaminants direct entry into the groundwater. Note that wells are sometimes located in or near treated fields and other application sites. Avoid back siphoning. Back siphoning is the reverse flow of liquids into a fill hose. It sucks tank contents, including pesticides, back into the water supply. Back siphoning starts with a reduction in water pressure and can draw very large quantities of pesticide directly into the water source. This happens when the end of the water hose is allowed to extend below the surface of the spray mixture when filling a tank. And you can see here in this image, when you look at B, you can see the fact that the water hose is actually down in the tank water where the mixture is. And that's when we talk about back siphoning being a problem. So if there's a drop in water pressure and you have your hose down in the tank like you see in B, you're going to have a major problem because that water pressure drops. It sucks back in that water with the pesticides and it goes into the water supply. So as we try to avoid back siphoning, the simplest way to prevent backflow is to maintain an air gap between the discharge end of the water supply line and the pesticide solution in the spray tank. An air gap prevents contamination of the hose and keeps pesticides from back siphoning into the water source if a drop or loss of water pressure occurs. Keep the air gap at least twice the diameter of the discharge pipe. Another method to prevent back siphoning is to use a backflow prevention device or check valve. Improved land use and application methods. Terraces and conservation tillage practices can reduce water runoff and soil erosion. Ideally, growers should leave as much plant residue as possible on the soil surface to lessen erosion. Where conservation tillage is not possible, decrease runoff potential by incorporating a low concentration of the pesticide into the soil. In ornamental plantings, consider using mulches to reduce water runoff and soil erosion. Grass buffer strips are very effective in reducing pesticide runoff because they trap sediment containing pesticides and slow runoff water. This allows more runoff water to infiltrate the soil, leaving untreated grass strips next to streams, ponds, and other sensitive areas can trap much of the pesticide running off of these treated areas. Time pesticide applications according to the weather forecast. Pesticides are most susceptible to runoff from heavy rains or irrigation during the first several hours after application. Do not apply to saturated or frozen ground. To avoid overspraying an area and causing drift, check the pesticide label for application precautions or restrictions during windy conditions. Wind speed, temperature, and humidity all affect the off-target movement of pesticides. Select products wisely. Whenever possible, use pesticides that are less likely to leach. Read labels for such warnings. Handle pesticides safely. Follow these guidelines to prevent surface water or groundwater contamination. Immediately contain and control pesticide spills. Check application equipment regularly for leaks or damage. Mix and load pesticides away from water sources. After the pesticide application is complete, follow label directions for proper equipment cleanup and container disposal. After applying granular pesticides, sweep or blow any granules from sidewalks, driveways, or patios onto the treatment area. Whenever possible, clean sprayers at the application site at a safe distance from wells, ponds, streams, and storm drains. Spray the rinse aid onto the treated area or on another site listed on the pesticide label, or using the next tank mix. Be sure not to exceed label rates. Preventing harmful effects on sensitive areas and non-target organisms. To avoid harming the environment, you must be aware of sensitive areas, non-target plants and animals, especially endangered species, and damaging effects on habitat. Sensitive areas. In addition to water sources, sensitive areas include sites where living things could easily be injured by a pesticide. Outdoor sensitive areas include school grounds, playgrounds, and recreational areas, habitats of endangered species, apiaries, honeybee sites, wildlife refuges, and parks, areas where domestic animals and livestock are kept, ornamental plantings, public gardens, and sensitive food or feed crops. Indoor sensitive areas include places where people live, work, shop, or are cared for, such as hospitals and daycare centers. Food or feed is processed, prepared, stored, or served. Domestic or confined animals live, eat, or are otherwise cared for. Ornamental or other sensitive plants are grown or maintained, such as in malls and buildings. Sometimes pesticides must be deliberately applied to a sensitive area to control a regulated pest, such as mosquito abatement or gypsy moth forest treatments. Only well-trained applicators should perform these applications. At other times, the sensitive area may be part of a larger target site. Whenever possible, take special precautions to avoid treating the sensitive area. Leaving an untreated buffer zone around a sensitive area is a practical way to avoid contaminating it. In still other instances, the sensitive area may be near a site used for mixing and loading, storage and disposal, or equipment washing. Be very careful to avoid contaminating the sensitive area. Check the label for statements that alert you to special restrictions around sensitive areas. Pesticide effects on non-target organisms. Pesticides may affect non-target organisms directly, causing immediate injury, or they may produce long-term consequences through environmental pollution. Pesticides may build up in the bodies of animals or in the soil. For example, if you use the same mixing and loading site or equipment cleaning site over a long period, pesticides are likely to accumulate in the soil. When this occurs, plants and animals that come into contact with the soil may be harmed. The following sections discuss the effect of pesticides on non-target plants, bees, and other beneficial insects, and fish, wildlife, and livestock. Non-target plants. Nearly all pesticides can cause plant injury, phytotoxicity, due to chemical exposure, particularly if applied at too high a rate, at the wrong time, or under unfavorable environmental conditions. Phytotoxicity can occur on any part of a plant, roots, stems, leaves, flowers, or fruits. Most phytotoxic injury is due to herbicides, although damage to crops or other nearby plants is primarily caused by drift. It may sometimes be a consequence of surface runoff and root uptake. Bees and other beneficial insects. Besides making honey and beeswax, bees pollinate many fruit, nut, seed, vegetable, and field crops. You must be aware of bee activity when planning pesticide applications. There has been increasing concern about the decline of bee colonies and the role pesticides may play. Preventing bee loss is the joint responsibility of the applicator, the grower, and the beekeeper. Bees may travel as far as 3 miles from their hive to find blooming flowers. Before applying pesticides labeled as toxic to bees, notify beekeepers in the area so they can protect or move their bee colonies. Some states have laws requiring notification and registries for beekeepers. Bees and other insect pollinators may be exposed to pesticides through different routes, including 1. Direct contact during foliar applications, 2. Contact with residues on plant surfaces after applications, 3. Drip from the application into hive entrance, 4. ingestions of residues in nectar, pollen, or guttation, water, dew, when the pesticide is applied as a seed treatment, soil or tree injection, or foliar application. Insecticides are generally toxic to bees, but some are more hazardous than others. Herbicides are unlikely to harm bees directly. Fungicides do not appear to affect adult bees, but may affect larval development. Tank mixing insecticides and fungicides may create a mixture that is more toxic to bees than either product used alone. Minimize bee kills from insecticide poisoning by following a few basic principles. Pay careful attention to pesticide labels. For each application site, look for the bee hazard icon in the Directions for Use section for specific use restrictions and instructions to protect bees and other pollinators. Do not apply insecticide to crops in bloom. Apply insecticides in the evening or at night when bees are not foraging. Early morning application may protect honeybees, but wild bees forage at or before dawn. Minimize bee kills from insecticide poisoning by following a few basic principles. Do not apply insecticides when weeds or other plants around the treatment site are in bloom. Do not allow the pesticide to drift onto attractive habitat, natural areas, or beehives. Choose the least hazardous insecticide formulation and application method. Pesticides can harm other beneficial insects in addition to bees. These beneficials may be valuable allies in keeping pest populations below damaging levels. A pesticide application often harms the beneficial insect population as much as the target pest. So, do not spray when beneficial insects are in the target area unless it is unavoidable. Alternatively, choose a product that does not harm beneficials. Fish, wildlife, and livestock. Pesticides can harm all kinds of animals. Most injuries occur from the direct effects of acute poisoning. Fish kills often result from water pollution by a pesticide. Insecticides are the most likely cause, especially when small ponds or streams are under conditions of low water flow or volume. Bird kills resulting from pesticide exposure may happen in a number of ways. Birds may ingest pesticide granules, baits, or treated seeds, be exposed directly to sprays, consume treated crops or drink contaminated water, or feed on pesticide-contaminated insects and other prey. Granular or pelleted formulations are a particular concern because birds and other animals often mistake them for food. Liquid formulations may be safer when birds and other wildlife are in or near the treated area. Remove pet dishes from spray areas. Place baits properly so they are inaccessible to pets, birds, and other wildlife. Animals may also be harmed when they eat plants or animals carrying pesticide residues. Predatory birds or mammals feeding on animals killed by pesticides are a special concern. Pesticide residues remaining on or in the bodies of the dead animal may harm predators. This is called secondary poisoning. Check the pesticide label for statements about secondary poisoning. The less obvious effects resulting from long-term exposure to pesticides are a major concern. For example, certain pesticides have been banned because of fish and bird kills and the reproductive failures of several bird species. The most important source of livestock pesticide poisoning has been through contaminated feed, forage, and drinking water. Contamination often occurs as a result of improper or careless transportation, storage, handling, application, or disposal of pesticides. Protecting endangered species. Certain plants and animals have been identified as endangered or threatened species. Be very careful not to harm these populations. Because all living things are part of a complex, delicately balanced network, removing a single species may set off a chain reaction that affects many other species. The full significance of extinction is not always readily apparent, and the long-term effects are often difficult to predict. EPA has a list of endangered species on their website. You should be familiar with those species in your service area. An endangered species is one on the brink of extinction throughout all or a significant part of its range. A threatened species is one likely to become endangered. The reasons for a species decline are usually complex, and thus recovery is difficult. A major problem for most wildlife is the destruction of habitat, usually the result of industrial, agricultural, residential, or recreational development. Each state is responsible for implementing the Federal Endangered Species Protection Program in cooperation with EPA to protect endangered and threatened species from the harmful effects of pesticides. Under this program, pesticide products that might harm an endangered species carry a label statement instructing applicators to consult a county bulletin to determine if they must take any special precautionary measures when using the product. EPA develops these bulletins, which identify precautionary measures required in each county where one or more pesticides could affect an endangered or threatened species. Precautionary measures may include buffer strips, reduced application rates, and timing restrictions, or an applicator might be prohibited from using the pesticide within the identified habitat altogether. Summary: an important part of using pesticides legally and responsibly is considering where the pesticide may end up once it leaves the container and whether it might harm or damage non-target sites, plants, or animals. By applying pesticides at the right time, in the right place, and with the proper application technique, you can greatly reduce or even prevent drift, runoff, and leaching. Pesticides that enter groundwater and surface water are hazardous to aquatic organisms, plants, and wildlife. Therefore, you should implement best management practices to prevent runoff and leaching of pesticides. Sensitive areas include places such as schools, playgrounds, endangered species habitats, and ornamental plantings. Non-target organisms include plants, bees, and other beneficial insects, fish, wildlife, and livestock. Because of the greater risk of injury to people, plants, and animals, you must know when and how to properly apply pesticides in or near such areas. Always check the label statements on endangered and threatened species. You may need to consult a county bulletin that details the procedures for protecting them. It is your responsibility not only to follow label directions, but also to use the best management practices that present the least risk to the environment while achieving effective pest control. You have completed Part 1 of this course. We only have one planet. Please continue to Part 2. Today's course, Advanced Formulations and Combinations, was prepared by Jack Launius. Types of pesticide formulations and mixtures. The most basic pesticide formulations include suspensions and emulsions. As formulations get more advanced, there are several kinds of formulations that are like the basic formulations, but function quite differently. These advanced formulations include capsulated suspensions, microemulsions, water dispersible granules, and many others. Decisions concerning the management and prevention of pest infestations in the urban environment should always be knowledge-based. Integrated Pest Management (IPM) is a decision-making process driven by information collected during an inspection. Pest management professionals, PMPs, committed to an IPM mindset, make decisions about pest management that are logical reactions to the information gathered during the inspection process. An IPM mindset, therefore, demands that all options, including a sensible use of pesticides, be considered when developing a pest management action plan. Decisions. When used responsibly, pesticide-based controls can reduce or eliminate a pest problem while maintaining a stable, sound environment. However, because many pesticides are broad-spectrum, they must be used with great care to prevent undesirable effects. Other considerations are the toxicity, watching the LD50, drift hazards, environmental impact, impact on people and pets, and even impact on beneficial insects such as pollinators. The U.S. Environmental Protection Agency, EPA, defines a pesticide as any substance or mixture of substances intended for preventing, destroying, repelling, or mitigating any pest. Insecticide-based pest control products are composed of a mixture of chemicals classified as either active ingredients or inert ingredients. The specific chemicals in the mixture responsible for affecting the pest organism is referred to as the active ingredient. The active ingredient in its raw form is referred to as technical grade and is often 95 to 100% pure. Although there are a few exceptions, insecticides used by the pest management industry are rarely applied as technical grade active ingredients. Most commonly, the active ingredient is formulated with other chemicals called inert ingredients. While inert ingredients enhance product efficacy and make in-use products easier to use and safer to handle, they have little toxicity towards target pests. Because inert ingredients have great influence on an in-use product's characteristics and properties, especially performance, their identities are often trade secrets not revealed by the product's manufacturer. An active ingredient's chemical name is based on a strict set of internationally adopted rules of nomenclature established by the International Union of Pure and Applied Chemistry, IUPAC, or the CAS Chemical Abstract Systematic Name. These rules are considered the language of chemistry. Embedded within every chemical name are the pieces of information that describe the exact arrangement of every atom and chemical bond in the molecule. Active ingredients are also known by their common name. According to established rules, common names for pesticides are normally issued by the chemical's original manufacturer and then submitted to the International Organization for Standardization (ISO) for approval. Common names reduce confusion caused by multiple trade or brand names discussed below and are less cumbersome than chemical names during oral and written communication. Definitions: active ingredient, the chemical substance responsible for achieving a product's desired effect. Technical grade active ingredient. The chemical substance is pesticide in its raw form, usually 95 to 100% active ingredient prior to being formulated into a product. Definitions: inert ingredient. Inert ingredients are biologically inactive chemicals, i.e., they typically have no pesticidal properties, that are mixed with active ingredients to produce an in-use for sale product. Some commonly used types of inert ingredients and their functions include the following. Emulsifiers allow petroleum-soluble but water-insoluble active ingredients to evenly disperse in water. Dilutants and carriers are meant to dilute the amount of active ingredient in a formulation described later to carry it to its intended target. Often the same material serves as both dilutant and carrier. For example, talc is an inert ingredient in many dust formulations. Definitions: only a small part of the dust formulation is insecticidal. The remainder is inert talc that not only dilutes the active ingredient, but also carries it to its intended target. In liquid spray formulations, water is both a dilutant and carrier. In granular formulations, the inert granule on which the pesticide is absorbed is the carrier. Definitions: stickers allow active ingredients to stick or adhere to the treated surface. Wetting agents, e.g., spreaders, dispersants, penetrants, are inert chemicals that are added to water to increase spreading and/or penetration by eliminating or reducing surface tension. For example, a drop of water will bead on wax paper, but when a spreader/dispersant is added, the water droplet spreads evenly over the wax paper. Wetting agents are used in wettable powder formulations to allow the powder to evenly mix with water. Definitions: solutions are liquids, and all the chemicals that are dissolved in the liquid, for example boron, dissolve completely when placed in water to make a solution. In this example, water is called the solvent and the boron is called the solute. When a chemical is soluble in a liquid, it forms a solution and cannot separate. Definitions: a suspension is a liquid that contains solid particles that are not dissolved. Over time, the solid particles will settle to the bottom of the container. Many liquid spray formulations, wettable powders, suspendable concentrates, and microencapsulates are suspensions in water, and will settle to the bottom of the sprayer if not agitated. Suspensions should be shaken or agitated often to resuspend the product in the water. Definitions: contact toxicants are chemicals that penetrate the target organism on contact. For example, liquid sprays are usually effective only after an insect crawls on the treated surface and contacts the residual deposit. Oral toxicants are chemicals that act after having been ingested by the target organism. For example, bait products kill only after an insect consumes the bait containing the active ingredient. Fumigants are chemical gases. They act after an insect breathes them. The product label. Most pesticide products used by the pest management industry must be registered with and granted a label by the EPA. A product label is a manufacturer's written directions on how to use and not use the product and is based on extensive testing, specific knowledge, supportive data, and product experience. To be granted a label, a product manufacturer must provide the EPA supportive data as well as other documentation to convince the EPA that the product may be used without unreasonable risk to non-target organisms or the environment. Additionally, supportive data is required to be submitted to the EPA for pesticides labeled for control of some structural and public health pests. Efficacy data must support label claims for control of these pests when used according to label instructions. The product label. Labels are specific about how a product can and cannot be used. Because the label is a legal document, it is a requirement that pesticide users comply with the directions for use on the label. Users should always heed a manufacturer's recommendations and mandates and never do more than what is permitted by a product's label. Use of a product in a manner that is not permitted by the label is a violation of federal law and can carry state and/or federally imposed penalties. All EPA-granted labels contain the statement, "It is a violation of federal law to use this product in a manner inconsistent with its labeling." In other words, the label is the law. The product label. It is very important that PMPs be familiar with the product's label, not to only ensure that the product is being used in the most efficacious manner possible, but to ensure that its use is safe, legal, and environmentally responsible. The product label. Important information on a product's label includes first aid measures, in the case of an accidental poisoning, including emergency phone numbers, precautions when mixing, handling, applying, and storing the product, including the use of personal protective equipment, recommendations for disposal of used containers and contaminated rinse water or wash water, and potential hazards that can result from the misuse of the product. For example, the product's impact on various non-target organisms, such as fish, bees, and other wildlife. The product label. The majority of a product's label is directions for use. The directions for use section commonly includes pests that can be treated with the product, where the product can and cannot be used, and how to mix the product to achieve the desired concentration. The directions for use section also provides information on product concentrations, application volumes, and suggestions on how spot, general spray, crack and crevice, and where, specific sites, to apply the product to best achieve control of the pest listed. SDS Safety Data Sheet. The Hazard Communication Statement HCS 29 CFR 1910.1200G, revised in 2012, requires that the chemical manufacturer, distributor, or importer provide safety data sheet SDSs, formerly MSDS or material safety data sheets, for each hazardous chemical to downstream users to communicate information on these hazards. The information contained in the SDS is largely the same as the MSDS, except now the SDS are required to be presented in a consistent, user-friendly 16-section format. This brief provides guidance to help workers who handle hazardous chemicals to become familiar with the format and understand the contents of the SDSs. SDS Safety Data Sheet. The SDS includes information such as the properties of each chemical, the physical, health, and environmental health hazards, protective measures, and safety precautions for handling, storing, and transporting the chemical. The information contained in the SDS must be in English, although it may be in other languages as well. In addition, OSHA requires that the SDS preparers provide specific minimum information as detailed in Appendix D of 29 CFR 1910.1200. The SDS preparers may also include additional information in various sections. SDS Safety Data Sheet. Sections 1 through 8 contain general information about the chemical identification, hazards, composition, safe handling practices, and emergency control measures, e.g. firefighting. This information should be helpful to those that need to get the information quickly. Sections 9 through 11 and 16 contain other technical and scientific information, such as physical and chemical properties, stability and reactivity information, toxicological information, exposure control information, and other information including the data preparation or last revision. Let's talk about signal words. Signal words that may appear on the label. When we look at our chart, you can see in the upper left-hand side, we see signal word. Looking just below, we're going to start with danger or danger poison. The category for that product would be Class 1, highly toxic, and the toxicity lethal dose would be corrosive or irritant properties, a few drops to 1 teaspoon. Looking at our second signal word in orange, which would be warning, the category would be a Class 2, moderately toxic, and its toxicity lethal dose would be 1 teaspoon to 1 ounce. Looking at our third signal word in yellow, it's going to be caution. Its category is Class 3, slightly toxic, and its toxicity lethal dose is going to be 1 ounce to 1 pint or 1 pound. Looking at our final signal word in green, we're going to have caution or none. The category is going to be Class 4, very slight hazard. Toxicity lethal dose is going to be over 1 pint or 1 pound. Lethal doses are listed for a 150-pound adult. A product's toxicity category determines what must be on its label. Let's take a look at the acute toxicity categories for pesticide products hazard indicators. As you can see, we've got 4 columns on this chart. First, we have in red, highly toxic category 1, danger/danger poison. In category 2, we've got moderately toxic, category 2 warning. We got category 3 in column 3 in blue, which is going to be low toxicity, category 3 caution. And our final category in green is going to be very low toxicity, category 4, optional signal word caution. Looking back on the left side of our screen, you can see we're starting by looking at an oral LD50. So let's look at it. Oral LD50 under column 1, highly toxic, category 1, danger/danger poison, is up to and including 50 milligrams/kilograms. When we look at oral LD50 under category 2, which is going to be moderately toxic, category 2 warning, it's going to be greater than 50 through 500 milligrams/kilograms. If we look at oral LD50 under column 3, low toxicity, category 3 caution, it's going to be greater than 500 through 5,000 milligrams/kilograms. And looking again at oral LD50 under category 4 in green, optional signal word caution, it's going to be greater than 5,000 milligrams/kilograms. Let's take a look again at the left column on our chart. Let's go down to dermal LD50. When we talk about dermal LD50 and we look at it under column 1, highly toxic, category 1, danger/danger poison, we see it's up to and including 200 milligrams/kilograms. If we look at dermal LD50 under moderately toxic, category 2 warning, it's going to be greater than 200 through 2,000 milligrams/kilograms. If we look at dermal LD50 under category 3, low toxicity, category 3 caution, we're going to be greater than 2,000 through 20,000 milligrams/kilograms. And if we look at dermal LD50 under very low toxicity, category 4, optional signal word caution, it's going to be greater than 20,000 milligrams/kilograms. Looking further down on our chart of acute toxicity categories for pesticide products hazard indicators, you're going to see inhalation LC50. If we look at this under the column highly toxic category 1 danger/danger poison, you can see it's up to and including 0.2 milligrams/liter. If we look under category 2 moderately toxic category 2 warning, you can see it's greater than 0.2 through 2 milligrams/liters. If we look under category 3 low toxicity category 3 caution, you can see it's greater than 2 through 20 milligrams/liters. And if we look at our final column, very low toxicity category 4 optional signal word caution, you can see it's greater than 2.0 milligrams/liters. Looking further down the left side of our chart, you can see we're going to look at eye irritation. Eye irritation under the highly toxic category 1 danger/danger poison is considered corrosive, corneal opacity, not reversible within 7 days. If we look at it under moderately toxic category 2 warning, eye irritation, corneal opacity reversible within 7 days, irritation persisting for 7 days. If we look at eye irritation under the column low toxicity category 3 caution, no corneal opacity, irritation reversible within 7 days. And if we look at eye irritation under our final column, very low toxicity category 4 optional signal word caution, there's going to be no irritation. Looking at the bottom of the column on the left hand side of our chart, you're going to see skin irritation. When we look at skin irritation under highly toxic category 1 danger/danger poison, you can see it's corrosive. If we look at skin irritation under column 2 moderately toxic category 2 warning, you can see it says severe irritation at 72 hours. If we look at skin irritation under low toxicity category 3 caution, you can see it can cause moderate irritation at 72 hours. And we would look at skin irritation in our last column, very low toxicity category 4 optional signal word caution, it's going to be mild or slight irritation at 72 hours. Active ingredient. Adjuvants enhance pesticide efficacy without increasing the toxicity or increasing the effectiveness of a specific mode of action. Types of pesticide formulations and mixtures. Many products used in conjunction with others will add to the overall level of control. Spraying alone isn't enough. Types of pesticide formulations and mixtures. Solubles. Soluble products form a true dilution when the active ingredient is dissolved completely into water. Boron. One of the most common soluble products used for general pest and termite control. Types of pesticide formulations and mixtures. The most common soluble pesticide used today is boron. Boron can be purchased under several trade names. Timbor, Nibor, and Board Defense are a few examples. Boron, in the soluble form, is used generally for wood-destroying organisms. Types of pesticide formulations and mixtures. When applied on wood, it penetrates the cellular structure of the wood, making the wood toxic to termites. In a dry form, it can be used for ants and cockroaches. It absorbs small amounts of water out of the air and is sweet tasting. Wettable powders and suspensions. These carrier agents want to settle and require frequent agitation to continue floating in the product. A huge advantage of products carried in a suspension is that they do not burn plants like many emulsions do. They also sit on the surface of porous materials, allowing more contact with the pest. Once the product is dry, it doesn't move through the soil, it stays in place until no longer active. Wettable powder. Wettable powder formulations are created by impregnating or coating a microscopic particle of an inert carrier, e.g., absorptive clay, talc, etc., with insecticide and various inert ingredients to enhance the wetting, spreading, and dispersing characteristics of the powder. The inert ingredients, wetting agents, allow the dry powder to evenly disperse in and mix with the water without clumping or caking. Because wettable powders are true suspensions, constant agitation is required to keep the powder suspended in water. Wettable powders do not readily absorb into skin, but care should be taken when using this formulation to avoid accidental inhalation. Wettable powders and suspensions. These carrier agents want to settle and require frequent agitation to continue floating in the product. A huge advantage of products carried in a suspension is that they don't burn plants like many emulsions do. Once the product is dry, it doesn't move through the soil, it stays in place until no longer active. Emulsions. Emulsions are formed when an emulsifier is used to combine two parts of a finished solution or product that otherwise wouldn't mix. Generally, active ingredients are mixed in an oil base. Oil and water do not mix. Therefore, an emulsifier is required for the active ingredient to float evenly in the finished solution. Emulsifiables. Water and oil do not mix unless an emulsifying agent is added. When an emulsifier is added to a mixture of oil and water, microscopic droplets of oil are formed that disperse throughout the water. The resultant milky white mixture is referred to as an emulsion. The droplets in emulsifiable formulations do require minimal agitation in comparison to formulations that are suspensions, wettable powders, microencapsulates, suspension concentrates that may require more agitation. Emulsions. Emulsions require frequent agitation, otherwise the active ingredient will settle to the bottom of the mixture. This is typical because the pesticide never completely dissolves. Emulsions. Because of the oil base, emulsions are more readily absorbed through the insect cuticles, making them more likely to kill on contact. Oils in this product also cause faster skin absorption in humans, and therefore applicators should be especially careful about getting it on their skin and on non-target organisms. Zenprox EC. The EC in the product name signifies that the product is an emulsifiable concentrate. Zenprox EC contains an ether pyrethroid that bonds differently to the nerve cell than other pyrethroids. Because of its unique mode of action and formulation, it is less likely to cause insect resistance and is very effective for interior treatments. Because it is held in an emulsion, it penetrates the insect cuticle faster and has a faster knockdown. Next, we're going to take a look at microemulsions. Microemulsions. Acetemprid, the first active ingredient, has a high rate of lateral transfer, which is enhanced by the small particle size. The second active ingredient, bifenthrin, leaves a long residual. Microemulsions. The small particles make it likely to penetrate the insect cuticle and soil surface even faster than other emulsions. A microemulsion particle is 100 times smaller than a particle from a standard emulsion and 1,000 times smaller than a microcap. Microencapsulated are formed by encapsulating an insecticide in a microscopic, round plastic capsule. The capsules are mixed with inert ingredients, dispersants, wetting agents, etc., to keep them from clumping and to help the mixture flow more readily. The inert ingredients also facilitate storage and dispersion when diluted in water. Microencapsulated. The capsule's wall thickness determines the release rate of the insecticide to the outside environment. The insecticide seeps through the capsule's wall and coats the outside of the capsule. As the insecticide disappears, degradation, evaporation, etc., additional insecticide inside the capsule continues to coat the capsule surface. This process maintains a capsule that is constantly coated with a thin film of insecticide. Microemulsions. Transport micron is well suited for smaller insects like soakids due to its small particle size, absorption rate, and dual mode of action. The product does not contain label restrictions beyond what is normally found with regards to neonicotinoids and even pyrethroids. Microencapsulated suspensions. The acronym CS implies that a product is a capsulated suspension. Small capsules are evenly divided in the carrier agent, water. These microcaps are relatively small and are about 30 microns in size. Because the microcaps break down slowly, the products tend to leave behind a good residual, but are generally slow-acting. Microencapsulated suspensions. The residual benefits of these products are enhanced by the fact that the active ingredients are protected from the elements, harsh weather, UV rays, and the high pH levels found on brick and concrete. Some products can have as many as 10,000 microcaps per square inch. Onslaught Fast Cap is a pyrethroid-based polymeric microencapsulation. It has 3 active ingredients. The first 2 are pyrethroids, and the third is Synergist that enhances the effectiveness of the product. This is a typical product not only because it has 2 pyrethroids in it, but also because modern pyrethroids don't generally come with a Synergist. Onslaught Fast Cap. The Synergist PBO enhances pyrethroids specifically and makes this product one of the strongest pesticides for spiders and scorpions. The Synergist also helps to make the product fast-acting, unlike some other microencapsulated products, but the product retains its long residual due to the formulation. This product is highly repellent and consideration should be taken when applying since it can create new problems with ants, cockroaches, and other highly unpredictable pests. Water dispersible granules. Airlon is an example of a product held in water dispersible granules. Despite containing minerals, Airlon has not been shown to stain any surfaces. The granules are evenly suspended in water after mixing and disperse evenly on surfaces when applied. The active ingredient in Airlon, indoxacarb, has been shown to have exponential control since the product has a high rate of lateral transfer. Water dispersible granules. The product is target specific and through its meta-active activation, it can differentiate between target pests and non-target organisms. It works great on cockroaches but terrible on bees. Water dispersible granules. When it is inside of an insect, it combines with enzymes and forms the meta-active compound. As an example, the meta-active compound can often be found in the sputum of cockroaches several generations after the first cockroach is fed. Synergist. Exciter is a common product containing a synergist and is mixed with other products to synergize them. Exciter does not leave a residual treatment on surfaces, instead it has a rate of contact mortality. The combination of Exciter with residual products has the knockdown that is common with Exciter and the residual of the other product. Synergist. Synergists are products or active ingredients that enhance the toxic effect of a specific pesticide or active ingredient. The most common synergist is piperonyl butoxide PBO. Generally, PBO is used to enhance the mode of action found in pyrethrins and pyrethroids. PPO blocks the mode of action found in sodium channel inhibitors by blocking an insect's natural defense to these products. Surfactants. Surfactants are a type of adjuvant that add to the efficacy of a pesticide without adding to the toxicity level or enhancing the effect of a specific mode of action. Surfactants enhance the ability of water molecules to naturally bond together, which creates a more uniform distribution of a spray mixture on plant leaves and on ground surfaces. Surfactants are also wetting agents. This means that they allow water and products to more easily penetrate soil. Surfactants. Adding surfactants to products in a suspension will force them to penetrate soil that they otherwise might not. Surfactants also force products that tend to penetrate the soil to move deeper. Yucca is a surfactant made from the Yucca scitigera plant found in the desert. The Yucca scitigera plant produces its own chemical compounds to help it manage water more effectively. It is perfect for use with any pesticide or fertilizer, and when used by itself can enhance the vitality of plants and even correct some soil conditions. Baits. Baits enhance treatments by adding to the effectiveness of spray treatments. Granular baits can be put into gardens and yards. Boron-based baits such as Niban and Mother Earth G last longer than the average spray application and can extend the effective life of a pest control treatment since they will remain active once the liquid application has lost its residual action. When looking at Niban granular bait, the active ingredient is orthoboric acid 5%. Other ingredients are 95% for a total of 100%. Baits. Bifenthrin in a suspension will last up to 30 days, max Thor, according to the manufacturer. Boron-based baits such as Niban last beyond 1 month and continue to work as they break down. Abamectin-based baits such as Advance 375A have been shown to limit reproduction of ants. They should be used in spring when reproduction is at its highest levels and can accompany boron-based baits or be used as a sole bait on a property. Let's take a look at some specific pesticides and their formulations. Let's start with Aerolon. That would be water-soluble granules. Onslaught Fast Cap, microencapsulated suspension. Optigard Flex, microencapsulated suspension. Max Thor SC, suspension concentrate. Microcare 3% CS, microencapsulate suspension. Premise 2, suspension concentrate. Premise 75 WP, wettable powder suspension. ProThor SC2, suspension concentrate. Suspend SC, suspension concentrate. Temperate SC, suspension concentrate. Tempo SC Ultra, suspension concentrate. Tempo Ultra WP, wettable powder suspension. Transport Micron, microemulsion. Zenprox EC, emulsion. Let's first take a look at Aerolon, which is a water-soluble granule. Aerolon. Aerolon is an insecticide that can be used to control a broad range of pests. The active ingredient is indoxacarb 20%. Uses non-repellency with slight delay in mortality, which allows target insects to carry it back to their site and share it with other insects for thorough control. Aerolon is a non-pyrethroid designed for flexible use indoors as a 10-foot band application outdoors. It can also be used as a crack and crevice application in food handling establishments as directed by the product label. Insects on the Aerolon label: ants, beetles, box elder, carpenter bees, centipedes, cockroaches, crickets, earwigs, fleas, flies, grasshoppers, millipedes, pillbugs, silverfish, sowbugs, springtails, stink bugs, and wasps. Onslaught Fast Cap. Onslaught Fast Cap spider and scorpion insecticide has a unique formulation that contains exponent synergist that enhances two other active ingredients, esfenvalerate and perlethrin. This quick-acting insecticide may be used indoors and outdoors on homes and has a label for food and non-food areas in commercial structures. Onslaught Fast Cap is labeled for indoor, in food and non-food areas. Onslaught Fast Cap may be used in homes, food processing plants, restaurants, schools, warehouses, hotels, outdoor perimeter treatments to areas such as around garbage cans, porches, patios, carports, garages, fence lines on trees, lawns, landscapes, and turf in and around livestock housing. Onslaught Fast Cap has a quick-acting microencapsulated formula, gives a quick kill while still providing a residual control. Insects included on the Onslaught Fast Cap label include ants, Asian lady beetles, bed bugs, box elder bugs, carpenter ants, cockroaches, confused flower beetles, darkling beetles, lesser mealworm, face flies, fleas, fruit flies, horn flies, hornets, house flies, Indian meal moths, lesser grain borers, mosquitoes, red flower beetles, rice weevils, sawtooth grain beetles, scorpions, small flying moths, spiders, stink bugs, swarming termites, ticks, wasps, and yellow jackets. Onslaught Fast Cap. Mix Onslaught Fast Cap with an IGR such as Nygaard IGR concentrate to break the insect growth cycle and control future emerging insect populations as part of an IPM program. Optigard Flex. Active ingredient thiamethoxam, CAS number 153719-23-4, 21.6%. Other ingredients 78.4% for a total of 100%. Optigard Flex Liquid is a suspension concentrate formulation that contains 2 pounds thiamethoxam per gallon formulated product, 244 grams thiamethoxam per liter formulated product. Optigard Flex for control of listed pests, including cockroaches, ants, except carpenter ants and pharaoh ants, fire ants and beetles, for control of localized infestations of drywood termites, subterranean termites, carpenter bees, and wood-destroying beetles and borers. Max Thor SC suspension concentrate, made by Insistex, is labeled for an extremely broad usage both indoors and outdoors and cover a wide variety of pests. Its goal is to have a strong stability and a long residual on almost any type of surface. The active ingredients in Max Thor SC is bifenthrin 7.9%, other ingredients are going to be 92.1%, and total ingredients are going to be 100%. Max Thor SC is effective on a wide variety of pests due to its active ingredient of bifenthrin. Microcare 3% CS. Microcare 3% CS Control Release Insecticide is designed to save you time by staying in water solution without agitation. This botanical insecticide delivers fast knockdown and residual control of a broad spectrum of pests. Microcare 3% CS kills accessible stages of angoumois, grain moths, ants, excluding harvester ants, Asian lady beetles, bees, box elder bugs, cadelles, carpet beetles, carpenter ants, carpenter bees, centipedes, cigarette beetles, clover mites, cockroaches, confused flower beetles, crickets, dermestid beetles, dried fruit beetles, drugstore beetles, fire brats, fleas, flies, fungus gnat larvae, gnats, grain mites, India meal moths, mealworms, mealybugs, Mediterranean flower moths, millipedes, mosquitoes, moths, red flower beetles, sawtooth grain beetles, scorpions, silverfish, sowbugs, spiders, ticks, Tragoderma, wasps, weevils, granary and rice weevils, and yellow jackets. Microcare 3% CS for use in and around bakeries, beverage plants, calf hutches, canneries, dairies, flour mills, federally inspected meat and poultry plants, food handling establishments, food processing plants, food storage areas, grain elevators, grain mills, granaries, hog operations, homes, horse barns, hospitals and nursing homes, except patient rooms while occupied, hotels, industrial installations, kennels, landscapes, loafing sheds, meat packing plants, milk rooms, milking parlors, motels, office buildings, poultry operations, residences, restaurants, schools, stables, supermarkets, transportation equipment, airplanes, cargo areas only, boats, buses, rail cars, ships, trailers and trucks, warehouses and zoos. Let's take a look at Premise 2 insecticide, which is a suspension concentrate. Premise 2. For use by individuals, firms licensed or registered by the state to apply termiticide products. States may have more restrictive requirements regarding qualifications of persons using this product. Contact the Structural Pest Control Regulatory Agency of your state prior to use of this product. For prevention or control of subterranean termites, drywood termites, dampwood termites, carpenter ants, and other wood-infesting insects. Premise 2. Premise 2 has an active ingredient of imidacloprid, 1-6-chloro-3, pyridinyl, methyl, N-nitro-2, imidazolidininamine, 21.4%, with inert ingredients of 78.6%. It contains 2 pounds of imidacloprid per gallon. Premise 75WP. Premise 75WP is a wettable powder termiticide that was formulated to provide professional, lasting, and effective termite control. Premise 75WP may be used to do a soil-based perimeter treatment around a home's foundation to prevent termite infestation or treating localized areas of known subterranean termite activity. Premise 75WP. Premise was formulated for controlling drywood and dampwood termites, borers, and other wood-infesting insects in and around basements, attics, crawl spaces, voids, and damaged wood piles. Premise is a non-repellent termiticide, meaning that termites do not detect that Premise is present. Premise was designed for termites to contact the product, then transfer it to other termites, eventually killing the colony. The next product we're going to take a look at is ProThor SC2, which is a suspension concentrate. ProThor SC2. for prevention or control of subterranean termites in and around residential, commercial, industrial, institutional, and public structures and buildings, for foliar and systemic control of insect pests of turf grass, landscape ornamentals, shrubs and trees in lawns, golf courses, landscapes, playgrounds, parks, athletic fields, and interior plantscapes. Prothor SC2. Active ingredient is going to be imidacloprid, 21.4%. Other ingredients are going to be 78.6%, and it contains 2 pounds of imidacloprid per gallon. Our next product is going to be Suspend SC, which is a suspension concentrate insecticide. Suspend SC, only for use in storage by pest control operators and/or commercial applicators for residential, industrial, and institutional control of major nuisance pests listed on the label. Controls numerous pests in and around households and other structures, will not damage paints, plastics, fabrics, or other surfaces where water alone causes no damage. For insect control on commercial and residential turf and landscape ornamental plants. Suspend SC active ingredient is going to be deltamethrin, 4.75%. Other ingredients are going to be 95.25%, and it contains 0.42 pound deltamethrin per gallon. Suspend SC. Listed insects on the label are going to include ants, carpet beetles, firebrats, fleas, gnats, midges, centipedes, millipedes, pantry pests, silverfish, ticks indoors. Suspend SC is also labeled for bees, bed bugs, box elder bugs, fleas outdoors, cessid flies, cockroaches, crickets, flies, including such flies as stable, house, cluster, and horse flies, elm leaf beetles, ground beetles, moths, midges, hornets, killer bees, lice, mosquitoes, multicolored Asian lady beetle, pillbugs, scorpions, sowbugs, spiders, yellow jackets, wasp, and carpenter ants. Temperate SC. Temperate SC is a suspended concentrate insecticide that offers a dual mode of action by using 2 powerful and effective residual insecticides, beta-cyfluthrin and imidacloprid. The result is a dual action product. Temperate SC is labeled for indoor and outdoor use. Temperate SC. In the state of New York, this product may only be applied for indoor uses. Active ingredient is going to be imidacloprid, 1-6-chloro-3-pyridinil, methyl N-nitro-2-imidazolidinamine, 21%, B-cyfluthrin, cyano-4-fluoro-3, phenoxyphenyl, methyl 3-2-2-dichloroethanol, 2,2-dimethyl, cyclopropane carboxylate, 10.5%. Other ingredients are going to be 68.5%. Temperate SC. The labeled insects are going to include ants, bed bugs, blue or green bottle flies, box elder bugs, brown marmorated stink bugs, carpet beetles, centipedes, clothes moths, clover mites, cluster fly, cockroaches, crickets, darkling beetles, dermestids, earwigs, elm leaf beetles, firebrats, flesh flies, flies, fruit flies, gnats, hide beetles, hornets, houseflies, kudzu, globular stink bugs, leather beetles, midges, millipedes, moths, multicolored Asian lady beetles, forward flies, pillbugs, cyarid flies, fungus gnats, silverfish, sowbugs, spiders, wasp, and yellow jackets. Let's take a look at our next suspension concentrate, Tempo SC Ultra. Tempo SC Ultra, cyfluthrin cyano 11.8%, was designed to be an effective broad-spectrum spray for both indoor and outdoor applications, including trees, lawns, shrubs, etc., designed for a quick knockdown and residual control. Our next product is going to be Tempo SC Ultra, which is a suspension concentrate. Active ingredient is going to be B-cyfluthrin cyano 4-fluoro, phenoxyphenyl, methyl 3-2,2-dichloroethanol, 2,2-dimethyl, cyclopropane carboxylate, 11.8%. Other ingredients, 88.2%. Contains 1 pound cyano 4-fluoro 3-phenoxyphenyl methyl 3-2,2-dichloroethyl 2,2-dimethyl cyclopropane carboxylate per gallon. Insects controlled on the Tempo SC Ultra label include ants, except Pharaoh and Harvester, fire ants, aphids, armyworms, azalea caterpillars, bagworms, beetles, billbugs adult, black turfgrass Atenius adult, black vine weevil adult, blowflies, bluegrass billbug adult, box elder bugs, bristly rose slugs, budworms, cadelles, beetles, California oakworms, cankerworms, case bears, carpenter ants, carpenter beetles, caterpillars. Continuing our insects controlled list with Tempo SC Ultra, we have chiggers, chinch bugs, cigarette beetles, cloves moths, clover mites, cockroaches, confused flower beetles, crickets, cutworms, darkling beetles, dermestid beetles, drugstore beetles, earwigs, elm leaf beetles, elm spanworms, field flies, firebrats, flea beetles, flies, flower four beetles, fruit flies, fungus gnats, grain mites, granary weevil, grasshoppers, ground beetles, gypsy moth larvae, hide beetles, hornets, houseflies, hyperodes weevil adult, Indian meal moths, Japanese beetles adult, June beetles adult, lace bugs, larder beetles, leaf-eating caterpillars, leaf hoppers, leaf rollers. Closing out the list of insects controlled on the Tempo SC Ultra label, we have leaf skeletonizers, leather beetles, lesser grain borers beetles, lesser mealworms, mealybugs, Mediterranean flower moths, merchant grain beetles, mealworms, mealworm beetles, millipedes, mole crickets, mosquitoes, moths, oleander moth larvae, orchid weevil, pear, scilla, pepper tree psyllid, board flies, pill bugs, pine shoot moths, pine tip moths, plant bugs, red flower beetles, red humped caterpillars, rice weevils beetles, sawfly larvae, sawtooth grain beetles, scale insect, crawler stages, cyarid flies, silverfish, sod webworms, sow bugs, spider mites, spiders, spittle bugs, stable flies, striped beetles, striped oakworms, tent caterpillars, thrips, ticks, tussock moth larvae, walnut caterpillars, warehouse beetles, webworms, whiteflies, yellow jackets, yellowneck caterpillars direct spray only. The next product we're going to look at is Transport Micron, which is a microemulsion. Transport Micron to control termites and listed household pests indoors and around the exterior perimeter of residential, institutional, public, commercial, industrial buildings, and non-commercial barns, i.e., non-commercial barns are storage structures not intended for housing livestock and other pests, and food feed handling establishments. Transport Micron active ingredient azathioprine 5%, bifenthrin 6%. Other ingredients are going to be 89%. Insects on the Transport Micron label include ants, including red imported fire ants, carpenter ants, and Argentine ants, but excluding Pharaoh ants, bees, beetles, not for use in California, biting flies, box elder bugs, carpenter bees, centipedes, chiggers, clover mites, cockroaches, crickets, earwigs, elm leaf beetles, firebrats, fleas, flies, gnats, ground nesting solitary bees and wasps, midges, millipedes, mosquitoes, moths, pillbugs, scorpions, silverfish, sowbugs, spider mites, spiders including black widow, springtails, stink bugs, ticks including brown dog ticks, and wasps. The next product we're going to take a look at is Zenprox EC, which is an emulsion or emulsifiable concentrate. Zenprox EC kills ants, bedbugs, cockroaches, centipedes, crickets, flies, fleas, fruit flies, gnats, mosquitoes, moths, scorpions, silverfish, spiders, brown recluse, black widows and others, ticks, wasps, and other listed insect pests. It's for use in homes, apartments, hotels, schools, nursing homes, hospitals, office buildings, warehouses, commercial and industrial buildings, and other listed buildings and structures. Zenprox EC. The active ingredients are going to be Edofenprox CAS number 80844-07-1, 16.2%, Piperonil butoxide CAS number 51-03-6, 64.8%. Other ingredients are going to be 19%. Butylcarbidyl 6-propylpiperonil, ether, and related compounds. This formulation contains 1.4 pounds Edofenprox and 5.6 pounds of piperonil butoxide per gallon. In-use dilution is 0.25% Edofenprox. We have to ask the question, why are formulations so important? Formulations are one of the biggest decisions you make when performing a pest control service. You need to consider the pests being treated, the metamorphosis, their social behavior, and other factors. And this is very important. If we don't understand these types of things, we're never going to solve the problem. Obviously, you need to identify the pest. Look at the metamorphosis. Look how they grow. Think about the different life cycles and understand what the best products will be depending on the different stages of the life cycle. Also, in some life cycles, you may not even be able to kill them. These are things you need to think about, as well as their social behavior. You need to understand if it's a colonizing insect like an ant, we're going to treat it differently than we would millipedes or something like that. So we're really just hitting the tip of the iceberg on the importance of formulations, but I at least want you thinking and getting some ideas of what you need to do when you're choosing a formulation. Sensitivity of accounts. Another factor is going to be the sensitivity of accounts. You would think differently when treating a daycare center than a home with no children or pets. Always think about where you are treating, who it will affect, and what is around you before you select the product formulation. We're using daycare center as an example here because, as you can imagine, with children crawling all over the floor inside of a building, how comfortable would you be using pesticides in an area like that? Also, if you do need to use pesticides indoors, where are you going to put them? You really need to think about that because now we've got an issue of keeping the pesticides out of reach of children, making sure they don't come into contact with them. So maybe more of an exterior application makes more sense, but then we've got the issue that kids might even be outdoors. So you really need to think about something like a daycare center totally differently than you would a home with no children or pets, where you really don't have the same level of worry about exposure in an area like that. Commercial accounts. Consider office buildings. You may be dealing with many different personalities when treating a large structure. Does it make sense to go in and hose down the baseboards in offices? Many times, applicators do things like this, and companies must wind up explaining their way out of a bad situation. And I'm speaking to this from experience. I've had technicians that were under my charge that did this and told people to lift their feet up, whatever the case was. People told me they didn't even want their offices sprayed. This was in the older days, but I can tell you there's still companies that go out and do things like this. So really think about commercial accounts, especially when you're coming into contact with a lot of different people, because there can be several different issues and you're going to be dealing with personalities that can have a wide range of thoughts about pesticide use in general. What about schools and public buildings? These types of accounts can have an even higher level of concern. As you can imagine, you must understand the sensitive nature of them. You must also read and understand any state laws pertaining to pest treatments in these types of structures. It is very common to have specific guidelines set by the state that must be followed when treating these types of buildings.
You have completed Part 2, Advanced Formulations and Combinations.
Part 3, 7A, General and Household Pest, Identification and Control. Ants. Ants are social insects that produce a colony made of various, specialized types of individual ants. Most ants are known as workers. They are wingless, do most of the food foraging and rearing of young, and defend the colony. Eggs are produced by the large queens, which have wings until after they have mated. Smaller winged ants found in colonies are the males. Ants. Ants are characterized by having a very narrow, pinched waist and antennae that are bent or elbowed. They are sometimes confused with termites, especially when swarms are produced. However, termites have a broad waist and beaded antennae. Development of ants involves complete metamorphosis. Eggs are extremely small. The developing larvae are fed by the worker ants and pass through several molts before pupation. The pupa don't feed and are immobile, soft, and white. Ant nests, usually, are produced underground, and colonies can contain tens of thousands of workers. The larger carpenter ants build nests in wood, usually wood that is partially decayed. Ants feed on a wide variety of different foods. Sugary materials are preferred by some species, others mostly feed on fatty or protein-rich foods. Some ants are important predators of insect pests. However, problems with ants often occur when they forage for food indoors during the warmer months. In addition, carpenter ants can cause structural damage. Carpenter ants, Camponotus sp. Carpenter ants are the largest ants, 1/4 to 1/2 inch. Often they are black or dark brown, although some eastern plain species are lighter in color. The most distinctive habit of carpenter ants is their nesting in wood. The ants excavate galleries and pile coarse sawdust at the nest openings. Unlike termites, carpenter ants don't eat wood. Instead, they scavenge on dead bodies, insect honeydew, and other materials. Carpenter ants almost always nest in wood that is soft because of water and decay damage. Rarely does damage extend from nest originating from damaged wood into sound wood, causing structural damage. Carpenter ants don't sting, but they can produce a mildly painful pinch from their jaws. Harvester ants, Paganomemex sp. Nests of harvester ants are very conspicuous since they often produce large mounds. The ants are fairly large and red or dark brown in color. Harvester ants primarily feed on seeds and may clear the vegetation from the area around the mound. They rarely enter homes. Harvester ants have a mildly painful sting. Field ants, Formica sp. There are a great many species of field ants. These ants are medium-sized, and they may be brown, red, black, or any combination of these colors. Nesting occurs outdoors, often near pavement. The ants are attracted to sweets. Cornfield ants, Lasius sp. Nests of the cornfield ants occur in fields and around homes. Typically, nesting sites in yards include brick or stone walls, cracks in the pavement, beneath rocks, and sometimes in openings around foundations. They don't nest in the house, but they often forage inside in search of sweet materials. Pavement ant, Tetramorium caespidum. The pavement ant can be one of the most frequent nuisance ants in some areas. They are small, blackish-brown ants with pale legs and antennae. As the name might suggest, pavement ants commonly nest under pavement slabs, especially next to lawn areas. Rocks and areas under slab construction homes have also been commonly used as nesting sites. Foraging in the home most commonly occurs during summer, but nests adjacent to homes can allow for foraging to occur year-round. Pharaoh ant, Monomorium pharaonis. One of the most persistently annoying and hard to control ants in homes is the pharaoh ant. Pharaoh ants are very small and yellow, pale red. Unlike most other ants, pharaoh ants have adapted well to nesting indoors, and colonies may spread throughout a building. In addition, pharaoh ant colonies readily split into smaller colonies when disturbed. Pharaoh ants have a wide range of foods that include jellies, grease, cake, and pet food. Thief ant, Solenopsis molesta. The thief ant is one of the smallest ants found within a building, similar in size to pharaoh ants. However, its habits differ considerably from many other ants, since it primarily develops in association with colonies of other ant species. Because of their small size, thief ants can move around in small tunnels of other ant colonies and may move about and kill other immature ants. Within homes, thief ants forage on greasy foods. Nests can occur in a wide variety of locations, but they are almost always located outdoors. General ant control. Sanitation is an important aspect of any ant control program. Crumbs, grease, food scraps, and other foods attractive to foraging workers should be eliminated. Heavy infestations of ants in buildings are rarely found where thorough sanitation is practiced. Sanitation is also important to increase the effectiveness of ant baiting. Most species of nuisance ants nest outdoors. Perimeter treatments with residual sprays applied around foundations can prevent many ants from foraging indoors. General ant control. For more permanent control, nests can be located and attacked. Dust are usually more effective for this than sprays, since the dust are more readily tracked into the colony. Also, slow-acting insecticides such as baits are the most useful, since they allow the forager time to return to the nest so the poison can be fed in the colony, killing queens and young. Control of some ants, such as carpenter ants and pharaoh ants, requires more specialized treatment. For effective control of carpenter ants, finding the nest is the ideal solution. If the nest can't be found, there are other alternatives. Carpenter ant baits are available, and there are residual products for treatments that can substantially drop the colony population. When carpenter ants are found in a building, they are either nesting inside the building or nesting outside of the building and entering to forage for food. In some circumstances, an entire colony may migrate from one nesting site to another to areas of wood associated with high moisture. Critical areas include clogged drain gutters, poorly fitted or damaged siding and flashing, wood shingle roofs, hollow porch posts and columns, and leaking doors and window frames. Look for wood in contact with soil and wood in crawl spaces or under dirt-filled slab porches. Finding carpenter ants. Piles of wood debris ejected from the colony. This debris has a shredded quality that looks somewhat like shavings found in pencil sharpeners. It's similar to that produced by some wood-boring beetles that are common in firewood. Sometimes this debris is deposited in the voids in the wall and isn't visible. 2. Windows are small openings to the nest. Windows may not always be present, since existing cracks may be used by the ants. 3. Ant activity. The ants often forage in kitchen pantries, garbage, and other areas for food. Often, relatively few ants are seen during the day, as they are more active at night. Swarmers. These may be found trapped in spiderwebs. Damaged timbers. The surface may appear solid, but by sounding, the damaged areas can be located. Sound detection is sometimes useful in carpenter ant nest location. An active colony at times produces a distinct, dry, rustling sound that may be heard from outside the nest. Sometimes the noise is very loud, but generally it can only be heard when conditions are very still and outside noises are at a minimum. Control of carpenter ants indoors should involve elimination of high moisture conditions that provide wood conditions suitable for carpenter ant nesting. Control of carpenter ants indoors should also involve insecticide application to nest and nest areas. Dust are especially effective in treating nest galleries. Nest treatments may be used with dust or in conjunction with sprays. However, spraying or dusting the infested area with residual insecticides without locating or treating the nest itself usually doesn't result in complete control. The insecticide should be applied to reach, as much as possible, areas inhibited or traveled by the ants. The extent of the gallery should be determined to whatever degree is practical by careful inspection and drilling. Control of carpenter ants indoors should involve baiting. If applied to areas of foraging activity, can also aid in colony control and elimination. Pharaoh ant control. Pharaoh ants are unusually well suited to nesting indoors, and most colonies will be located within buildings rather than outdoors. They are also poorly controlled with residual sprays, since irritating chemicals, including solvents and cleaners, may cause the nest to bud into separate colonies that can disperse throughout the structure. Pharaoh ant control. Use of slow-acting baits has been the most effective for pharaoh ant control.
Sweet baits, especially mint apple jelly, are readily accepted by foraging workers. However, pharaoh ants may later become saturated by the sweet baits and no longer accept them. Use of a combination of fat-based materials, such as peanut butter and honey, in combination with sweets are often effective for a longer period than are sweet baits alone. Pharaoh ant control. To improve bait acceptance, sanitation is essential. Failure to restrict other food sources will result in poor bait acceptance. Since the purpose of baiting is to get the ants to feed on the bait and return it to the colony, residual insecticide should not be used in the area of baiting. It is also important to avoid use of volatile cleaners and solvents, which may repel pharaoh ants. Residual insecticides can be used as a preventative treatment in areas where ants are not present. Common household pests, cockroaches. What you're seeing here on the left is an utica, a cockroach egg sac, and the life cycle of a cockroach on the right. Cockroaches are oval, flattened, fast-moving insects. They have long, hair-like antennae and a broad, saddle-like plate pronotum that covers the head. Adult stages of most species have wings, with the front pair being thickened and leathery. Cockroaches go through gradual metamorphosis with 3 basic stages in their life cycle: egg, nymph, and adult. The eggs are laid in bean-like egg capsules called utica, which may contain several dozen eggs. Cockroaches. These egg capsules are often dropped around food sources or glued to surfaces, although some cockroaches carry the capsule during its development. The immature stages are called nymphs. Several nymphal stages occurred, each separated by a molt. The nymphs generally appear like the adult stage, but they lack wings and are smaller. Typically 2 or 3 months pass while they complete their life cycle. Cockroaches. Cockroaches are among the oldest group of insects known, with fossils dating back 200 million years. As a group, the cockroaches have shown exceptional ability to adapt to and survive in a wide range of environments, including human dwellings. Most cockroaches can develop on a wide range of food, and their flattened body form allows them to move into most areas. Cockroaches have also developed a high level of resistance to commonly used insecticides. Cockroaches. Cockroaches can enter buildings and containers of many kinds. They also may enter around loose-fitting doors and windows and through utility lines, and they may travel through sewers. Once within a home, cockroaches tend to prefer warm, dark, moist shelters and are often found near kitchens and food handling areas. Since cockroaches are nocturnal, they are rarely seen during the day. Cockroaches. Aside from their importance as a household nuisance, they may soil areas with their salivary secretions and excrement, leaving an unpleasant odor. Cockroaches and cockroach parts also produce allergic reactions in some humans. Cockroaches haven't been found to be direct carriers of human disease. However, their habits of feeding on filth or diseased organisms make them well suited to mechanically contaminate food or utensils. They are suspected of helping to spread diseases such as dysentery, diarrhea, and food poisoning. German cockroach, Blatella germanica. Adults are pale brown to tan and about 1/2 inch long. Adults have wings and are distinguished by having 2 dark stripes that run lengthwise along the pronotum behind the head. This species has the highest reproductive potential of the house-infesting cockroaches. Females carry their egg capsule protruding from their abdomen until the eggs are ready to hatch. German cockroach, Blatella germanica. Females produce about 4 to 8 capsules in their lifetime. Each capsule contains 30 to 50 eggs, which hatch in about 28 days at room temperature. The eggs usually die if the mother is killed. Females live an average of 250 days. German cockroach, Blatella germanica. German cockroaches will generally be found close to moisture in food, such as in kitchens and other food areas, restrooms, and around plumbing fixtures. Surveys should concentrate in cracks and crevices, under tabletops, behind sinks, in cabinets, in motor areas of refrigerators, in and around kitchen equipment and similar sites. Infestations found scattered throughout a building, including non-food areas, indicate very high populations. Brown banded cockroach, Supella longipalpus. Brown banded cockroaches are the smallest of the more common cockroach, slightly smaller than the German cockroach. Brown banded cockroaches vary from light tan to glossy dark brown in color. The adult stages are marked with two light-colored bands at the base of the wings. Brown banded cockroach, Supella longipalpus. Brown banded cockroaches usually glue their egg capsules to surfaces in dark areas such as cabinets, chairs, boxes, drawers, and high areas of a building. Because of this habit, they are easily transported to new buildings. Females produce about 14 capsules during their lifetime, averaging 18 eggs in each capsule. Eggs hatch in about 50 to 75 days. The adult female may typically live about 200 days. Brown banded cockroach, Supella longipalpus. Brown banded cockroaches tend to scatter thoroughly through a building. They prefer areas of higher temperature, 80 degrees Fahrenheit or higher. Brown banded cockroaches tend to occur more often in homes, apartments, hotels, and hospitals than in stores or restaurants. Oriental cockroach, Blatta orientalis. Oriental cockroaches are not as common as the brown banded cockroach and the German cockroach. Oriental cockroach, Blatta orientalis. Adults are about 1 inch long and dark brown or black in color. Wings of the Oriental cockroach are short. Females only have small wing pads, while males have wings that only cover about 3/4 of their abdomen. Females drop egg capsules in warm, sheltered areas near a food supply. Each female produces an average of 8 egg capsules, each containing about 160 eggs. Under room temperature conditions, eggs hatch in about 60 days. Oriental cockroach, Blatta orientalis. Adult females may live about 180 days. Oriental cockroaches are almost always found around moist, dark sites. Common habitats include floor and storm drains, water meter boxes, around plumbing fixtures, moist crawl spaces, sewers, and around garbage. Oriental cockroaches may be found outdoors during the warmer months of the year. Oriental cockroaches are rather sociable, and clusters of them may be found in favorable habitats. They are seldom found on high walls, in high cupboards, or in the upper floors of buildings. Oriental cockroach, Blatta orientalis. Detection. The site should be thoroughly surveyed to determine the extent of the infestation and to identify the type of treatments that will be required. Fundamental to this is determining the cockroach species present. Since different cockroach species have differing habits, this will allow treatments to be better targeted. A search should be made of all suspected hiding places. Since cockroaches are less active during the day, this can be difficult. Flushing sprays of pyrethrins can be used to irritate cockroaches and cause them to move out of their hiding areas. Oriental cockroach, Blatta orientalis. Sticky traps or glue boards can also be useful to help detect cockroach activity and monitor the successfulness of a treatment. Several different types of traps exist, and some also contain the sex-attractant chemicals used by certain cockroach species. These traps should be placed in areas where cockroach activity is suspected, and they should be checked after a few days. Traps can also be used to help control cockroaches, but they aren't an effective substitute for other control practices. Oriental cockroach, Blatta orientalis. Sanitation is fundamental to cockroach control. Any methods that can be used to deny cockroaches the food, water, and shelter they need will greatly aid in control. Cleanliness and good housekeeping are essential. Food should be kept in tightly closed containers and should not be left exposed. This includes spilled materials, garbage, food scraps left in the sink areas, and pet foods. Water is an important need of cockroaches. Oriental cockroach, Blatta orientalis. Dripping faucets, leaking pipes, and other sources of moisture should be eliminated. Bottles and cans to be recycled should be stored outdoors if possible. Sewer openings should be screened. It is also important to remove potential sources of reinfestations. Cracks, crevices, and other openings should be sealed. Pipes should be caulked and sewer drains screened. All materials being moved into the building should be checked for evidence of cockroach infestation. Control. Several approaches to chemical control are possible. Regardless of the chemical or formulation chosen, applications made near regular hiding and breeding places will be most effective since they allow more contact. Chemical controls usually provide only temporary suppression, especially when they aren't combined with a vigorous sanitation effort. Another serious limitation of insecticides is the development by many cockroaches of resistance to the chemicals. Many populations of German cockroaches are no longer susceptible to several insecticides that formerly were effective. Control. Cockroaches are repelled by several chemicals and will avoid treated surfaces. Often, where no previous control has occurred, the initial treatment consists of a thorough cleanup or clean out. During this treatment, sprays or dust are applied thoroughly throughout the building. As a result of this thorough treatment, there is often an immediate reduction in cockroach numbers. However, cockroaches are rarely eliminated by a single treatment since egg capsules aren't killed. Also, some cockroaches may remain hidden in or migrate to untreated areas. Vacuuming is almost always the best first treatment option to quickly reduce the population and prevent scattering of the infestation. Monitoring with sticky traps or glue boards can help determine the success of the treatment. Sticky traps with food attractant. Sticky traps are a great way to identify areas of infestation and to monitor areas after treatment. Control. Control chemicals can be microencapsulated formulations, dust, insect growth regulators, IGRs, or baits. Choice of the type of treatment should be matched to the conditions of the infestation site. Treatments may involve sprays or crack and crevice treatments to provide a residual effect. Treatment. These applications leave a toxic residue on the treated surface that cockroaches pick up when moving across it. The length of time that treatments remain effective varies depending on such factors as the concentration of the chemical applied, choice of insecticide, and application surface. 2 to 4 weeks of residual activity is fairly typical with baits, dust, and IGRs lasting longer. Sprays should be applied to cockroach harborages with thorough emphasis on cracks and crevices. Avoid runoff and immediately wipe off excess spray. Oil-based sprays shouldn't be applied near open flames, to tile floors, or onto plants. Water-based sprays shouldn't be used near electrical outlets. Several precautions should always be taken when making insecticide applications for cockroach control. Pets should be removed from the treatment area during application, and all aquariums should be covered. If sprays are to be applied to areas where food, cooking utensils, or dishes are stored, these items should be covered or removed prior to treating. Furthermore, applications around these sites must be limited to cracks and crevices, avoiding exposed areas. Also, treatments made near air ducts and ventilation systems should be done with extreme care to avoid air contamination. Dust can penetrate cockroach hiding areas that sprays may not reach. They are also useful on rough surfaces or on surfaces that would absorb liquid sprays. They may kill the insect by having the chemical penetrate the insect body or be swallowed as the cockroach cleans its antenna and legs. When applied to dry locations, they also last longer than residual sprays. Dust should be applied as thin films since heavy concentrations can repel cockroaches. Some dust, such as boric acid, may be applied in water, which quickly dries, but to be effective, dust must remain dry. Dust are not appropriate for use in areas where they would be unsightly or cause contamination problems. Baits are generally long-lasting and can be applied to areas that can't be treated with sprays or dust. Often, baits may be placed inside small containers to help keep them away from pets and humans. To be effective, baits should be used in small amounts placed in many locations. Effectiveness of baits is greatly dependent on the amount of competing food sources available. If sanitation efforts haven't been thorough, baits perform poorly. I just want to mention on this slide, if any of you have worked in pest control situations where sanitation and competing food sources were an issue, baits are not going to be effective at these times. So whether you're dealing with a residential home or a restaurant or whatever the case may be, you have to make sure they have good sanitation. If not, you're not going to win the battle by baiting for cockroaches. We want to give a big thanks to bugwood.org for allowing us to use their photos and the individual photographers listed on this slide. The use of trade names in this publication is solely for the purpose of providing specific information or as examples. American Pest CEUs does not guarantee or warranty the product's name, and references to them in this publication does not signify our approval to the exclusion of other products of suitable composition. All chemicals should be used in accordance with directions on the manufacturer's label. Use pesticides safely. Read and follow all directions on the manufacturer's label.
Let's talk about termite identification and control.
Termite basics. In the United States, there are more than 50 termite species. In southern states east to west, drywood termites can live in all types of wood and can be found in any part of a house. Western subterranean termites, however, are ground-dwelling and must have a connection to the ground except in extreme cases. Subterranean termite colonies are the larger of the two, while the termites themselves are physically smaller. Subterranean termites are attracted to sources of moisture, such as areas around plumbing leaks and other ongoing structural issues. Subterranean termites. Subterranean termites live underground, where there is no light. When they do leave, they forage for food. In the forest, it is usually a fallen tree. In the city, it's a structure or the structure's contents. These are subterranean termites on the floor, where a file box had been sitting. Subterranean termites. Unlike drywood termites, they require contact with the soil or a constant source of moisture. They live in undecayed or decayed wood, usually with a moisture content around 14 to 18%. The advent of centrally heated homes has made it possible for termites to become a threat in virtually every region and state in the U.S. On average, there could be as many as 13 to 14 subterranean termite colonies per acre, which means that a typical home may easily have 3 to 4 colonies situated under or around it. Because there can be as many as 1 million subterranean termites per colony, the threat of infestation becomes a real one indeed. Subterranean termites cause more damage to homes in the U.S. than storms and fire combined. Subterranean termites nest in the soil to obtain moisture, but they also nest in wood that is often wet. They easily attack wood in contact with the ground. If wood does not contact the soil, they can build mud tunnels or tubes to reach wood several feet above the ground. These tunnels can extend for 50 to 60 feet to reach wood and often enter a structure through expansion joints in concrete slabs or where utilities or plumbing penetrations enter the house. Winged termites emerging from the ground out of doors near the house does not necessarily mean the house is infested, but it is a good reason to check further. Termites in the wood of homes or other buildings usually come from colonies already established in the soil. Biology. Termites are small, ant-like insects. However, they differ from ants in that they feed off of cellulose and wood. They have 4 wings of equal length and thick waist. Working largely unseen under the surface, they can tunnel through the wooden structural members in buildings and completely destroy them. Wood that comes in contact with the soil, such as exterior trim or cladding on your home, provides a perfect point of entry for a termite colony. Biology. Termites are social insects that live in colonies where labor is divided among a caste system. They have reproductive and soldier caste. In many termite societies, there is also a distinct worker caste, but the typical duties of workers, nest building, and food gathering, and feeding the reproductives and soldiers, are handled by the nymphs as well. Workers and nymphs do all the work. Soldiers' sole job is to defend the colony. The diagram on our current slide is showing a subterranean termite colony broken up by caste. As you can see all the way on the left, we have the wing form. In the center at the top, we have the male and female primary reproductives. To the right of that, there's an arrow that shows the eggs. There's an arrow down from there showing the nymphs. Another arrow kind of going back towards the center at the bottom showing the workers. At the bottom in the center, we've got the soldier adults, and all the way on the left at the bottom, we've got the secondary reproductives. Biology. Winged adults, often called swarmers, they are the primary reproductives. They emerge from colonies on colonizing flights during certain seasons of the year. After the flights, the male, the king, and the female, the queen, will pair up, lose their wings, and construct a small cell in the soil. They will mate, lay eggs, and rear the first group of workers. In colonies where the primary reproductives are not present, secondary reproductives without color or functional wings will often occur in large numbers. On this slide, we're going a little deeper into the castes in the termite colony. So as you can see on the left, we're showing the nymphs. These immature termites develop into workers, soldiers, and reproductives. As the nymphs become larger, they also begin to damage the wood. Next, we have the soldiers. These termites protect the colony. They have enlarged jaws called mandibles, which they use to defend the colony. They look like workers, but their heads are enlarged and darker colored than the workers. They comprise only 1 to 3% of the foraging termite population. Then we have the workers. These are the termites that cause most of the damage by eating wood, but they also maintain the colony, build and repair the nests, forage for food, and help take care of the young. Workers are the most numerous of the three castes. Reproductives. Reproductives can be primary or secondary. The secondary are found in mature colonies and serve as replacements if something happens to the primary reproductives. Wing productives are alates, or coal black to pale yellow-brown, flattened, and about 1/4 to 3/8 inch long, with pale or smoke gray to brown wings. Alates are also known as swarmers. Habits. Subterranean termites live in colonies underground, from which they build tunnels in search of food, able to reach food above the level of the ground by building mud tubes dependent on moisture for survival. Subterranean termite feeding follows the grain of the wood. Unlike drywood termites or other wood-boring insects, subterranean termites do not push wood particles or pellets, fecal matter, to the outside, but rather use it in the construction of their tunnels. This debris, along with sand and soil particles, is used as a form of plaster. Habits. They can form secondary nests above ground called aerial colonies. These independent nests may survive independent of the ground if there is a moisture source available. Such sources of moisture would be a form of a leaky roof or plumbing leaks. In the photo on this screen, you can see a subterranean termite mud tube coming from a second floor closet ceiling. This would tip you off that there must be a moisture leak in the attic, probably in the form of a roof leak or a plumbing leak, and you definitely are going to want to do more inspection to see what's going on up above. Another important thing to understand is the diet of subterranean termites. They're going to feed on wood and other cellulose material. Subterranean termites feed on wood and other items that contain cellulose, such as paper, fiberboard, and some fabrics derived from cotton or plant fibers. Termites have protozoa in their digestive tracts that can convert cellulose into usable food. This is money that has been stored in a coffee can in a garage and is partially eaten by subterranean termites. On this screen, you can see some pictures of drywood and subterranean termites. You can look at the photos and definitely see some differences. I'm going to give everybody about 15 seconds to review this. If you're listening on audio, the course will pick up in about 15 seconds from now. The current image is showing a western drywood termite colony development timeline. Year 1. After mating, the queen may produce 5 eggs and 20 nymphs and 1 soldier. In year 2, you may see 6 to 40 nymphs and 1 soldier by year end. In year 3, you may see 40 to 165 individuals by the year end. And in year 4, you may have 70 to 700 individuals by the year end, and the colony may begin producing swarmers. Termite basics. Drywood termites are called that for a reason. Moisture does not attract them, and they will infest wood that is dry. For drywood termites, fumigation is quite often the most reasonable and complete solution. Fumigation with bicane gas kills termites in both visible, accessible areas, and many houses are pre-treated for subterranean termites with the same or similar products to those used for post-construction treatment. These treatments are effective against the target, which is subterranean termites, but have little to no effect on other types. Subterranean termites can be controlled through pre-treatments because it involves treating the ground, which is where they live and enter the structure. Drywood termites, however, infest houses with no connection to the ground. Therefore, pre-treatments for them are done by the wood directly with applications of boron-based products. There are several options for post-construction foundation treatments. Products such as Thermador, Premise, Ultraset, Talstar, and others are among them. Premise and Thermador have different modes of action, but are used about the same. Premise is systemic in plants near the treatment area, however, and Thermador is not. Ultraset is designed for the chemically sensitive because its mode of action is unique in the way that it removes calcium within the insect's muscles. Talstar, Maxthor, Upstar Gold, Masterline Bifenthrin, and other Talstar generics are all repellent to termites and leave a barrier that in many cases won't kill subterranean termites, but instead will force them into other areas. Thermador SC is a suspension concentrate that forms a suspension when mixed with water. Thermador SC can be tank mixed, but should not be mixed with other products or their residues. In a vehicle-mounted spray tank, it can be applied in its diluted form for a subterranean termite foundation treatment at a rate of 4 gallons per 10 linear feet per foot of depth. Thermador HE is applied at a rate of 2 gallons per 10 linear feet per foot of depth when used normally, but mixed at a higher rate than Thermador SC. On this slide, we're going to be looking at how many lineal feet are in the treatment area. As the text indicates on the structure is 60 feet long and 40 feet wide. When looking for the lineal feet of a structure, it is important to note that you're going to add the total lineal feet of each side. The formula is going to be lineal feet on each side equals total lineal feet. When looking at a rectangular structure like we are now, you can understand that the top of the structure is 60 feet long. That means also that the bottom of the structure is 60 feet long. Using this same principle, the left side of the structure is going to be 40 feet wide, just as the right side of the structure is. That means to get the total lineal footage of the structure, we're going to add 60 feet, plus 60 feet, plus 40 feet, plus 40 feet, for a total of 200 lineal feet. Measuring a complete foundation layout and calculating the amount of termiticide. Looking at the current structure, you'll notice that there's 3 sections marked off. Look at each section and get an idea in your mind of what you think the lineal footage of each section is. The structure we've been looking at is a single-story home on a supported slab. House, garage, room addition are separate foundations. In step 1, we're going to look at what is the total lineal footage of each section. Number 1 is going to be 80 plus 32 plus 80 plus 32. Section 2 is going to be 12 plus 14 plus 12 plus 14. And section 3 is going to be 20 plus 16 plus 20 plus 4. No treatment is done across the overhead door. To finish our calculation of the linear footage on this structure, we're going to look at Section 1, which has a total of 224 linear feet, Section 2, 52 linear feet, Section 3, 60 linear feet, which gives us a grand total of 336 linear feet. Step 1. How many gallons do I apply? Take the total lineal feet you are treating. Example, if the perimeter of the house is 200 lineal feet of treated area, you must multiply 200 lineal feet times 4 gallons per foot, and that would equal 80 gallons of dilution. Multiply total lineal feet of all treated areas by 0.4 for the total amount of dilution. If the foot of depth is greater than 1 foot, multiply your final answer by the actual foot of depth. Step 2. How much chemical do I add? Thermidor SC, for a 0.06% finished solution, multiply the total gallons you will need by 0.8. Thermidor SC, for a 1.25% finished solution, multiply the total gallons you will need by 1.6. Step 3. How many seconds per foot do I treat? Put the tip you will be using on the gun, set the pressure to 25 psi. If your rig pumps out 1 gallon in 45 seconds, then 45 seconds times 4 gallons equals 180, divided by 10 lineal feet equals 18 seconds per foot times foot of depth equals total seconds per foot. Multiply how long it takes to pump 1 gallon. Multiply that answer by 4 and then divide by 10. That'll leave us with 4 gallons per 10 linear foot to foot of depth. Pre-treatments. Gallons of concentrate. The number of gallons of a manufacturer's concentrate, which is mixed with a water carrier. An example of a concentrate Thermidor SC with 9.1% active ingredient. Gallons of spray. The result of mixing the concentrate with a diluent, usually water. This is the finished product that is applied to the site. Percent of active ingredient desired. This is the amount of active ingredient that is contained in the finished spray. Normally the label will state what percentage this should be. It is always expressed as a whole number when used in the formula above. Example is going to be 1% is not 1, not 0.01. 5% is 5, not 0.005. It is the weight of 1 gallon of water expressed in pounds. It is always the same thing. Termite pretreatment formulas, chemical barriers. Chemical barriers, which are used to control subterranean termites, are usually of 2 types, horizontal and vertical. Horizontal area. To establish a horizontal barrier, gallons of spray are applied to square feet. The product label will state the rate of application, such as 1 gallon per 10 square feet or 1 1/2 gallons per 10 square feet. To determine the square footage of a structure, the length L of the structure is multiplied by the width W of the structure. Length times width equals square feet. For example, if a home is 170 feet long and 60 feet wide, the square footage encompassed by the home would be 170 feet length times 60 feet width, for a total of 10,200 square feet. To determine the gallons of spray for the home mentioned, first read the label. In this case, the label states to apply the spray at 1 1/2 gallons per 10 square feet. Then divide the square footage of the home, 10,200 square feet, by the square footage given on the label, 10 square feet, and multiply the gallons given on the label, 1 1/2 gallons. This problem would look like this. 10,200 square feet divided by 10 square feet times 1 1/2 gallons equals gallons of spray. 1,020 times 1 1/2 gallons, or 1.5, equals gallons of spray, or a total of 1,530 gallons of spray. It therefore takes 1,530 gallons of spray to establish a horizontal barrier for a home that is 170 feet long and 60 feet wide. Vertical. To establish a vertical barrier, the gallons of spray are applied to linear feet. To determine the linear feet of a foundation, add all the sides together. If both sides of the foundation are to be treated, add all the sides together and multiply by 2. This will give you the total linear feet to be treated, both inside and outside of the foundation wall. For example, if a foundation is 150 feet long and 80 feet wide, then the diagram of the structure would look like this. The linear feet to be treated would then be figured out as we have before by doing everything in the parentheses first. This would be 150 feet plus 80 feet plus 150 feet plus 80 feet. That gives us a total of 460 feet, and we're going to times that by 2, which gives us our final total of 920 total linear feet. To determine the gallons of solution for the structure mentioned in this example, first, read the label for the application rate. In this case, the label states to apply the spray solution at a rate of 4 gallons per 10 lineal feet. Then divide the linear footage of the structure, 920, by the gallons on the label, 4 gallons. The problem would look like this. We're first going to take 920 feet and divide it by 10. This will give us a total of 92. We're going to times that number by 4 gallons, which is going to be the gallons of spray solution. That'll give us a total of 368 gallons of total spray solution. It therefore takes 368 gallons of spray to establish a vertical barrier for a structure that is 150 feet long and 80 feet wide. Termite pre-treat formulas. For example, if the support posts on a pier and beam structure are 1 feet long per side and there are 24 posts, then there would be 96 linear feet to be treated. 4 sides to each post times 1 foot equals 4 feet times 24 posts, which equals 96 feet. Some foundations are hollow block. In this type of structure, the stem wall is treated on both sides and the hollow block is treated inside. In this application, the gallons per linear foot is not doubled. Treatment specifications. Many of the subterranean termite products can be used for drywood termite local treatments. These products are used as a finished solution to inject in the termite galleries and kill entire colonies. For those that have little experience or are unsure of the gallery locations, drilling in a W pattern into the long side of the wood gives you a greater chance of success. For those with more experience, in cases where galleries are more obvious, less holes and less of a pattern may be acceptable. Some drywood termite products come in an RTU or ready-to-use form. The more common products are aerosols and canned pressurized products like Primus Foam, Termidor, Psychic CS, or Pro Citra DL. Those injecting should be careful of injected product escaping through a kickout hole and other holes that may have been made by the technician. Crawl, walls, and attic borate calculations. Crawl space to calculate square footage, multiply flat ground square feet times 1.6. This is going to equal the total square feet of treatment surface. Walls, take the total height and the total length and multiply by 1.4. Attic rafter calculation, multiply square feet of attic floor times 2.2 for square feet of treatment area of rafters. Square feet equals length times width. 60 feet times 40 feet is going to give us a total of 2,400 square feet. Walls that are 8 feet high and 60 feet long times 1.4 are going to give us a total of 672 square feet. 1 pound of board defense or Timbor covers 200 square feet. Divide your totals by 200, which is going to equal approximately how many pounds you need. Treatment specifications. Borates are mineral-based products that work by killing the protozoa within an insect's digestive tract once it is ingested. In the case of termites, it is applied to wood either topically or injected. It penetrates the cellular structure of wood, making the wood harmful to any insect that would feed on it. It is not harmful to non-wood destroying pests when used this way. In a dry formulation, however, it can be handled improperly or used for that purpose. Boron can be used as a local treatment for drywood termites or can be used as a preventative treatment for all termites. Borate applications. Areas such as attics and crawl spaces are the most viable treatment areas since exposed wood can be drilled and injected and then all of the surrounding wood can be broadcast sprayed. Wall voids and other closed areas can be treated with an expanding boron foam that is applied using special foam machines. These foam machines, or foamers, as some people refer to them, have a tank in which boron is added to an expanded foam adjuvant that forces the product through the nozzle with the consistency of shaving cream. Boron can also be applied in its finished solution to newly built homes while they are in the framing stage. In this stage, while most of the wood is exposed, a treatment can be applied for the sake of leaving a long-term residual. These treatments are generally warranted longer, and when combined with the subterranean termite pretreatment of the soil, will vaccinate a home against termites for several years. Boron. This is boron in its unfinished form to the finished formulation you may be familiar with. This is a boron application for new construction. The green is a marker dye that will lose its color over time. The dye is used to make certain all surfaces are treated. This is another whole structure treatment with boron. Whole structure treatments may require 2 to 4 site trips so all the wood can be treated as it's put in. Keep in mind it is critical to mix it completely. We used a large mixing blade with a high-speed drill for small jobs and a barrel with an 1800 RPM electric motor for larger jobs that we took on site. This is the small mixer we used. This is a custom-made mixer consisting of a 55-gallon line drum and an 1800 RPM motor on a custom pallet to allow for mixer adjustment. Inside there is a sump pump to move the mixture from the barrel into a tank. If the job required more than 55 gallons, we would take the mixer to the job site. Some instances may require a foam application, such as in areas over finished rooms. The foam reduces the potential for runoff, decreasing the possibility of damage to ceilings below. The foam allows the boron to sit on the wood longer for absorption. Another use for boron applications is the treatment of wall voids for control and prevention of subterranean and Formosan termites. In this picture, the blue tape indicates where the studs are, and you will notice holes just above the floor, which are 2 inches over the top of the bottom plate. The wall cavity is injected with boron foam to a minimum of 18 inches up from the bottom. This prevents subterranean termites from building tubes up the studs. And of course, if they attempt to consume the wood, they will die. When foaming wall voids, use a moisture meter to accurately determine how high the foam is. This foam machine was custom built in the early 2000s. The volume, liquid air, and pressure can be adjusted separately for treatment requirements. This is injecting a wall void with boron foam. Slabs. There are several foundation types, and a general understanding of what makes each of those different will allow for better treatments. In some cases, holes may need to be made sideways or at an angle to allow treatment in these and similar areas. These treatments are referred to as vertical treatments and horizontal treatment. There are 3 common types of slabs that include monolithic, floating, and supported. The names are somewhat descriptive of their design, and they each serve a different purpose. Supported slab. A supported slab is poured in 2 parts with the main slab resting on or being supported by the footing. The areas where the slab meets the foundation of the footing is referred to as an expansion joint. Expansion joints may allow subterranean termites to enter the structure. Oftentimes, product will come up through these expansion joints. This does not denote product failure and is generally not relevant. Floating slab. Floating slabs are similar to supported slabs, but nothing is supported. The expansion joints are similar to that of supported slabs and can allow termite access. This is most commonly found with room additions, garages, and outdoor patios. Monolithic slabs. Mono implies one. This means that the slab is one big piece and has no expansion joints. Extra info. How many seconds per foot? 4 gallons at 10 Leo feet to foot of depth. If your rig pumps out 1 gallon in 45 seconds, then this means that 45 seconds per 4 gallons is going to mean you're going to put out 4 gallons in about 180 seconds. Assuming the structure has 1 foot of depth to the footer, that means we're going to spend about 18 seconds per foot on the 10-foot stretch to get out our 4 gallons, which will equal a total of 180 seconds. How much should I apply? If the house is 200 lineal feet of treated area, you multiply 200 lineal feet times 4 gallons per foot, which equals a total of 80 gallons of dilution. If the foot of depth is greater than 1 foot, multiply your final answer by the actual foot of depth. Crawl and attic, borate calculations. Crawl space to calculate square feet. Multiply flat ground, square feet times 1.6, which will equal square foot of treatment surface. Attic rafter calculation, multiply square feet of attic floor times 2.2 for square feet of treatment area or rafters. Extra info. Bat traps. Bat traps are treated at a rate of 3 gallons of diluted material. Treatment. Always apply chemical from a sub-rig at 25 psi or less. Trenching is a maximum of 6 inches wide and a depth of 6 inches. Rotting in soil is spaced every 6 inches. When drilling holes, you need to space them at 12-inch intervals or less. You must maintain a continual barrier. When treating in a crawl, after you trench, use the short rod with the straight tip to apply the chemical. When treating the exterior, use the long rod with the straight tip to apply the chemical. When treating below a slab, always use the 180-degree tip pointed toward the foundation. When treating next to the plumbing under a slab, use a 360-degree tip. When rodding the exterior perimeter of a foundation, use the 90-degree tip pointed towards the foundation. When treating trenches in sub-areas or exterior trenches at the foundation, use the straight tip.
For the sake of today's training, we needed a label to talk about as our treatment product. We decided on Termidor SC because it is a common product used in the industry. We do not support any specific products, but we did need something to use, and we thought this would be a good one. Termidor SC is a suspended concentrate that forms a suspension when mixed with water. Termidor SC can be tank mixed, but should not be mixed with other products or their residues. So keep in mind that this is a suspended concentrate, and it's probably only going to be stable for about 3 days in your tank. You really don't want to try to use the product later, and as we're going to talk about more, you don't want to overmix on the amount of product you need for a job anyways, but make sure you're not using it after about 3 days because then it's really not going to be effective. The other thing you need to know is your tank needs to be clean before you mix any products. Termidor SC is no exception, especially because it's a non-repellent product. You really don't want any other products or the residues in your tank because it's going to be counterproductive to the termite treatment you're trying to perform. Another thing you need to be aware of is the Termidor SC mix rate for post-construction treatments. Termidor SC is labeled for use at 0.06, 0.09, or 0.125% finished dilution. The 0.06 finished dilution should be used for typical prevention and/or termite control situations. Where severe termite or other wood-infesting pest infestations or problem soils or problem construction types exist, it is advisable to use 0.09% or 0.125%. So you really need to figure this out during your inspection and your prep, what you're dealing with as far as the infestation and the soil type, and make sure you're using the right calculation of the product. Something else that's important for you to know is the Termidor SC finished dilution mix rate. We have a table on here that shows the mix rate by desired finished dilution rate of Termidor SC. Most common control and prevention situations will call for 0.8 ounces per gallon of water or a 0.06% finished dilution. And I want you to look at the chart on the left where it says Table 2, 0.06 ounce of Termidor SC finished dilution. Let's go about 4 columns down where it says 100 gallons of finished dilution. This would actually take 99.25 ounces of water and a 78-ounce bottle of Termidor SC. So the 0.80 ounces per gallon is not 100% true. That would be true if you're just mixing 1 gallon, but when you're mixing 100 gallons, you can actually use a 78-ounce bottle of Termidor SC. You can actually purchase the bottles in that quantity, and it makes sense because then you use 1 bottle per 100 gallons of water. Now there's obviously different rates you could do. You could use 50 gallons, you could use 25. It really doesn't matter, but the point of what you need to know is that the Termidor SC is going to be mixed at the rates on the label, and you always need to follow the label. I always suggest to people to have a 100-gallon tank because most of the time you can mix all your Termidor SC at once and you don't have to go through the process of mixing over and over again as you would if you had, say, a 25-gallon tank. So keep in mind the label's the law. You need to do a good inspection. You need to know exactly what your calculations are.
Then when you do your mixing, you're going to have all your ducks in a row so you don't have to worry about issues later. Let's talk about the calculation for Termidor SC by linear footage. You must have your linear footage prior to mixing your Termidor SC. I know you probably remember that from us talking about it earlier in the course. This is going to be crucial to make sure that you mix the right amount of termiticide. Your calculation worksheet for Termidor SC is below for most crawl space and slab homes with 1 foot of depth to the footer. Your formula is as follows. You're going to divide the linear footage by 10-foot stretches, which is going to give you a number. You times that number by 4 gallons per 10 linear foot stretch, and you get a total finished solution needed. Make sure this is done right because once again you need to mix the right amount of product because having too little or too much is not a good thing for your treatment. Let's go ahead and do a practice calculation for Termidor SC. Let's say you have a 200 linear foot home with 1 foot of depth from the grade to the footer. Your calculation would be as follows. 200 linear feet divided by 10-foot stretches equals 20. You're going to times that by 4 gallons per 10 linear feet, which is a total of 80 gallons of finished solution. That is 200 linear feet divided by 10-foot stretches times 4 gallons per 10 feet for a total of 80 gallons of finished solution. This is a really simple formula that works time and time again, and you need to make sure you have this on a worksheet or you have this available to you and your technician so you don't have to worry about calculations out in the field. You can also go back to your graph at any time to make sure you have the correct linear footage and make sure all the numbers add up. Another calculation you'll need to perform to do a termite treatment is calculating masonry and block voids. First, you get your linear feet of the treatment area added together. The calculation for this type of treatment is as follows. It's going to be linear footage divided by 10-foot stretches divided by 2. The treatment rate is 2 gallons per 10 linear feet in these types of areas. So these types of areas are definitely different because they are going to be a void area and it's not going to be down into the soil. So you're only going to need about half the termiticide you would if you were doing a trench and treatment area. Let's look a little further in depth at treating masonry and hollow block. Treating hollow block voids involves drilling every 12 inches using a hammer drill with a masonry bit. These holes must be drilled below the sill plate and as close to the footing as possible. Make sure to cover the holes with termite plugs and use mortar mix to cover over the plugs. So you can see in the photo here that obviously we're drilling the holes as shown on top about every 12 inches apart, and it works really well with a masonry bit and a hammer drill as shown here. So keep in mind this can be a pretty simple type of treatment, and basically you're just treating hollow areas, so it's going to be easy to pump the termiticide in there, put the plugs in them, and then use mortar to cover them back up when you're finished. Another type of home you're going to need to know how to treat is a brick style home. You're going to need to know that you drill about the distance of every other mortar joint when treating these types of homes. A good rule of thumb is to drill about 3 bricks up from the exterior grade. So we talked a little bit about this before. Obviously you want to drill above the footing. You definitely don't want to worry about that. So you'll drill about 3 bricks up. And as long as you're drilling in the range of about every other mortar joint between, you should be fine for doing the treatment in a brick style home. Another type of home you may come across is a basement style home. Basement homes are a little different because they generally have a footer over 4 feet deep. Termidor SC is applied at a rate of 4 gallons per linear foot to 1 foot depth of the footer up to 4 feet in depth. This makes the calculation on these much harder. I can tell you throughout the years I've had a lot of people come to me because they have a lot of trouble understanding how to treat these types of homes. We're going to talk further in depth on this in the coming slides. Let's do a little calculation on a basement home. Assuming this home has 200 linear feet as we've been using for our calculations, we're going to take the 200 linear feet and divide by 10, which again would be the 10-foot stretches we've talked about from the beginning. This would give us a number of 20. The rate of Termidor will be 16 gallons per 10 linear feet, which is 4 gallons per 10 linear foot per depth of the footer up to 4 feet. So we're going to say this has an 8-foot depth footer, so that makes it pretty simple that it's going to be 16 per 10 for the sake of this calculation. Continuing our calculation for the 200 linear foot home on the basement we've been discussing, you're going to take the 20 and times it by 16 for a total of 320 gallons. So basically for a 200 linear foot home with an 8-foot depth footer, we're going to need 320 gallons because we're taking the 200, dividing it by 10, and timesing it by 16 to get our total gallons. This is the amount of finished Thermador SC at 0.06% required to complete the perimeter Thermador SC treatment on this home. Let's look at something that's a little bit more complicated. We need to learn how to treat the soil to each 1 foot depth of the footer per linear foot. This is a little more complicated than it sounds, and is probably one of the toughest things I've had for people to learn through the years. The first foot is going to be pretty simple. As you can see in the diagram, we're going to treat the first foot of soil down to what would be a standard footer, the same way we always would. You're going to do maybe 6 seconds per linear foot, treat it, and then move on. The problem is when you get to that second foot, how are you going to treat it? Obviously, you're going to have to push the rod down in the soil about 12 inches. Now, we would do the same 6 seconds per linear foot, but you need to keep in mind that your rod has to be about 2 feet down in the soil. The other thing you need to know is when you go to the third foot, you're going to have to push the rod another 12 inches down in the soil. Again, you would use your same 6 seconds per linear foot. But keep in mind you need to treat each layer as evenly as possible. It can be a complicated thing, and the only thing I can tell you about this is it's going to take some time and some knowledge and experience for you to be able to do it. But I want you to understand that that's the way it needs to be treated, and you need to follow those principles.
Next, we're going to look at Category 7D, Community Insect, Mosquito Identification and Control. All mosquito larvae depend on still, stagnant water to develop into adults. This includes habitats like ditches, swamps, marshes, basins, pools, depressions, and small natural man-made containers such as tires, buckets, and trash cans. While many of these environments can be managed with larvicides or biological controls, there are also physical control methods that can offer more lasting results. Let's talk about source reduction in specific habitats. Source reduction involves any technique that physically changes or eliminates a mosquito breeding site, making it unsuitable for the mosquito life cycle to continue. This can include removing discarded tires, filling in low-lying areas, and enhancing drainage systems. It may also involve intentionally flooding certain areas to flush out larvae and boost access for natural predators like fish. Next are some source reduction strategies tailored to specific habitats you might encounter in your area. Artificial containers. Any object that can hold standing water for 5 days or longer has the potential to become a mosquito breeding site. Common examples of artificial habitats include cans, buckets, old tires, clogged gutters, trash cans, cemetery vases, children's toys, abandoned swimming pools, and plastic tarps. These environments are ideal for many domestic mosquito species such as Aedes aegypti, Aedes albopictus, Aedes triceratus, and Culex. Effective source reduction in these habitats focuses on sanitation and education. For disposable items, work with homeowners to ensure that unwanted objects are removed. Trash cans should always be tightly covered, and if lids are missing, encourage property owners to drill holes in the bottom to prevent water accumulation. For those using rain barrels, it's essential that all openings, including the often overlooked overflow hole, are sealed. Items like buckets and watering cans should be turned upside down to prevent water from collecting. For permanent containers, such as bird baths or plant saucers, advise homeowners to flush them out weekly with fresh water. In many cases, source reduction can be combined with other control methods like larvicides or biological control for enhanced effectiveness. Natural containers. Natural containers include any natural structure that can hold water for 5 or more continuous days. Examples include tree holes, Aedes, Triceratus, and rock pools, Aedes japonicus. If tree holes become a problem, they can be filled with sand or other materials to prevent water collection. Swamps and marshes. Swamps, flooded woodlands, and marshes are common mosquito larval sites for many species, including Aedes, Taeniorhynchus, and Aedes sollicitans salt marsh mosquitoes, Anopheles quadrimaculatus permanent water swamps, and many species of Culex and Culicida. Permanent water mosquitoes often prefer deeper water containing emerging vegetation, which provides larva protection from predatory fish and insects. In the shallower parts of the swamp and upper marshes, where water levels fluctuate with rains and high tides, floodwater mosquitoes may breed in great abundance during periods of inundation. Floodwaters. Many low depression areas can create floodwater habitats for species such as Aedes vexans and Saurophora columbii. Floodwater habitats include any area that temporarily floods for at least 5 days or more after heavy rains. This would include lawn depressions, pastures, erosion areas, tire ruts, depressions made by animals or human activity, and silt deposits. While many of these areas do not remain flooded in between rains, they can produce very large numbers of mosquitoes. Because these types of floodwater sites are temporary, improving habitat for predators, fish, is usually not an option. Therefore, filling in low-lying areas might provide a more long-term solution. Mosquito control programs should consider monitoring these sites closely after heavy rains. This is a very interesting area in mosquito control, in my opinion. When you're working on properties like this, whether they're commercial, residential, or whatever the case may be, you've got an area of standing water that's going to allow mosquitoes to breed. What we need to figure out is these more long-term solutions. A lot of times that's going to take you working with the customers as well. It's not going to be as easy as you just going out and fixing this problem yourself. A lot of times you're going to need to work hand in hand with the customer or the client to make sure they help you in the solution. Now in this case, some grading could be at hand. Is that something you might be able to offer as a mosquito control company? Yes. But I would say probably 99% of you don't want to get into this type of business. You may even want to make a relationship partner with somebody that does grading and things like that, and have a good referral source to help out your clients in instances like this. Retention and detention basins. After heavy rains, retention and detention basins are designed to collect and move water away from roads and buildings. Detention basins are designed to temporarily detain water for a short period of time, less than 5 days. These types of habitats often become mosquito problems when they become clogged and water is not flowing. Source reduction efforts include improving drainage and unclogging basins. Retention basins are different from detention basins in that they are designed to retain water for a longer period of time, more than 5 days. Ditches. Drainage and septic ditches are a specific type of man-made structure that is used to help collect and move rainwater away from roads and buildings. These type of habitats are ideal for species of Culex that prefer more organic water, such as Culex quinquefasciatus. Source reduction of ditches can be problematic, but if water movement can be improved, it could provide a more long-term solution. These type of habitats should be monitored and controlled frequently, as Culex quinquefasciatus is the most important vector species of West Nile virus in the state. Other habitats. Highways and railroads are almost always built on an embankment, creating a type of dam that often blocks natural drainage. Culverts are designed to allow for artificial drainage, but improper design or installation can result in undrained areas where mosquitoes can breed. Also, borrow pits, from which roadbed fill is taken, make good larval habitats if not properly engineered. Let's talk about specific non-chemical control measures. Control measures for source reduction fall into 6 broad categories: drainage, flushing, water management, filling, sanitation, and education. Drainage. Often mosquito habitats exist because areas are not properly draining. Improving drainage in areas can help ensure that water is moving as it should. Mosquitoes do not like moving water, and not collecting in low-lying areas. Unclogging ditches and basins can help improve water flow. Where the land is high enough for gravity drainage, simple ditching to promote rapid runoff of rainwater can be an efficient means of preventing mosquitoes. Water management strategies. Proper water management can minimize the wet-dry cycle conducive to floodwater mosquito breeding. Filling. Oftentimes, small lawn depressions in low-lying areas can be filled to prevent the collection of water. Soil, road debris, or canal dredging may be used to fill and eliminate areas where mosquito larvae occur. With sanitation, artificial container reduction can be extremely important, especially in urban areas. Gutters and downspouts should be monitored and flushed out regularly. Trash cans can produce mosquitoes if not properly covered. Local laws may help justify enforcement of cleanup if necessary. Education. Education of property owners to employ sanitation in yards can play an important role in reducing mosquito production in residential areas. The list of things that can be done by homeowners is almost endless. Filling plant trays with sand, not leaving children's toys out, removal of trash, washing bird baths and pet water dishes, and stocking ornamental ponds with fish are just some of the important components of reducing breeding sources. Let's talk about biological control. Biological control is the use of natural enemies to control a target pest. While mosquitoes have many natural enemies, birds, bats, spiders, beetles, and ants, very few are commonly employed in controlling mosquitoes. Natural enemies used in biological control include parasites, predators, and pathogens. Parasites are organisms that live inside a host and feed on tissues and fluids. Nematode worms are an example of a mosquito parasite that could be explored as a biological control option. Predators are animals that immediately kill and feed on a prey organism. While there are many predators that eat mosquitoes, the most common biological control agents are fish and copepods that feed on the larvae. Pathogens are any type of microorganism, virus, bacteria, fungus, protozoa that cause disease or death in a target organism. Bacterial-derived products such as Bacillus thuringiensis, Israelensis, BTI, were once classified as biological control agents. However, they are now grouped into a special category called biorational control products. Also known as biopesticides, these slightly differ from biological control methods since these are pesticides that are derived from natural materials such as animals, plants, bacteria, and certain minerals. We will focus on the use of predators because they are the most commonly used biological control agents in mosquito control. Next, we'll look at predators of mosquito larvae. Numerous predators of mosquito larvae and pupa have been investigated for mosquito control, including fish, turtles, tadpoles, cyclopoid copepods, tadpole shrimp, tripods, aquatic bugs, notonectids, embellostomatids, aquatic beetles, didicids, dragonfly and mayfly, nymphs, planarians, and hydra. Only fish and cyclopoid copepods are used operationally because they have two essential properties for control operations. 1. Sustainability, and 2. Suitable supply sources. Fish and copepods can be collected from large natural populations or mass-produced at a reasonable cost. Therefore, there is typically a constant and suitable supply source for both. Second, when introduced to breeding sites, these predators multiply to numbers that are large enough to kill virtually all mosquito larvae, and they maintain their numbers for extended periods of time. While other natural predators can be employed, their regular use in operational programs might be challenged by cost, sustainability, and whether there is a suitable supply source. Fish have been in widespread use for more than 70 years. Fish are effective since they meet both criteria in that they can sustain themselves in field and there are multiple supply sources. Fish feed on a variety of food sources in the absence of available mosquito larvae. Having a broad diet allows these fish to maintain themselves in numbers sufficient to eat almost any number of mosquito larvae that might periodically appear. Many kinds of fish are effective for mosquito control, but top minnows, Poeciliidae, and killfish, Cyprinodontidae, are used most frequently because they are small and abundant, making them convenient to capture and transport, and they usually thrive in large numbers when introduced to mosquito breeding habitats. The mosquito fish, Gambusia affinis, a species of top minnow, has been so effective for mosquito control that it has been used more than all other species of fish combined. Gambusia is particularly useful because it thrives in a broad array of aquatic habitats including freshwater, brackish water, clean water, or polluted water, and it tolerates a wide range of temperatures 1 to 38 degrees Celsius. The recommended stocking rate for Gambusia is 0.5 to 1.5 pounds per acre, pound equals ca.500 fish. Control is usually rapid, though maximum control may be achieved only after the fish have had a month or two to build up their numbers. For example, Gambusia usually builds up to about 5,000 fish per acre in rice fields. Smaller stocking numbers are acceptable, e.g. 0.2 of a pound per acre, if it is possible to wait an extra few weeks for the population to grow. Guppies, Poecilia reticulata, are a top minnow used for mosquito control in some of the conditions where Gambusia is not suitable, such as excessively polluted water. Guppies have a major limitation. They can survive only in water above 10 degrees Celsius and thus need to be reintroduced into control areas at least once a year. Some limitations to using fish. It is common for fish to eliminate almost all mosquito larvae, but there are situations where fish are not so effective. For example, in aquatic vegetation, larvae can hide from fish. Some vegetation, such as spartina grass and marshes, can be so thick that fish have no access at all. Fish may also be temporarily ineffective when aquatic animals other than larvae become so abundant that the fish prey on those animals instead of the mosquito larvae. Fish cannot survive for long in an aquatic habitat that is very small, e.g. a discarded tire, nor can they survive when a site dries up. Therefore, other organisms such as copepods can be ideal in small habitats. Copepods. Copepods satisfy both criteria for operational use in that they are sustainable and there are adequate supply sources. Copepods are convenient and inexpensive to produce and transport in large numbers and are particularly suitable for some mosquito habitats where fish will not work. Copepods are tiny crustaceans, 1 millimeter in length, and are abundant in nature almost everywhere there is water. They are voracious predators, and the largest species, Mesocyclops and Macrocyclops and Megacyclops, prey on first instar mosquito larvae. Smaller species of copepods generally are not large enough to be effective predators of mosquito larvae. Because copepods are so small, they thrive in habitats that are too small for fish. They can also move easily through the middle of thick aquatic vegetation that fish cannot penetrate. Copepods can survive when a site dries up, provided the soil retains some moisture, and re-emerge when a site floods, just in time to consume hatching mosquito larvae. Application of copepods and tires. The most established use of copepods is for control in discarded tires. They can survive in tires as long as the tires retain moisture, which can be periods of months or years. Tires in wooded or otherwise shaded areas are particularly suitable. The best species for tires is Mesocyclops longicetus, and the best season during which to introduce it to tires in Louisiana is spring. Copepods can be introduced into tires with a backpack sprayer. Just keep in mind, depending on what state you're in, there's different times of the year that would be better to introduce the copepods. In our more northern and cooler climates, we need to think about that early summer range. You just want to make sure it's heating up enough that the mosquitoes are starting to breed. So keep in mind everything we talk about can vary a little bit state to state, and you need to understand and monitor your local weather. A single fertilized adult female introduced into a tire will produce enough offspring in 2 months to control any hatching of mosquito larvae. Placing as few as 50 to 100 adults per tire will provide immediate control of all new Aedes larvae that hatch within the tire, and they will continue to kill all larvae as long as they survive in the tire. If a tire is newly discarded and therefore completely clean inside, it may be necessary to put a small amount of food, e.g. a few grains of rice, in the tire to sustain the copepod population. If there are mosquito larvae in the tire at the time of introduction and immediate control of late instar larvae is desired, it is best to apply microbial larvicides simultaneously in order to kill any larvae too large for the copepods to kill. Only one application of larvicide should be required, as the copepods will deal with any subsequent hatching of mosquito larvae. Application of copepods in larger habitats. Cannibal mosquitoes. Toxorynchides mosquitoes are large, non-biting mosquitoes that lay eggs in containers. Their larvae prey on other mosquito larvae, while adults do not blood feed. Some species of Toxorynchides can be mass-produced in the laboratory for introduction into containers. They can be introduced as eggs or larvae, but the most effective way is to release gravid females so that they can deposit their eggs in containers. The great strength of Toxorynchides is the abilities of females to find inconspicuous containers, including ones that are inaccessible to mosquito control operators. A single treatment with Toxorynchides will last about 3 weeks, which is the time it takes for Toxorynchides larvae to pupate. Toxorynchides should be used in conjunction with conventional source reduction to control hidden and accessible containers that are not eliminated through other means, e.g. plugged rain gutters that collect rainwater or tree holes in woodlots near residential areas. Toxorynchides amboinensis is an exotic species that has been mass-produced successfully and released with encouraging results. During a 7-week study in New Orleans, A.E. aegypti populations were reduced 95% when adult female TX amboinensis were released in conjunction with ground ULV treatments. Comparable A.E. aegypti populations were reduced by only 30% when malathion was used without TX amboinensis. The main limitation of TX amboinensis is that it cannot reproduce to maintain a long-term field population under some conditions. It is therefore necessary to release large numbers of TX amboinensis every few weeks to maintain control. The release rate should be about 50 adult female Toxorynchides per acre. Improving habitat for biological control. Agents and natural enemies, mosquito control programs, can help strengthen both natural enemy and biological control populations by monitoring habitats. Since most biological control is focused on larval stages, aquatic habitats can be modified to improve survival and sustainability of predators. Application of insecticides. Several broad-spectrum pesticides can potentially kill predators of mosquito larvae. Therefore, habitats being treated with biological control agents, such as backyard swimming pools, should be evaluated in areas recently treated with adulticides. Many larviciding products, such as Bacillus thuringiensis VAR, Israelensis BTI, are specific to mosquito larvae. Therefore, product selection can impact biological control success. Control of immature mosquitoes. Larval control involves a 2-step process, starting with the identification of the mosquito species, their developmental stage, and the associated habitat. Once you have this information, you can select the appropriate control method, whether physical, chemical, biological, mechanical, or decide that no action is needed. By identifying the species and the habitat, you can determine the best approach. For instance, Aedes albopictus and A.E. aegypti can often be controlled by removing and disposing of artificial containers. Refer to the source reduction section. In contrast, species like Culex quinque fasciatus, which thrive in permanent water, may require chemical treatments such as bacterial larvicides, insect growth regulators, or surface oils. Mosquito species that pose little risk to human or animal health, such as Weomia smithii, may not require control measures. There is no universal solution for larval control, so tracking and recording the effectiveness of each method used is an important aspect of a successful program. Most larvicides employed in mosquito control are considered biorational, meaning they are derived from natural sources, such as bacteria, and generally have less impact on non-target organisms. One of the most commonly used biorational larvicides is derived from bacteria. These bacterial larvicides often use various strains of bacteria, providing a cost-effective, environmentally friendly solution. Examples of bacterial larvicides include Bacillus thuringiensis, subspecies of Israelensis BTI, Bacillus sphaericus BS, and Saccharopolyspora spinosa spinosad. Bacillus thuringiensis, subspecies Israelensis BTI, was the first bacterial larvicide to be widely used in mosquito control. Discovered in Israel in 1976 and commercially available in 1983, BTI kills larvae through toxic crystals present in the bacteria, which disrupt the mosquito's gut once ingested. These toxic crystals are the active ingredient in commercial BTI formulations rather than live bacteria, making it a biorational control method rather than traditional biological control. For BTI to be effective, the mosquito must have an alkaline gut, which helps activate the toxins. A major advantage of BTI is its low toxicity to non-target organisms because of the pH differences in their guts. It specifically targets mosquito larvae and related flies, causing no harm to plants or other animals. However, BTI has a short duration of action, as the toxins lose effectiveness after a few days when the particles settle to the bottom of the water, out of reach of the larva. Reapplication every 7 to 10 days is necessary to maintain control. Special formulations such as BTI, briquettes, or dunks can release the toxin gradually, providing longer-lasting effects. Bacillus sphaericus BS was isolated in California in 1964 and became available for commercial use in 1991. Like BTI, BS causes damage to the mosquito larva's digestive system upon ingestion. However, BS is made from live bacterial spores, which can survive and multiply in aquatic habitats for up to 30 days. BS is particularly effective in organic waters and can continue to kill larvae for weeks, though its efficacy is reduced if water temperatures drop. Saccharopolyspora spinosa spinosad is a newer bacterial larvicide first discovered in soil from a former sugar mill in the Virgin Islands in 1985. Commercially available for mosquito control since 2007, spinosad works by attacking the mosquito's nervous system, paralyzing, and ultimately killing it. Unlike BTI and BS, spinosad is effective in a variety of aquatic environments, including both permanent and floodwater habitats. Available in tablets, granules, and liquid forms, spinosad has varying residual effects depending on the formulation. As it works differently from other larvicides, it can be a useful tool for addressing mosquitoes that have developed resistance to other treatments. Combination products. As a result of the diversity of bacterial larvicides available, vendors have started to offer larvicides as duplex mixtures. For example, BTI and BS have been mixed together to give control with quick knockdown BTI and longevity BS. In general, the effectiveness of bacterial larvicides can be reduced if 1. There's thick vegetation that prevents particles from dispersing to all of the larvae. 2. The water is organically polluted. Or 3. The water contains a large quantity of particulate matter that the larvae consume in favor of the larvicide. Under these conditions, it is necessary to apply the product at its maximum label rate to achieve appreciable results. Next, we're going to look at chemical control options. Insect growth regulators, IGR. IGRs may be referred to as juvenile hormone mimics and kill by interfering with insect growth and development. These chemicals stimulate cuticular inhibitors within the mosquito body that in turn disrupts the normal life cycle progression. The result is the exoskeleton of the larva or pupa fails to form properly, thereby preventing complete emergence in the larva-pupa molt or the pupa-adult molt. The most common IGR used for controlling mosquitoes is S-methoprene. S-methoprene can be used in a variety of aquatic habitats, including catch basins, roadside ditches, artificial containers, flooded areas, etc. One benefit of S-methoprene is that it can provide control even after the treated site has gone through a wet, dry-wet cycle. However, when sampling after treatment with S-methoprene, technicians will still encounter larvae, as mosquitoes treated with the IGR do not immediately die, unlike other larvicides. IGRs are target-specific and come in several forms: briquette, pellet, water-soluble pouches, granules, and liquid. Each formulation provides residual control, with some products lasting up to 150 days. Surface oils and films. Commercially available monomolecular surface films, RO-Surf, MSF, and Agnic MMF, non-ionic products, are utilized as larvicides and pupicides of mosquitoes. They are biodegradable and spread spontaneously over the surface of the water to form an ultra-thin film monomolecular layer about 1 molecule in thickness. Their mode of action against mosquito larvae and pupa is physical rather than chemical. They lower the water surface tension, preventing suspension of the larva and pupa at the water surface, subsequently suffocating them. They also interfere with the emergence of the adults. Monomolecular surface film products have shown to be relatively safe to non-target invertebrates and vertebrates, including humans. Let's talk about larvicide formulations. Granules. Granular particulates are much larger than those of dust and wettable powders and are formulated on porous carrier materials like clay or ground corn cobs. The carrier material may have the pesticide coated on its outer surface, or the pesticide may be absorbed into the material itself. Sometimes granules are encapsulated or coated with a slowly dissolving material. As the coating dissolves, the pesticide is slowly released, ensuring the presence of the toxin in the larval habitat for an extended period. This formulation is generally used when excessive plant growth is present in the larval habitat. Sand. Sand can be used to create on-site granular formation by combining liquid larvicide products with sand. Sand formulations were originally developed to control larvae in tree-canopied swamps and coastal salt marshes in Florida. Briquettes. Briquettes are similar to granules, but much larger, and they come in a variety of sizes and shapes. Briquettes slowly dissolve and release a sustained amount of larvicide over time. Briquettes are normally applied to shallow depressions in no-flow or low-flow water conditions, e.g. woodland pools, catch basins, etc. Pellets. Pellets, like briquettes, slowly release a larvicide and offer control for up to 30 days. Pellets can be applied by hand, truck, or airplane and can treat a wide variety of habitats, e.g. containers, woodland pools, floodplains, etc. On the current image, you're seeing some of the shapes and sizes of the granules, pellets, and briquettes. Liquid formulations. Emulsifiable concentrates. An emulsifiable concentrate formulation usually contains a liquid active ingredient, one or more petroleum-based solvents, which give EC formulations their strong odor, and an agent that allows the formulation to be mixed with water to form an emulsion. Liquid larvicides and aqueous suspension products mix easily with water. These can be injected or mixed with water to obtain the proper application rate. These products require agitation after sitting for a prolonged time. Surface oils. These are petroleum-based products that kill larvae by suffocation. Next, we'll look at methods of application. Larviciding. The term larviciding is used to describe the procedure of applying insecticides to kill immature mosquitoes, larvae, and pupa in the water. In order to help preserve the susceptibility of mosquito species to insecticides, the same class of materials should not be used both as a larvicide and as an adulticide, especially against the same species. Hand application. Larviciding by hand is usually restricted to breeding areas that are too small for aerial treatment and inaccessible to vehicles. Ground larviciding is normally performed with petroleum oils, monomolecular films, insect growth regulators, and/or other formulations using biological agents, e.g. BTI. Truck-based applications. Ground larviciding by truck was normally restricted to roadside ditches and other breeding areas. Also, larvicide equipment may be mounted on four-wheelers or other all-terrain vehicles for control in remote locations. Currently, new technologies have been implemented where larvicides have been applied to neighborhoods using specialized mist blowers. Aerial application. Determination of the need for aerial spraying involves knowledge of the target species, including life history and behavior, and delineation of the infested areas. Aerial larviciding is utilized for larger and more remote breeding areas. Liquid and solid, i.e. granular, sand, formulations are the materials of choice. Most aerial larviciding are conducted during the daytime. Let's talk about adult mosquito control. Adult mosquito control, adulticiding, focuses on killing the adult stage of the mosquito. As a result, mosquitoes are targeted while in flight or at rest rather than as immatures with an aquatic environment. Adulticiding is incredibly important when 1. The level of nuisance-biting mosquitoes is high, 2. There's an increased risk for virus transmission, and/or 3. When adult mosquitoes pose other increased risks to humans or animals. Surveillance is incredibly important to justify when and where adulticiding applications will occur. The first step in the control of adult mosquitoes is to identify the pest species. This can be accomplished using a variety of methods. It is important to continuously monitor mosquito populations to recognize when chemical control of adult populations is needed. There will be times when adult populations are low enough or weather conditions prevent the need for spray applications. Let's discuss application of pesticides. Use pesticides to supplement physical, cultural, or natural methods of control. Apply pesticides in a manner that offers minimal hazards to non-target organisms, man, and the environment. Use pesticides to treat only those specific sites where mosquitoes are present. Apply pesticides selectively to the proper life stage of the mosquito. Some adulticides may be most effective against the early stages of larval development, while others are more effective against the later stages of development. Apply pesticides in accordance with federal and state laws and regulations and in compliance with specific instruction on the label. Read the label. On this slide, we're going to look at the principal advantages of adulticiding and the principal limitations of adulticiding. Our first advantage of adulticiding is rapid and dramatic reduction of adults. Second, can potentially reduce the risk of increased arbovirus, can be used in combination with other control methods for increased population reduction. Economic benefits derived from adulticide applications often offset the cost and can quickly reduce the burden of biting mosquitoes on humans and animals. When we look at some of the principal limitations of adulticiding, results are going to often be temporary, risk of non-target effects, some pesticides may cause unsightly stains or damage auto finishes and other surfaces. Insecticide resistance may develop within mosquito populations after prolonged usage, and pesticides are expensive and costs continue to rise. Next, we're going to look at types of adulticides. Pyrethrins. Pyrethrins are naturally occurring plant secondary metabolites with insecticidal properties that are found in members of the genus Chrysanthemum. They function by binding to sodium channels on the nerves, causing paralysis and death. Pyrethrum is one product that has been used in mosquito control. While it is more often considered one of the more environmentally acceptable adulticides, it breaks down rapidly when exposed to light. Pyrethroids. Pyrethroids are synthetic compounds whose structures mimic pyrethrins. These products were modified in order to have increased stability, allowing them to persist in the environment for longer. Like pyrethrins, pyrethroids also disrupt the sodium channels on the nerves, resulting in paralysis and death. Examples of pyrethroids used in mosquito control include permethrin, resmethrin, deltamethrin, prolethrin, etofenprox, and phenanthrene, also known as simethrin. Additionally, bifenthrin, permethrin, lambda, cyalothrin, and deltamethrin are also commonly used as barrier treatments for mosquito control. Pyrethroids are extremely toxic to fish and should be applied carefully and according to the product label. Organophosphates, Nalid, malathion, and chlorpyrifos are organophosphate adulticides that are used in mosquito control programs. They are variable in toxicity and persistence, but most often break down rapidly. Organophosphates work by inhibiting an enzyme, cholinesterase, that breaks down acetylcholine, an important neurotransmitter on the surface of nerve cells. Since the enzyme gets inhibited, nerves continue firing, causing paralysis and death. This cellular process is highly conserved in animals, meaning that humans can be negatively impacted. It is recommended that employees working extensively with organophosphates be tested for acetylcholinesterase annually before and after the spray season. Piperonil butoxide (PBO). Many formulated adulticides have PBO added to increase their efficacy. PBO has little to no toxic properties, but functions as a synergist, a compound or pesticide that enhances the toxicity of another pesticide by inhibiting detoxification processes in arthropods. As a result, insecticides can be more effective even with less of an active ingredient. Let's look at dry or solid formulations. Insecticidal dust. These consist of an inert carrier, such as talc or pyrophyllite, and an insecticide active ingredient that is usually in the range of 1 to 10% of the total weight. Although dust are usually low in cost, easy to apply, non-staining, and non-toxic to vegetation, they are rarely used in mosquito control. Poisons in dust form are generally not absorbed through the skin, but may be dangerous if inhaled. Dust do not adhere well to vertical surfaces such as walls and are easily removed by winds and rain. Wettable powders, suspensions. Wettable powders, prior to being mixed with water for application, look like dust. Unlike dust, they contain wetting agent in addition to the insecticide and inert ingredient. Wettable powders are not commonly used in mosquito control. They are not suitable for ultra-low volume ULV applications and leave a residue. Some larvicides are available as wettable powders. One drawback is that they must be agitated while applied. High concentrate solutions. These are special formulations consisting of pesticides diluted with an oil to contain not less than 1.5 pounds of active ingredient, AI, per gallon. In mosquito control, they are often used in ULV application for control of adult mosquitoes. This formulation allows the pesticide to stick to objects and target organisms. EC. These formulations contain an insecticide, a petroleum carrier, and an emulsifying agent that permits the formulation to mix well with water. When diluted, emulsions need little agitation and can be used as a residual spray both outdoors and indoors. They can also be used as aerosol sprays for adult mosquito control. Caution should be used during applications as ECs can damage some plants and stain certain surfaces. Insecticides around a home or a business. Granular applications. A wide variety of applicator equipment is available, including handheld, truck-mounted, and aerial. Handheld equipment may be a simple spreader, or it may be a backpack-powered sprayer. These are generally used for small areas. Truck-mounted equipment consists of a granular hopper and a blower and is used primarily to treat roadside ditches. The treatment of large areas, e.g. marshland, rice fields, and pastures, can be accomplished by using aerial application. Backpack mister and hand foggers. These contain a chemical tank and a small gas or electric engine with a blower for atomizing of the chemical. Commonly used around homes and public spaces, they offer an economical way of treating adult mosquitoes in small areas. Both are used to control mosquitoes and for barrier treatments. The technician should follow the chemical label and user guide prior to any application. Thermal fog applicators. Through the early 1980s, large thermal fog machines were used much the same as aerosol dispensers in the home. The machines were generally mounted on trucks and produced a thick, fog-like cloud dispensed downwind. Small portable thermal fog generators still have a limited use in urban areas for treating storm drain systems during disease outbreaks. Power sprayers. There are many types and sizes of power equipment available for large-scale mosquito control operations. A power sprayer usually consists of a power source, i.e., gasoline engine, electrical, pump, chemical, storage tank, and one or more hoses for delivery of material. These units can be mounted on skids or permanently mounted to spray vehicles. The versatility of a skid-mounted sprayer allows it to be removed whenever the vehicle is needed for other purposes. Power sprayers are used to apply many different pesticide formulations. They are used for residual spraying to control resting adult mosquitoes, and they are used to apply larvicides in roadside ditches and woodland ponds. Mist sprayer duster. These are truck-mounted sprayers used for area-wide larviciding. They apply liquid BTI to neighborhoods from public roads, enabling control of container breeding species of mosquitoes on a large scale. An example of this is the Buffalo turbine spray system. ULV ground sprayer. ULV spraying is the application of small amounts of highly concentrated adulticide. The ground sprayer usually holds 5 to 20 gallons of concentrate or formulation. It is often mounted on the bed of a half-ton truck. In contrast, the thermal fogger was much larger and heavier, and its adulticide tank contained 25 to 200 gallons or more. The unit was usually mounted on a much larger vehicle, such as a 1 to 3 ton truck. Most ULV ground sprayers use a blower that delivers high-speed air to break up and transport the spray droplets to a point just outside the nozzle orifice. The prevailing winds, less than 10 miles per hour, act to move the adulticide droplets across the treatment area. No wind less than 1 mile per hour often results in poor dispersal of the adulticide, and this results in poor control of mosquito populations in the vicinity. ULV applications use less adulticide per acre than in thermal foggers. The result is less environmental contamination, saving in adulticide cost, reduction of dilutants, and reduced time for loading or transporting adulticides. Another advantage of ULV aerosols is the avoidance of dense fog such as those produced by thermal fog generators. ULV ground equipment should produce a carefully regulated and monitored flow rate and spectrum of droplet sizes. Usually the nozzle should be directed upward at an angle of 45 degrees to ensure maximum dispersal of insecticide. Vehicle speed should not exceed that designated on the insecticide label. The spray should always be shut off when the vehicle is stopped, even momentarily. In our next section, we're going to go over wood preservation. Let's talk about wood preservatives. Wood pesticides or preservatives extend the life of wood products by protecting them from damage by insects, fungi, marine borers, and weather. Preservatives are applied depending on how and where the wood products will be used, the expected conditions of exposure to wood-destroying agents, and the cost per year of service life. We need to understand what type of wood needs to be treated. Cross ties, poles, posts, and other wood products that contact the ground or are exposed to the weather must be protected with preservatives to ensure reasonable service life. Other wood products not in contact with the ground may be treated as a precautionary measure, even though they are not exposed to moisture and weather. What is wood composed of? 90% of wood is made up of minute, hollow fibers oriented lengthwise along the tree stem. These fibers, 0.5 inch long or 5 millimeters, are 100 times longer than wide. The tree transports water and nutrients vertically through these fibers, which also serve as a means of support. The remaining 10% of the wood is composed of short, hollow, brick-shaped cells oriented from the bark toward the center of the tree as ribbons or rays of unequal height and length. These rays distribute food manufactured in the leaves and transported down the inner bark to the growing tissues between the bark and the wood. Wood pressure treated with creosote. This wood has been preserved by pressure treatment with an EPA-registered pesticide containing creosote to protect it from insect attack and decay. Wood treated with creosote should be used only where sufficient protection is important. Creosote penetrates deeply into and remains in the pressure-treated wood for a long time. Exposure to creosote may present certain hazards, therefore the following precautions should be taken both when handling treated wood and in determining where to use the treated wood. Wood treated with creosote should not be used where it will be in frequent or prolonged contact with bare skin, for example chairs and other outdoor furniture, unless an effective sealer has been applied. That brings us to a good question. Where can creosote be used? Creosote-treated wood should not be used in residential interiors. Creosote-treated wood in interiors of industrial buildings should be used only for components that are in ground contact and are subject to decay or insect infestation, and for wood block flooring. For such uses, 2 coats of appropriate sealer must be applied. Sealers may be applied at the installation site. Wood treated with creosote should not be used in the interiors of farm buildings, where wood may be in direct contact with domestic animals or livestock that may crib, or bite, or lick the wood. Creosote-treated wood may be used for building components that are in ground contact and are subject to decay or insect infestation. However, 2 coats of an effective sealer must be applied. Let's talk about the disposal of creosote-treated wood. Dispose of treated wood by ordinary trash collection or burial. Treated wood should not be burned in open fires, wood stoves, fireplaces, or residential boilers because toxic chemicals may be produced as part of the smoke and ashes. Treated wood from commercial or industrial use, for example construction sites, may be burned only in commercial or industrial incinerators or boilers in accordance with state and federal regulations. Inhalation issues with creosote. Avoid frequent or prolonged inhalation of sawdust from treated wood. When sawing and machining treated wood, wear a dust mask. Whenever possible, these operations should be performed outdoors to avoid indoor accumulations of airborne sawdust from treated wood. When power sawing or machining, wear goggles to protect eyes. Skin contact issues with creosote. Avoid frequent or prolonged skin contact with creosote-treated wood. When you handle the treated wood, wear long-sleeve shirts and long pants. Use gloves that are impervious to the preservative, for example, gloves that are vinyl-coated. When you are power sawing or machining, wear goggles to protect your eyes. After working with the wood, and before eating, drinking, or using tobacco products, wash exposed body areas thoroughly. If preservatives or sawdust accumulate on clothes, launder before reuse.
Another label we're going to look at as part of our training is called PESTICIDE. This is a penetrating fungicide, termiticide, and preservative. It's actually considered a clear wood preservative. Use PESTICIDE to control wood decay and insect damage on all interior and exterior wood. This meets AWPA standard M4 for end cuts. The active ingredient is going to be disodium octaborate tetrahydrate, with active ingredients of 8.5%. Other ingredients total 91.5%. This is an EPA registered product with the registration number 64405-5. Our next section of the label is going to be on first aid. If swallow, call a poison control center or doctor immediately for treatment advice. Have person sip a glass of water if able to swallow. Do not induce vomiting unless told to do so by poison control center or doctor. Do not give anything by mouth to an unconscious person. Continuing our discussion on first aid section of the label, if the products on your skin or clothing, take off contaminated clothing. Rinse skin immediately with plenty of water for 15 to 20 minutes. Call a poison control center or doctor for treatment advice. Further in the first aid section of the label, if the product is in your eyes, hold eye open and rinse slowly and gently with water for 15 to 20 minutes. Remove contact lenses if present. After the first 5 minutes, then continue rinse in the eye. Call a poison control center or doctor for treatment advice. Have the product container or label with you when calling a poison control center or doctor or going for treatment. You may also contact 800-424-9300 for emergency medical treatment. Our next section of the label is going to be on precautionary statements. Caution, harmful if swallowed or absorbed through the skin. Causes eye irritation. Avoid contact with skin, eyes, or clothing. Wash thoroughly with soap and water after handling. These are very important statements that everybody needs to read on these labels. Obviously, you know if something's swallowed or absorbed through the skin, it's probably going to be harmful. Just keep in mind, this product is going to cause eye irritation as well, so you really want to avoid contact with the skin, eyes, or clothing, and just make sure you wash thoroughly with soap and water after handling. You definitely don't want these pesticides on your hands, and then you eat or something like that, and then you're getting it obviously in your system and things like that. You definitely don't want to do. We're now going to talk about the personal protective equipment on the label, PPE. Applicators and other handlers must wear long-sleeve shirts and long pants, chemical-resistant or water-repellent gloves, shoes, plus socks. This is really important, guys. I know a lot of people I've seen through the years will just go out, do pesticide applications in short-sleeve shirts. Don't worry about if they're wearing shorts. These things are a major problem, so really follow these labels and protect your skin from the product. You may think, well, I'm not going to get it on me, but I can tell you, if you're treating in shorts or without a long sleeve shirt on, basically the wind or anything else is going to blow this product and it's going to get on your skin. And obviously it makes sense to wear gloves because your hands are an easy area for products to get on. And then of course shoes plus socks. I don't know why that's on there, but I think common sense tells us we're definitely going to wear those when handling a pesticide. Our next thing on the label is going to be environmental hazards. Wood treatment facilities must take steps to prevent runoff of the product into waterways. This is a really big deal. I can tell anybody that's an outdoorsman, or even if you just like seeing the natural environment, or even our drinking water or anything else, these types of products can be a problem. So we really need to think about where these products go when it comes to runoff. So treated material stored outdoors within 100 feet of a pond, lake, stream, or river must be covered, surrounded by a containment berm, or otherwise protected to prevent surface water runoff. The containment berm must be of sufficient height to prevent runoff during heavy rainfall events. Do not apply directly to water, to areas where surface water is present, or to intertidal areas below the mean high water mark. Do not contaminate water when disposing of equipment, wash waters, or rinsate. So some of this stuff is pretty straightforward, but just keep in mind if you're in an area where there might be water that comes up, flooding, or intertidal areas, something you really need to think about was storing this. I know most of you probably would, but I've seen pesticide storage sites that were in water areas that kind of shocked me. So keep in mind it's very important that these types of products do not end up in an area where water can take them out somewhere. In our next section of the label, directions for use, it is a violation of federal law to use this product in a manner inconsistent with its labeling. Use of this product to prevent bed bugs is prohibited. Application to carpets is prohibited. So these are some pretty important things. Obviously, any pesticide, if you've taken any of our courses, you know we say this over and over again. The label is the law, and it is a violation of federal law to use any product outside of its label. And I'm going to reiterate something I always say. You don't want to use the product outside of its label. A, it could cause harm to you or the environment around you, people, pets, waterways, whatever the case may be. But also, the product itself doesn't work any better. It's not like if you use the product outside of the label or add more that you're going to get a better result. You also have to think about things like the chemical cost itself. So if I'm using the product and I'm putting double the rate or whatever the case may be, this is costing me and or my company a lot of money. So you really need to think about these sections of the label. Follow the label, it's been tested by the EPA, and you know the formulation is exactly what it should be. Now I'm also looking at the fact that this can't be used for bed bugs. I'm not sure why that's on there, but I always hear a lot of different people telling me they're using a lot of products for bed bugs. So obviously this is not a bed bug product. And applications to carpets is prohibited. Once again, good to know, this is not even a product you can use in cracks and crevices on carpets or anything like that. Notice, read and understand the entire label before using. Once again, this is a huge thing in the pest management industry. You really do need to read and understand each label before you use it. I know that's not a common thing per se because a lot of times you're in a hurry, you've got a lot of homes or businesses you need to take care of, but reading and understanding the label is very important. And then think of it like this. Once you're using a product, you've read and you understand the label, at that point you're going to know most of it by heart. You're not going to have to keep doing this over and over again, but especially the first few times you use a product, really read that label. And of course, use only according to label directions, which we already just discussed. Before buying or using this product, read warranty disclaimer and limitation of remedy statements found elsewhere on the label. If the terms are unacceptable, return unopened package to the seller for a full refund of the purchase price. Otherwise, use by the buyer or any other user constitutes acceptance of the terms under warranty disclaimer and limitation of remedies. Safe handling procedures: clean spills and overspray with a damp cloth or absorb with appropriate materials. When applying this product in confined spaces, it is recommended that ventilation or an exhaust system be provided. Once again, there's some really good information in here. Basically, they're saying you do need to clean up overspray with a damp cloth or absorb it with appropriate materials. Also see huge importance when they say when applying this product in confined spaces, it is recommended that ventilation or an exhaust system be provided. That's a big thing to me. Let's say you're in a crawl space or an attic or something like that and you're going to use this product. You definitely want to make sure there's some ventilation, or probably even think about a respirator. Obviously follow what the label says. We just have to keep in mind that you don't want to be in a confined space just breathing in a product like this. If the label says that, it's definitely important for you. You do not want to be breathing this in, and you definitely don't want to be in an unventilated area. In our next section of the label, product information, PESTICIDE is a ready-to-use product that is applied to wood. PESTICIDE will both control and help prevent infestations of wood-destroying organisms such as subterranean, which includes formosan and drywood termites, wood-boring beetles, carpenter ants, and decay fungi. It may take several days for the infestation to be controlled. However, any termites that start to ingest treated wood or that are directly sprayed will die. As a termiticide, this product is not intended as a substitute for whole structure treatment. Surface preparation is going to involve applying only to bare dry wood. This is another important thing. Obviously, if wood has a finish, it's not going to work well with a product like this. You may ask why. Well, wood is very porous. So it's important to understand that with wood being porous, it absorbs things. So if a piece of wood has paint or a lacquer or a varnish finish, this product is not going to absorb into the wood, which is exactly how it's designed to do. So make sure you're using this only on bare, dry wood. Some areas like maybe an attic or a crawl space would have this type of wood. Obviously, a lot of you may have done treatments like that, but just keep in mind if the wood's wet or it has a finish on it, you're definitely not going to want to apply this product. And that may even make sense outdoors because you can use it outdoors. If wood has been rained on or something like that, I definitely wouldn't put this product on it until it dries out. Maintenance of treated surfaces. PESTICIDE may be applied as needed to exterior, unfinished wood surfaces. Interior surface treatments of existing wood are considered permanent and do not require reapplication or coating except in situations involving repeated moisture contact or high humidity, such as shower stalls, bathhouses, and saunas. So it's very important, obviously, if this is done on an exterior, you may need to look in the future to see if it needs to be treated again or at what point it needs to be treated. Obviously, interior surfaces, once this product's on there, it's not going anywhere unless it is in a wet area like a bathroom or an area of high humidity. So that makes sense because those types of areas are going to break down any pesticide type of product, especially shower stalls, something like that, where the moisture is just permeating into the wood. The cleanup section of the label on this product is pretty simple. You're going to use soap and water to clean up tools. That brings us to the application instructions portion of our label. Apply PESTICIDE only to bare wood or to wood surfaces where an intact water repellent barrier is not present. Either brush on or apply with a low pressure sprayer. Small wooden items, field cuts, or end cuts may also be treated by dipping. Return unused product to original container and seal tightly. Always clean and or flush equipment and lines with water after each use. When applying more than one coat, wait at least 20 minutes between applications. When spraying attics or overhead interior areas, cover all surfaces below the treated area with plastic sheathing. Do not apply in food serving areas while food is exposed. When applying PESTICIDE to exterior surfaces, cover nearby plants and grasses with plastic. A couple quick things on this section of the label. I like the idea of either brush on or apply with a low pressure sprayer. That's a good point made because obviously you can use a brush with a product like this in some areas. I can tell you I've done treatments in large churches. We've had even wooden organs and things where we've actually brushed the product on because inside the equipment itself there were areas that didn't have any treatment on the surface, didn't have any paint or varnish or lacquer or anything like that, so we were able to brush it on. Obviously, low pressure sprayers are great because you don't want to spray this with high pressure like a termite rig or something like that, because obviously you're going to have problems with basically it just splashing everywhere and coming back off. You're always going to want to clean and or flush equipment and lines with water after use. I can tell you this for a fact, this type of product will harden and crystallize in your sprayers. You'll have major problems if you don't. Clean this out after use. I run a whole 3 gallons through my sprayers after I use it. And obviously when applying more than one coat, wait at least 20 minutes between applications. That's a pretty big deal because you have to remember that if you don't wait that 20 minutes and allow the first coat to dry, you're really just knocking it off when you treat again. Obviously, you can imagine not applying this in food serving areas when food is exposed. That kind of goes without saying. But also, when applying PESTICIDE to exterior surfaces, cover nearby plants and grasses with plastic. I can tell you from experience, if you get overspray on grasses or plants, it will kill them. As a matter of fact, I've seen technicians in our industry use this to kill all the grass in their yard when they're going to resod their yard. Obviously, that's not on the label, but I can tell you the person that did this, it definitely killed all their grass, their plants, and everything, and they were really surprised. So that just let me know up front, this product's going to kill anything that's growing, so make sure any ornamentals or grasses that you need to be protected, that they are covered before you use this product. Again, looking further down the label, storage and disposal. Do not contaminate water, food, or feed by storage and disposal. Pesticide storage. Store in a dry place. Do not store where children or animals may gain access. Protect from freezing. Again, there's some good things here. We already know we don't want to contaminate water, food, or feed. Obviously, that kind of goes without saying. But you need to store this in a dry place like we talked about before. But definitely keep out of reach of children. That's on the label here at the top in big letters. But just keep in mind that's common sense. Obviously, we don't want children or animals to gain access. And protect this product from freezing. There again is a great thing for you to know. If you're in a climate where it can go below 32 degrees or even below 40, you need to think about that. A product like this can freeze. Obviously, you can't use it if it's frozen anyways, but even when it thaws out, you still can't use the product again. So if it freezes, basically the product is no good and needs to be disposed of correctly. Pesticide disposal. Waste resulting from the use of this product may be disposed of on site or at approved waste disposal facility. Container handling. Non-refillable container. Do not reuse or refill this container. Offer for recycling if available, or reconditioning if appropriate. Otherwise, call your local solid waste agency for disposal instructions. Promptly triple rinse or equivalent container after emptying. Triple rinse as follows. Empty the remaining contents into application equipment or a mixed tank and drain for 10 seconds after the flow begins to drip. Fill the container 1/4 full with water and recap. Shake for 10 seconds. Pour rinseate into application equipment or a mixed tank or store rinseate for later use or disposal. Drain for 10 seconds after the flow begins to drip. Repeat this procedure. Alright guys, so pesticide disposal is a huge pet peeve for me. Once again, I know how busy technicians are and I know it's something that you really don't want to have to spend a lot of time on. Just keep in mind you're the frontline protectors of our environment when handling these products. Please make sure you dispose of this on-site or an approved waste disposal facility. On the container handling, this is a non-refillable container. Obviously, you're not going to reuse or refill the container. There'd be no reason to anyways. Now, you do want to remember you're going to use the triple rinse method on this. So obviously you need to empty the remaining contents into application equipment or mix a tank and drain for 10 seconds after the flow begins to drip. So keep in mind you're going to mix this into the container. You're going to fill the container 1/4 full with water and recap. Shake for 10 seconds. Then pour that rinse-aid into application equipments or mix a tank or store rinse-aid for later use or disposal. Now I'm going to tell you this. Basically, most people don't want to store this because if you're not going to reuse it within a reasonable amount of time, it's not going to be good. Keep in mind the best thing to do when you're at a site is don't mix up more than you need. Make sure not to mix up 5 gallons of product if you're only going to use 3. You can calculate before you even mix what you need, and that's really going to solve the issue of you having all this extra product. And then obviously, if you do have any rinse-aid, or you probably will in most cases, but make sure you store it, but also try to use it within a reasonable amount of time because these products are definitely not going to be good in water indefinitely. Warranty disclaimer. To the extent not prohibited by applicable law, manufacturer warrants that this product conforms to chemical description on the label and is reasonably fit for the purposes stated on the label when used in strict accordance with the directions, subject to the inherent risks set forth below. To the extent not prohibited by applicable law, manufacturer makes no other express or implied warranty of merchantability or fitness for a particular purpose or any other express or implied warranty. Inherent risk of use. The directions for use and use of this product are believed to be adequate and must carefully be followed. It is impossible to eliminate all risk associated with use of the product. Lack of performance and other intended consequences may result because of such factors as a use of product contrary to label instructions, abnormal conditions, the presence of other materials, climatic conditions, or the manner of use application, all of which are beyond the control of the manufacturer. To the extent not prohibited by applicable law, the buyer-user assumes all such risk. So keep in mind, if you're using this product correctly according to the label, a lot of these risks can be negated to a reasonable point. There's always going to be different environmental conditions. We talked about it. But if you're wearing the PPE and you're making sure that this stuff's not blowing back in your face, let's say, then you're really going to be a lot more protected. So just keep in mind, follow the label instructions for maximum safety and effectiveness. In this section of the label, we're going to talk a little bit about limitation of remedies to the extent not prohibited by applicable law, the exclusive remedy for losses or damages resulting from this product, including claims based on contract, negligence, strict liability, or other legal theories, should be limited to, at manufacturer's election, one of the following: refund of purchase price paid by the buyer or user for the product bought, or 2, replacement of the amount of product used. So keep in mind, this is just some legalese, but it's letting you know that losses or damages are limited to just refund or replacement of the product. Once again, it's up to you to use it correctly, make sure that it works right because you're doing the application correctly, and to protect yourself from the product itself by using the label directions and the PPE and things like that. Let's talk about restricted entry intervals.
Basically, an REI is just that stay-out time after a pesticide application.
Right, to keep workers safe.
Yeah, keeps them safe from exposure, and you find that time period right on the pesticide label itself, usually under agricultural use requirements in the directions for use section.
Or sometimes right next to the crop listed.
Sometimes, yeah, or the specific application method. It varies a bit.
Okay.
As you've just been hearing, the REI is listed on the pesticide labeling under the heading Agricultural Use Requirements in the Directions for Use section of the pesticide labeling, or next to the crop or application method to which it applies.
So our mission today really is to untangle the rules for when workers can go back in before that official REI is up. Because the basic rule is stay out, but there are exceptions.
There are, and that's where it gets tricky. So we want to make that clear. It's super important for farm safety.
Absolutely.
Early entry with no contact. Early entry with contact for short-term, emergency, or specially accepted task, which must comply with additional restrictions. Entry into treated areas during an REI is allowed to perform handling tasks as long as the persons entering such areas are trained and equipped as pesticide handlers and receive all other applicable WPS handler protections.
So lay it out for us. What's the employer's main job here?
Okay, fundamentally, the employer must keep workers out during the REI. That's the baseline.
The exceptions.
Right. But there are basically two main ways workers can enter early. First, if they will have absolutely zero contact with any pesticide residue. None.
Okay, zero contact. What's the second?
The second is for very specific situations where some contact might happen, but the work itself is really limited and controlled.
Gotcha.
And we should also just mention, trained and equipped pesticide handlers operate under different rules when they're actually doing handler tasks. Agricultural workers.
Okay, let's dig into that first one then. Early entry with no contact. What's the absolute bottom line?
The core idea is, like I said, workers can go in only if they won't touch any pesticide residue at all.
And where might that residue be hiding? It's not just on the plants, right?
No, definitely not. It could be on the crops, sure, but also weeds. It could be in or on the soil or potting mix, whatever they're using.
Okay.
Also think about water, irrigation water, even puddles on the ground. And the air itself, especially after fumigation or, fogs or mists before everything settles.
Okay. So it's pretty comprehensive.
Once again, I want to reiterate, where could these residues be hiding? They could be on plants, including both agricultural plants and weeds, on or in soil or planting medium, in water, such as irrigation water, or water standing in drainage ditches or puddles, in air. If pesticide remains suspended after application, such as after fumigation or after a smoke, mist, fog, or aerosol application.
And I noticed a key point in the guidance, just wearing PPE, like gloves or boots, doesn't count as no contact here, does it?
No, absolutely not. That's crucial. Using PPE doesn't magically make it no contact for this specific exception. The whole point here is avoiding the contact in the first place.
Right.
Avoiding contact by using personal protective equipment does not qualify as no contact early entry. No contact early entry workers do not have to be provided the special protections required for other early entry workers. The following are examples of situations where a worker would not be expected to contact pesticide residues in a treated area after sprays, dust, and vapors have settled out of the air.
So, what are some real-world examples where this no contact entry would actually be okay? After sprays or dusts have settled, obviously.
Well, think about someone walking down aisles or pathways, like established farm roads or footpaths within the treated area, as long as the plants aren't going to brush against them and nothing's dripping on them.
And they just wear normal work boots.
Yep, standard footwear is fine for that. No special PPE needed for this exception.
Okay, what else?
Being inside a vehicle can work. But again, the key is no plants brushing against the vehicle, nothing tripping into it.
Like a tractor with a closed cab.
Exactly. An enclosed cab is a perfect example.
So again, in situations where the worker is wearing footwear and is walking in aisles or on roads, footpaths, or other pathways through the treated area where the plants or other treated surfaces cannot brush against the worker and cannot drop or drip pesticides onto the worker, we wouldn't expect them to come into contact with the pesticides. Again, as we just talked about, if the worker is in a vehicle in a treated area where the plants cannot brush against the worker and cannot drop or drip pesticides onto the worker. So obviously, if the worker's in a vehicle, there's a lot more protection from these types of issues occurring.
What if the pesticide was put directly into the soil? Like injected?
Good question. If it was incorporated or injected, then you can do some tasks, but only if you're not disturbing that treated soil below the surface.
So, no digging.
Right. No digging, no turning the soil over, and again, driving through in a totally enclosed cab where no residue gets in, that works too.
Got it. So, no contact means absolutely zero physical interaction. And the big advantage is these workers don't need all that extra protective gear required for other early entry situations.
So again, this would be another scenario where workers wouldn't be expected to contact pesticides after a pesticide application that is incorporated or injected into the soil. The worker is doing tasks that do not involve touching or disrupting the soil subsurface. So at that point, after that pesticide has been incorporated or injected into that soil, there's going to be a lot lower risk that that person or anybody entering that area would contact the pesticide. That doesn't mean you don't need to wear PPE. That's just saying that there's no reason why a worker would contact these pesticides when they're doing tasks that don't involve touching or disrupting that soil subsurface. And of course, when the worker is driving through the treated area in an enclosed cab on a truck, tractor, or other vehicle that prevents occupants from contacting pesticide residues or pesticide-treated surfaces. Once again, you're inside that cab. The risk of you touching these pesticides should be pretty low. I'm going to reiterate, that does not mean you don't wear the proper PPE. That's just saying that your chances of coming into contact with a pesticide are much, much less when you're in one of these enclosed cabs.
That's a really important distinction, because if any contact is expected, even a little bit, well, then a whole different set of rules applies, much stricter.
Which brings us to that second category, early entry with contact.
Exactly. Early entry where contact might happen.
So when is it okay for workers to touch treated surfaces during an REI? It sounds like it's pretty rare.
It is. It's only allowed in very specific, limited situations. The guidelines basically break it down into three main types.
Okay, what are they?
First, short-term tasks. These have to be less than 1 hour total, and they cannot involve anything defined as hand labor.
Hand labor. Okay, we'll need to define that. What's the second thing?
Second is emergency tasks. Stuff that has to be done because there's been an officially declared agricultural emergency.
Ah, okay, like a natural disaster.
Sort of, yeah. We'll get into specifics. And the third category is specific tasks that the EPA itself has approved through a special exception process.
So it's really important for you to know there are situations where early entry with potential contact can be okay. What are the work situations where early entry is allowed? Early entry involving contact with pesticide-treated surfaces is permitted in only the following work situations. 1. Short-term tasks that last less than 1 hour and do not involve hand labor. 2. Emergency tasks that take place because of an agricultural emergency. And 3. Specific tasks approved by the EPA through a formal exception process. Let's think about some of those immediate tasks. Manual labor encompasses any farming activity conducted by hand or using handheld tools, which may result in significant contact with surfaces, such as plants, plant components, or soil that could harbor pesticide residues.
Okay, 3 categories. Let's circle back to hand labor. You said short-term tasks can't involve it. What exactly is hand labor according to these rules? Sounds critical.
It really is. Hand labor is basically any farm work done by hand, or maybe with handheld tools, where you're likely to have significant contact with those treated surfaces, the plants, the soil, whatever.
Can you give some examples?
Oh yeah, the list is long. Things like packing produce out in the field, harvesting fruits or vegetables by hand, detasseling corn, thinning out crops, weeding by hand.
Wow, okay. Keep going.
Topping plants, planting by hand, girdling trees, cane work, removing suckers, pruning, disbudding flowers, roguing that's pulling out diseased or unwanted plants, all that stuff.
That covers a huge amount of common farm work.
As you can imagine, to follow the label, we need to understand what these hand labor tasks are. They can include packing produce into containers in the field, harvesting, detasseling, thinning, weeding, topping, planting, girdling, caning, sucker removal, pruning, disbudding, and roguing. This is a pretty reasonable and comprehensive list of what will be included in hand labor. So again, if you're doing any of these types of things, this is going to be considered hand labor for label purposes.
But what's explicitly not hand labor, I saw a note about irrigation equipment.
Right, good catch. Operating, moving, or fixing irrigation or watering equipment, that is specifically not considered hand labor.
Okay, that's a key difference.
It is. And actually, those irrigation tasks can sometimes fall under one of those EPA-approved exceptions we mentioned.
Ah, interesting. Okay.
And we want to note here, the definition of hand labor does not include operating, moving, or repairing irrigation or watering equipment. These tasks can be performed during the REI, but only under approved situations with proper, early entry, personal protective equipment, PPE.
So before we get to the EPA stuff, tell me more about the agricultural emergency tasks. What counts as an emergency here? It can't just be like, my tractor broke down.
No, definitely not just a breakdown. For this exception, a state, tribal, or even a federal agency has to officially declare an agricultural emergency exists.
An official declaration.
Yes, based on conditions that exist or have happened or are even forecast that pose a real threat to agriculture in the area. Think big things: major flooding, hail damage, high winds, hurricane, tornado, a bad freeze, or frost.
Got it. So major widespread events.
And once again, these emergency tasks are going to be something a state or tribal or federal agency must declare that circumstances exist, have occurred, or are forecast that might cause an agricultural emergency where your establishment is located. Examples of such circumstances include flooding, hail, high winds, hurricane, tornado, freeze, or frost. You need to stay on top of this, and you need to understand how to keep up with when a state, tribal, or federal agency declares that these circumstances exist. Then you'll have a better understanding of how these emergency tasks affect the REI at that time. So when we look at these specific tasks with regulatory exemption, EPA has approved 2 specific tasks for early entry through EPA's formal regulatory exemption process. 1, limited contact tasks that could not have been foreseen, cannot be delayed, and do not involve hand labor. 2, irrigation tasks that cannot be delayed, involve limited contact with treated surfaces, and that will take more than 1 hour in the REI area to perform.
What about those EPA-approved specific tasks? You said there were 2 types.
Yeah, 2 main types under that umbrella. The first is called limited contact tasks.
Limited contact, okay.
These are tasks that couldn't have been predicted, they really can't wait, and here's that key phrase again: they do not involve hand labor.
No hand labor. Got it.
Now let's think about limited contact tasks. These limited contact tasks are tasks where early entry workers only contact with treated surfaces, including soil, water, surfaces of plants, crops, and any equipment, is minimal and is limited to their feet, lower legs, hands, and forearms. Hand labor tasks are not limited contact tasks. Examples of limited contact tasks are operating or repairing weather monitoring and frost protection equipment, repairing greenhouse heating, air conditioning, and ventilation equipment, repairing non-application and non-irrigation field equipment, maintaining and moving beehives.
And what does limited contact mean?
It means contact is minimal, and it's restricted just to the worker's feet, their lower legs, hands, and forearms. That's it.
So not getting residue all over their body.
Exactly. And just to be super clear, none of those hand labor tasks we listed earlier, harvesting, weeding, pruning, none of those count as limited contact tasks.
Okay. What are some examples then of these allowed limited contact tasks?
Think about things like fixing essential weather monitoring gear, or maybe frost protection equipment right when a sudden freeze is coming.
Okay, time-sensitive stuff.
Right, or repairing the HVAC system in a greenhouse, if it breaks unexpectedly. Fixing other field equipment too, as long as it's not application or irrigation gear. Oh, and moving or maintaining beehives falls in here too.
Interesting. Beehives. Okay, so that's limited contact.
Irrigation tasks are tasks related to operating, moving, or repairing irrigation or watering equipment, and where early entry workers only contact with treated surfaces, including soil, water, surfaces of plants, crops, and irrigation equipment, is minimal and is limited to their feet, lower legs, hands, and forearms.
What was the second type of EPA-approved task?
That one is specifically irrigation tasks.
Back to the irrigation equipment.
Exactly. This covers the necessary work of operating, moving, or repairing irrigation or watering systems. Like the limited contact tasks, these jobs can't be delayed, and they only involve that same minimal contact: feet, lower legs, hands, forearms.
So what makes them different from the limited contact category then?
The key difference is time. These specific irrigation tasks are ones that are expected to take more than 1 hour inside that REI area to get done.
Okay. Because the short-term tasks we mentioned first had that 1 hour cap.
Precisely. So this carves out an exception for those necessary longer irrigation jobs.
Makes sense.
Under what conditions is early entry allowed for these work situations? There are specific conditions that must be met for early entry for short-term task, limited contact task, irrigation task, and agricultural emergency task.
Okay, so for all these situations where contact might happen short-term, limited contact, irrigation, and emergencies, there are specific conditions that have to be met, right?
Let's take a look at when early entry can be allowed based on conditions and task. If we look at our first condition, wait at least 4 hours after pesticide application is completed, early entry may be allowed for short-term task, limited contact task, irrigation task, and agricultural emergency task. Now, when our condition involves waiting until inhalation exposure level on the pesticide label has been reached or any WPS ventilation criteria have been met, we can early enter with short-term task, limited contact task, irrigation task, and agricultural emergency task. When our condition is the maximum amount of time allowed per 24 hours has been spent in the area, we can early enter with a short-term task limited to 1 hour, a limited contact task limited to 8 hours, irrigation task limited to 8 hours, and no limit on agricultural emergencies. In our next condition where early entry can be allowed for pesticides whose labeling requires double notification, verbal notification, and posting signs. If we look at short-term task, yes, allowed for all WPS pesticides. If we look at limited contact task, no, there is no early entry allowed. If we look at irrigation task, no, there is no early entry allowed. And for agricultural emergencies, yes, early entry can be allowed for all WPS pesticides. Again, on this chart, we're looking at conditions where early entry may be allowed. In our first condition, our hand labor task permitted. For short-term tasks, the answer would be no. For limited contact task, the answer would be no. For irrigation tasks, the answer would be no. For agricultural emergency task, yes, but must be related to the ag emergency. In our next condition, where early entry may be allowed, employer provides special protections for early entry workers regarding training, instructions, decontamination supplies, and personal protective equipment PPE. For short-term tasks, the answer is yes. For limited contact task, the answer is yes. For irrigation task, the answer is yes. And for agricultural emergency tasks, the answer is yes, early entry is allowed. In the next condition where early entry may be allowed, need for entry could not have been anticipated. So early entry for short-term task in this scenario doesn't matter. For limited contact task, early entry is allowed only if need could not have been foreseen. Also with irrigation task, early entry is only allowed if need could not have been foreseen. And early entry may be allowed under this condition for agricultural emergency task only if circumstances could not have been anticipated when pesticide was applied. And our final condition where early entry might be allowed, entry is not an economic necessity. If we're looking at early entry being allowed on these, with short-term task, it doesn't matter. With limited contact task, only if delay would cause significant economic loss. With irrigation task, only if delay would cause significant economic loss. And with agricultural emergency task, early entry is only practiced to prevent or reduce a substantial economic loss. And that brings us to our next important point. What are the special protections for early entry workers? Worker employers must provide the following additional protections to early entry workers who contact anything that has been treated with a pesticide. Complete pesticide safety training, instructions, and information, decontamination supplies, personal protective equipment, PPE.
So let's get into those special protections you mentioned. What exactly does an employer have to provide for these early entry workers who might have contact?
Okay, several critical things. First, they need full pesticide safety training, specific instructions for the task, and all the relevant safety info.
And we need to look at training and instruction. Employers must make sure each early entry worker is trained as a WPS worker before entering a pesticide-treated area during an REI. The 5-day grace period for training that applies to other workers does not apply to early entry workers. Employers must instruct early entry workers in a manner they can understand. How to put on, use, and take off early entry PPE correctly, about the importance of washing thoroughly after removing PPE, how to prevent, recognize, and give correct first aid for heat illness, too much heat stress.
And this is super important, that normal 5-day grace period for training workers. It does not apply here.
So they need the training before they go in?
Absolutely. Before setting foot in that area for early entry work. No exceptions.
Makes total sense. What kind of specific instructions do they need?
The employer has to tell them, in a way they understand, exactly how to put on, use, and take off the required PPE correctly.
Okay.
They also have to stress how important it is to wash thoroughly after taking the PPE off. And critically, they need info on preventing heat illness, how to spot it, what the symptoms are, and basic first aid for it.
Yeah, heat illness is a big risk, especially wearing PPE. What about info from the pesticide label itself?
Also required. The employer has to communicate the key safety stuff from the label. Human hazard warnings, first aid steps, signs and symptoms of poisoning for that specific chemical, exactly what PPE is needed for early entry, and any other safety rules on that label.
So really thorough communication is key. What about the decontamination supplies? What needs to be available?
Right, decon supplies. Employers have to provide enough clean water for routine washing and for emergency eye flushing. Plus, soap and single-use towels. Enough for everyone.
I just want to point out that as an employer, providing these decontamination supplies is not optional. This is something you have to do. You have to provide the water, soap, and single-use towels as the label requires. If you don't do this, you're not just in violation of the law, you're putting people at risk. If you don't do this, you're risking your reputation, but also you're going to get an overall negative view and perception of your company out there in the field.
Good question. They can't be in the area being treated, obviously, and ideally not in an area still under REI, unless, that's the only way to make them accessible.
Accessible? How close is accessible?
The rule is reasonably accessible, which they define as within a quarter mile of where the early entry workers are.
Quarter mile, okay.
Now, when it comes to these decontamination supplies, this is really common sense, as we just heard. Obviously, they don't need to be in an area that's going to be treated with pesticides. Then they're going to be contaminated themselves, and we defeated our purpose. As you can imagine, we're not going to want them to be located in an area under an REI, because then, once again, we'd be defeating our purpose. We're sending somebody back into an area under an REI to go get decontamination supplies, and they can be exposed during that time. The only exception to this is when that area is necessary for the supplies to be reasonably accessible to the early entry worker. So again, if you need to put them in there to be reasonably accessible because they don't need to be too far away, as we're going to mention in a moment, then it's okay. But that's the only time it's okay to have these supplies in an REI area. And again, our final common sense rule here is this area needs to be reasonably accessible and not more than a quarter mile away from early entry workers. So if it's more than a quarter mile away, of course, we're going to be in violation. But once again, a lot of the things we're learning here are common sense. You don't want these to be more than a quarter of a mile away because they're very important when they're needed. You don't need somebody having to go a long distance just to get these decontamination supplies. A worker-employer must provide each early entry worker with at least 1 pint of emergency eye flush water when the pesticide labeling requires protective eyewear. The emergency eye flush water must be immediately accessible. At the site where early entry workers take off their PPE, the worker-employer must provide soap, clean towels, and enough water to allow early entry workers to wash thoroughly after removing their PPE.
What about specifically for eye washing?
If the pesticide label requires protective eyewear, then the employer has to provide at least a pint of emergency eye wash water for each worker. And it has to be immediately accessible right where they are.
Immediately accessible. Got it.
And one more thing on washing, where they take off their PPE, there needs to be soap, clean towels, and enough water right there for them to wash thoroughly.
Okay, comprehensive decon setup. And the last piece of the protection puzzle is the PPE itself. Right?
Exactly. The employer must provide the specific early entry PPE that's listed on the pesticide label, period.
They just provide it.
Provide it and make sure the workers actually wear it and wear it correctly while doing the task. Just handing it out isn't enough. They have to ensure proper use.
Wow. Okay. This has been incredibly detailed. We've really unpacked REIs and especially these complex exceptions.
Yeah, there's definitely a lot to keep track of.
So for everyone listening, trying to get this right, I guess the main takeaway is that dealing with these REI exceptions needs real care, real attention to detail.
Absolutely. You have to look closely at the type of entry, exactly what task needs doing, and then follow all the mandatory safety steps if there's any chance of contact.
And always, always go back to that pesticide label. That's your primary guide for the REI length and any specific early entry PPE.
Couldn't agree more. Understanding those specifics is vital, not just for staying compliant, but really for protecting the health and safety of the people doing the work.
So when we look at these specific tasks with regulatory exemption, EPA has approved 2 specific tasks for early entry through EPA's formal regulatory exemption process. 1. Limited contact tasks that could not have been foreseen, cannot be delayed, and do not involve hand labor. 2. Irrigation tasks that cannot be delayed, involve limited contact with treated surfaces, and that will take more than 1 hour in the REI area to perform.
What about those EPA-approved specific tasks? You said there were 2 types.
Yeah, 2 main types under that umbrella. The first is called limited contact tasks.
Limited contact, okay.
These are tasks that couldn't have been predicted, they really can't wait, and here's that key phrase again, they do not involve hand labor.
No hand labor, got it.
Now let's think about limited contact tasks. These limited contact tasks are tasks where early entry workers only contact with treated surfaces, including soil, water, surfaces of plants, crops, and any equipment, is minimal and is limited to their feet, lower legs, hands, and forearms. Hand labor tasks are not limited contact tasks. Examples of limited contact tasks are operating or repairing weather monitoring and frost protection equipment, repairing greenhouse heating, air conditioning, and ventilation equipment, repairing non-application and non-irrigation field equipment, maintaining and moving beehives.
And what does limited contact mean?
It means contact is minimal, and it's restricted just to the worker's feet, their lower legs, hands, and forearms. That's it.
So not getting residue all over their body.
Exactly. And just to be super clear, none of those hand labor tasks we listed earlier, harvesting, weeding, pruning, none of those count as limited contact tasks.
Okay. What are some examples then of these allowed limited contact tasks?
Think about things like fixing essential weather monitoring gear, or maybe frost protection equipment right when a sudden freeze is coming.
Okay, time-sensitive stuff.
Right, or repairing the HVAC system in a greenhouse, if it breaks unexpectedly. Fixing other field equipment too, as long as it's not application or irrigation gear. Oh, and moving or maintaining beehives falls in here too.
Interesting. Beehives. Okay, so that's limited contact.
Irrigation tasks are tasks related to operating, moving, or repairing irrigation or watering equipment, and where early entry workers only contact with treated surfaces, including soil, water, surfaces of plants, crops, and irrigation equipment, is minimal and is limited to their feet, lower legs, hands, and forearms.
What was the second type of EPA-approved task?
That one is specifically irrigation tasks.
Back to the irrigation equipment.
Exactly. This covers the necessary work of operating, moving, or repairing irrigation or watering systems. Like the limited contact tasks, these jobs can't be delayed, and they only involve that same minimal contact feet, lower legs, hands, forearms.
So what makes them different from the limited contact category then?
The key difference is time. These specific irrigation tasks are ones that are expected to take more than 1 hour inside that REI area to get done.
Ah, okay. Because the short-term tasks we mentioned first had that 1-hour cap.
Precisely. So this carves out an exception for those necessary longer irrigation jobs.
Makes sense.
Under what conditions is early entry allowed for these work situations? There are specific conditions that must be met for early entry for short-term task, limited contact task, irrigation task, and agricultural emergency task.
Okay, so for all these situations where contact might happen short-term, limited contact, irrigation, and emergencies, there are specific conditions that have to be met, right?
Let's take a look at when early entry can be allowed based on conditions and task. If we look at our first condition, wait at least 4 hours after pesticide application is completed, early entry may be allowed for short-term task, limited contact task, irrigation task, and agricultural emergency task. Now, when our condition involves waiting until inhalation exposure level on the pesticide label has been reached or any WPS ventilation criteria have been met, we can early enter with short-term task, limited contact task, irrigation task, and agricultural emergency task. When our condition is the maximum amount of time allowed per 24 hours has been spent in the area, we can early enter with a short-term task limited to 1 hour, a limited contact task limited to 8 hours, irrigation task limited to 8 hours, and no limit on agricultural emergencies. In our next condition where early entry can be allowed for pesticides whose labeling requires double notification, verbal notification, and posting signs. If we look at short-term task, yes, allowed for all WPS pesticides. If we look at limited contact task, no, there is no early entry allowed. If we look at irrigation task, no, there is no early entry allowed. And for agricultural emergencies, yes, early entry can be allowed for all WPS pesticides. Again, on this chart, we're looking at conditions where early entry may be allowed. In our first condition, our hand labor task permitted. For short-term task, the answer would be no. For limited contact task, the answer would be no. For irrigation task, the answer would be no. For agricultural emergency task, yes, but must be related to the ag emergency. In our next condition, where early entry may be allowed, employer provides special protections for early entry workers regarding training, instructions, decontamination supplies, and personal protective equipment PPE. For short-term task, the answer is yes. For limited contact task, the answer is yes. For irrigation task, the answer is yes. And for agricultural emergency task, the answer is yes, early entry is allowed. In the next condition where early entry may be allowed, need for entry could not have been anticipated. So early entry for short-term task in this scenario doesn't matter. For limited contact task, early entry is allowed only if need could not have been foreseen. Also with irrigation task, early entry is only allowed if need could not have been foreseen. And early entry may be allowed under this condition for agricultural emergency task only if circumstances could not have been anticipated when pesticide was applied. And our final condition where early entry might be allowed, entry is not an economic necessity. If we're looking at early entry being allowed on these, with short-term task, it doesn't matter. With limited contact task, only if delay would cause significant economic loss. With irrigation task, only if delay would cause significant economic loss. And with agricultural emergency task, early entry is only practiced to prevent or reduce of substantial economic loss. And that brings us to our next important point. What are the special protections for early entry workers? Worker employers must provide the following additional protections to early entry workers who contact anything that has been treated with a pesticide. complete pesticide safety training, instructions and information, decontamination supplies, personal protective equipment, PPE.
So let's get into those special protections you mentioned. What exactly does an employer have to provide for these early entry workers who might have contact?
Okay, several critical things. First, they need full pesticide safety training, specific instructions for the task, and all the relevant safety info.
And we need to look at training and instruction. Employers must make sure each early entry worker is trained as a WPS worker before entering a pesticide-treated area during an REI. The 5-day grace period for training that applies to other workers does not apply to early entry workers. Employers must instruct early entry workers in a manner they can understand. How to put on, use, and take off early entry PPE correctly, about the importance of washing thoroughly after removing PPE, how to prevent, recognize, and give correct first aid for heat illness, too much heat stress.
And this is super important, that normal 5-day grace period for training workers. It does not apply here.
So they need the training before they go in?
Absolutely. Before setting foot in that area for early entry work. No exceptions.
Makes total sense. What kind of specific instructions do they need?
The employer has to tell them, in a way they understand, exactly how to put on, use, and take off the required PPE correctly.
Okay.
They also have to stress how important it is to wash thoroughly after taking the PPE off. And critically, they need info on preventing heat illness, how to spot it, what the symptoms are, and basic first aid for it.
Yeah, heat illness is a big risk, especially wearing PPE. What about info from the pesticide label itself?
Also required. The employer has to communicate the key safety stuff from the label. Human hazard warnings, first aid steps, signs and symptoms of poisoning for that specific chemical, exactly what PPE is needed for early entry, and any other safety rules on that label.
So really thorough communication is key. What about the decontamination supplies? What needs to be available?
Right, decon supplies. Employers have to provide enough clean water for routine washing and for emergency eye flushing. Plus, soap and single-use towels. Enough for everyone.
I just want to point out that as an employer, providing these decontamination supplies is not optional. This is something you have to do. You have to provide the water, soap, and single-use towels as the label requires. If you don't do this, you're not just in violation of the law, you're putting people at risk. If you don't do this, you're risking your reputation, but also you're going to get an overall negative view and perception of your company out there in the field.
Good question. They can't be in the area being treated, obviously, and ideally not in an area still under REI, unless, that's the only way to make them accessible.
Accessible? How close is accessible?
The rule is reasonably accessible, which they define as within a quarter mile of where the early entry workers are.
Quarter mile, okay.
Now, when it comes to these decontamination supplies, this is really common sense, as we just heard. Obviously, they don't need to be in an area that's going to be treated with pesticides. Then they're going to be contaminated themselves, and we defeated our purpose. As you can imagine, we're not going to want them to be located in an area under an REI, because then, once again, we'd be defeating our purpose. We're sending somebody back into an area under an REI to go get decontamination supplies, and they can be exposed during that time. The only exception to this is when that area is necessary for the supplies to be reasonably accessible to the early entry worker. So again, if you need to put them in there to be reasonably accessible because they don't need to be too far away, as we're going to mention in a moment, then it's okay. But that's the only time it's okay to have these supplies in an REI area. And again, our final common sense rule here is this area needs to be reasonably accessible and not more than a quarter mile away from early entry workers. So if it's more than a quarter mile away, of course, we're going to be in violation. But once again, a lot of the things we're learning here are common sense. You don't want these to be more than a quarter of a mile away because they're very important when they're needed. You don't need somebody having to go a long distance just to get these decontamination supplies. A worker-employer must provide each early entry worker with at least 1 pint of emergency eye flush water when the pesticide labeling requires protective eyewear. The emergency eye flush water must be immediately accessible. At the site where early entry workers take off their PPE, the worker-employer must provide soap, clean towels, and enough water to allow early entry workers, to wash thoroughly after removing their PPE.
What about specifically for eye washing?
If the pesticide label requires protective eyewear, then the employer has to provide at least a pint of emergency eye wash water for each worker. And it has to be immediately accessible right where they are.
Immediately accessible. Got it.
And one more thing on washing where they take off their PPE. There needs to be soap, clean towels, and enough water right there for them to wash thoroughly.
Okay, comprehensive decon setup. And the last piece of the protection puzzle is the PPE itself.
Exactly. The employer must provide the specific early entry PPE that's listed on the pesticide label, period.
They just provide it.
Provide it and make sure the workers actually wear it and wear it correctly while doing the task. Just handing it out isn't enough. They have to ensure proper use.
Wow. Okay. This has been incredibly detailed. We've really unpacked REIs and especially these complex exceptions.
Yeah, there's definitely a lot to keep track of.
So for everyone listening, trying to get this right, I guess the main takeaway is that dealing with these REI exceptions needs real care, real attention to detail.
Absolutely. You have to look closely at the type of entry, exactly what task needs doing, and then follow all the mandatory safety steps if there's any chance of contact.
And always, always go back to that pesticide label. That's your primary guide for the REI length and any specific early entry PPE.
Couldn't agree more. Understanding those specifics is vital, not just for staying compliant, but really for protecting the health and safety of the people doing the work.
Congratulations, you have completed the course. Please proceed to the exam to receive your credit.